Course outline for professional network engineer certification on Google Cloud Platform. In a high level, what they expect you to understand or you should know to clear the exam. Design, plan and prototype GCP network, and this is where you should know bits and pieces of how you can create a network inside Google Cloud Platform. How to implement the VPC, virtual private cloud, which is, you can think of private data center inside the cloud. So how you can isolate your resources, cloud resources, from the world. You configure different network services like DNS or CDN. How you should know how to implement hybrid connectivity, and this means you are connecting your data center with Google Cloud Platform. And lastly, the network security, how IAM rules and impact the ability for you to do certain tasks on the network. Let's get into details of what they expect you to understand session by session. So the first session is designing and planning prototype Google Cloud Platform. In that particular section, they expect you to understand designing overall network architecture, VPC, designing a hybrid network, designing container IP addressing, and plan for Google Kubernetes engine. And this is you can think of very overview syllabus which they expect you to understand. If I get into details of that, this is the home page of Google Network Engineer. The registration is not currently on. This is March of 8th. If I go in details on the outline, so this is the first section. So you should know designing overall network architecture, failover, options for high availability, and all of this. All of this is just basic concepts around the network. The second one is the VPC, and in here you should understand or you should know how to configure a VPC, or what are different meaning of, say, peering, routes, firewall, and all that. Third one is the hybrid connectivity. That's where you connect your own data center with the Google Cloud Platform. So using the interconnect, peering, IPsec VPN, cloud router, its purpose, failover and disaster recovery strategy, standalone versus shared VPC interconnect, cross organization access and bandwidth. And lastly, designing container IP addressing plan for Kubernetes engine. Why this makes really a big difference? Because the way Kubernetes or the container engine does its IP addressing is totally different than the virtual machine addressing. So we are going into or getting into that as a special section here in the first one. So that's the first section. That's where we will get into overview of all those bits and pieces involved in the network. Second one is implement GCP virtual private network, or VPC, and this is where you go ahead and do a VPC configuration, configuring a routing, configuring and maintaining Google Kubernetes engine cluster, configuring and managing firewall rules. So all of that. So it is all related to VPC. If I go in details, this is where you configure actual VPC. But majority of the theory is already covered in the earlier section. You can think of here in VPC. The next part is actually implementing, and this is more demo oriented. We'll go ahead and configure VPC, peering, and all that. Second one is how you configure routing, static versus dynamic routing, and all that. Configuring Google Kubernetes engine cluster. I will give you high level overview of Kubernetes engine first, and then we'll get into how networking work in Google Kubernetes cluster. The third section is configuring network services, and these are like additional network services which are available, and that contains load balancing, CDN, and DNS. These are the major services that are available at as a network services. And then enabling the network services. If I look at the detail syllabus here, you configure different kind of load balancers. So what are the purpose of different load balancer? We are going to get into demo section as well. That's where we will configure HTTP or HTTPS load balancer. We'll understand how intelligent routing works inside the load balancer, and how session affinity works or capacity scaling works. The second one is CDN, and this is where you can implement content delivery network. It is simple configuration, but we will get into demo section of this one, and we will try to understand overall foundation of CDN and how it does, how you can actually create a keys, how you do a cache invalidation, and how you can generate the signed URLs. So all of that in CDN. The next one is DNS, which is 100% uptime guarantee, or SLA. We will have a demo, and we will configure different zones or records, the security, global serving, any cast IP, all of that we will check, and we will go into foundation of what are the limitation of cloud DNS, and where do we use internal DNS and all that. So that's the next section, the next chapter. The last one is enabling other networking services, which contains health check, which is already there in the load balancer, but we will talk in the context of instance group, canary A and B releases, distributed backend instances using regional managed instances, or enabling private API access. That's the section 3, and this is, you can think of all the miscellaneous network services beyond hybrid connectivity or VPC. The next section is implement hybrid connectivity, and this is where you connect your own premises or data center with Google Cloud Platform. So configuring Interconnect, configuring site-to-site IP VPN, configuring Cloud Writer for the reliability. So all of this contains in the hybrid connectivity. The next one is the network security. That is where we will look at IAM, how you can configure IAM. We will get into some of the examples of IAM. Then we'll look at Cloud Armor, how you can actually protect your load balancer from outside world or attacks. Configuring third-party device insertion into VPC using multi-NIC, managing keys for SSH access. The sixth section is managing and monitoring network operations. That's where we will get into details of Stackdriver offering, managing and maintaining security, example firewall rules or routers, maintaining and troubleshooting connectivity issues, monitoring, maintaining and troubleshooting latency and traffic flow using different components. So if I go back here and go to monitoring and managing and monitoring network operations, the first one is logging, monitoring Stackdriver, how you can connect Stackdriver with your cloud resources and start monitoring or logging those network. Then we will get into firewalls and diagnostic, resolving IAM rules, maintaining and troubleshooting connectivity issues, and this includes each and every bit of your connections, like identifying traffic flow topology, draining and redirecting traffic flow, cross connection handoff for interconnect, monitoring ingress and egress traffic flows, monitoring firewall logs, all of that. And lastly, monitoring and maintaining troubleshooting latency issues like network throughput and latency testing, router issues, or tracing the traffic flow. And major, you can actually go ahead and use Stackdriver trace for your application latency as well. The last section is optimizing your network resource, and that contains traffic flow optimization as well as cost and efficiency. If I go back here, if you look at the traffic flow, it says load balancer and CDN locations, global versus regional routing, expanding subnet ranges, accommodating workload increases like with auto scaling or manual scaling. And the cost efficiency is like your cost optimization using specific network tiers, cloud CDN or autoscaler. You can do automation, you can use VPN versus interconnect based on which one to choose. We are going to see the table there to to identify which one is best cost effective solution for your use case, and bandwidth utilization for your resources. What we are going to do is we are going to go ahead and do a regrouping, and regrouping happens because even though the syllabus, if you look at it, is spread and distributed the same concepts in multiple, or same service in multiple sections, we are going to cover that in the same manner, but I'm just trying to consolidate the theory part together. So what I'm going to do is I'm going to consolidate these high level theory parts like setup and IAM into one, which contains going through the interfaces, consoles, SDK, permissions, and all that. The second is going through the foundation or understanding high level what are compute services, database services, and storage services. And the third one is actually the network service, which is like VPC, your private network onto Google Cloud Platform. And the last one is interconnect options, like how you can connect your own premises with the Google Cloud Platform. This is how I'm going to restructure it. We are going to cover theory as well as practical, majority of the practicals in those hotspot, but I'm going to give you complete understanding about the syllabus in this course itself. So what we are going to do is we are going to see different options for the same thing, like the connectivity between your on premises with the GCP. What are different options available? We'll learn basic concepts about those options. We'll run through console as well as CLI whenever it is required, and we'll have some samples so that you can try it. So that's all about the syllabus of professional network engineer. You can actually go to this particular link to understand more about Google Professional Network Engineer certification syllabus. That's it, guys. If you have any questions on syllabus, let me know. Otherwise, you can move to the next lecture. Thanks. Hello, welcome to this lecture. This lecture is a part of Google Cloud Platform certification training series for cloud architects, cloud designers, cloud developers, and system operations. Are you excited? We will talk about platform overview. And I think you should be enough excited to understand Google Cloud Platform in nutshell, right? So let's go ahead and get started. This lecture is a part of 2 lectures of platform overview. In this particular lecture, we will talk about Google Data Center, POP locations, network backbone, regions and zones, services offered, and GCP interactions. Why we talk about this? Because Google Cloud Platform, as you understand, it's a public cloud offering in the world, and using which you can provision all infrastructure resources using their tools. So before that, you have to understand how Google have their data centers, what are those locations, what are the high level concepts to divide the region, or you can think the geography into region or zones, right? What is the network backbone? So let's go ahead and understand some of those in these 2 lectures. Let's talk about Google Data Center. Google data centers are somewhat different from any other data centers in the world right now, and these are some of the highlights which you can think it is different from others. First one is renewable energy. So what Google has done is they have signed a long-term contract with the renewable energy companies to use their electricity from renewable energy resources for their data centers. And you can think of this is one of the good objectives where Google says after some years they are going to completely move their data centers operation onto renewable energy. The second one is the efficiency of data center. You can think of when they have considerable amount of experience in building the data centers for their existing YouTube, Google search, all those apps like Gmail uh, or Google Drive, right? So they have experience, a considerable amount of experience in the data center operations. What they have done is, with their machine learning experiences, they have learned that if you raise the internal temperature up to 70 Fahrenheit, there is no problem. The performance of the hardware goes higher, not the lower. The life of hardware is really good. And when you hit to like 70 Fahrenheit and more, ultimately you do not need heavy cooling air coolers inside it. You can live with outside air temperature for cooling the inside hardware, and that's how they use it. They build the custom servers, so they don't just procure the servers from the market and use it. They are not hardware manufacturer though, but ultimately they purchase CPUs, RAMs, and all whatnot, right, which is required to build a server. And they know what type of servers they will need to build it for their own data centers. And based on the research which they have done, they build their own custom servers. And in fact, they build their own rack. The way they organize the data, they build their own network infrastructure, right? So uh, that's how they know how to take advantage of efficiency of those servers and the network. Data and security, and this is one of the most or prominent aspect which enterprises look for. Typically, when the data is stored, where it is getting stored, and what about the encryption, whether someone gets access to that particular data, whether they can read it or decrypt it, right? So data in rest and data in transit, both kind of encryption is very much important for any enterprises, and that is what Google provides. um, and as well, like physical data center security, like there are some locations or data centers people don't even know where they exist, right? In physical world. So they sometimes take that thought as a not to disclose the data center location to anyone, right? So if you look at, there are number of data centers across the world, and this is the map as on today, January or February 2019. These locations, you can think of all the blue locations. Those are the location currently exist, and they are planning to enhance. These services are getting continuously enhanced. They are continuously adding the data center locations across the globe. Zurich or Osaka or in Jakarta also, they are planning to have additional data centers in 2019. They divided the whole region, the whole geography into multiple regions, and that's how they have divided this in 18 regions. These actually, the services are accessible through 225 countries and around 100 plus point of presence. We'll talk about that later, but this is the overall map of data centers they have it. Let's talk about point of presence. Point of presence, the location in which you can have the connection available, or you can connect to the data Google's fiber optic network. If you look at here, the blue ones is their own network, and you can think of this is exclusively used for their existing services like YouTube, Google search, and whatnot. So all these blue network, this is their own network. But at the same time, what they have done is they have made investment, and these are like shared investment cables, marine cables. They have invested the money into that as well. So these are like partial ownership, plus blue ones are like full ownership by themselves. And looking at this particular the network, you can think the amount of scale they have for fiber optic network, like having services in one particular location, like in US, if at all there are services installed, and if that is something accessed from Asia or Europe, they have fiber optic connectivity, and the traffic travel to their own fiber optic network and to the nearest point of location. So this is the network. These locations, you can see they connects the dots or the fiber optic connections. These are the POP locations for any customer to connect to the Google Cloud platform. There are some of the top locations which support CDN, right? And this is again a part of network where the caching happens for the customer data. If you understand the concept of CDN, the concept is usually if at all you have some images, right? Or the static content, which based on the request, it is accessed from the backend services or your servers. Rather than if that data is not changed frequently, what you do is you ask for the caching for those information to near to your customer, and that is the CDN concept. These are the top locations or the locations in which they have CDN support. So if at all you are accessing the services from US or the servers from US, even though that is not even the case, we'll talk about that, how you provision services near to you. But consider that example, right? Your server from US in India or in Asia, your not all the time the service will go to backend to access one particular photo or your profile photo, right? It will come from your nearest location to you. That's how our CDN work, and they have support for around 80 plus locations across the globe, and they have partners. So it's not only these services only providing CDN, but they have partners like Equinox or some other companies. They provide CDN locations, and that is some spanning across 500 or 600 plus. Regions and zones. Uh, as I said, they have divided the complete geography in multiple regions. So the region is independent geographic area that consists of zones, right? The main purpose of region is to host your application near to your user, reduce latency and availability. Let's talk about it, right? The region is the area divided into, it's an independent unit, you can say, of the complete geography of the world. And in that particular region, if you are hosting the services, it should be redundant enough that if one particular location goes out, you can switch back to the other location, but your traffic stays in that particular region or physical area, geographical area. So zones are like independent physical locations. You can think or map this to the data centers, and in one particular region you have either two or more zones, and that's where the services are hosted. So if at all the connectivity to say zone A goes out, the zone B is available for your customer to service, right? And that's where the concept of zone is there. So it is zones are independent physical locations within a region. Region is just a boundary defined so that your services are load balanced and high availability is maintained within the region. Here is the list of the regions plus zones in as per current, like January 2019. You can think Asia East 1, Asia East 2 is these are the regions, and in which you have zones A, B, C, A, B, C, and likewise in US Central you have multiple physical locations A, B, C, and F. So when we look at a Google Cloud Platform, we are more drilling down into the actual services or the resources, right? These resources, anything, right? Like your virtual machine or database instance or your IP addresses, all of these are network and somehow computing components, I would say. These components are either it is in global in nature, means accessible across all the regions and available across all the regions. There are some regional resources only stick to that particular region, and there are some zonal resources like physical, actual virtual machine sits inside the physical location, and that is, even though it is accessible from all, but it has presence in one particular physical location. And the example I said, virtual machine or VM disk, those are the zonal resource. If you go out, if you look at the static IP address, that IP address is specific to a region. So it is not a global resource. It is specific to a region. And then you have the network, right? The complete virtual network. If you want to create a virtual network, virtual private network into GCP, that span across multiple regions. So that is a global resource. Disk images, global resources, because image is a service, and you can access any disk image from anywhere. The snapshot, whatever you store it, that is a global resource, and your definitely firewalls and all those defines a particular physical locations and the rules around it. But these are so the resources are either tied as a identified as a global resource, as a regional resource, or zonal resource. GCP services in a high level, right? So they have the services from infrastructure as a service to software as a service. So let's talk about what are those in nutshell, right? If it is infrastructure as a service, this is traditional data center model, right? Where you have servers, machines, CPUs, network interfaces, and everything, and you manage the software and platform around it. So the virtual machine typically is a computer on the cloud, and you can think that as a infrastructure as a service. You connect, you have your hardware like disk. If you provision a disk to store your backups, right, that becomes an infrastructure resource. Or you want to have 32 CPU plus 128 GBs of RAM in a particular virtual machine, that also become infrastructure as a service. That's where you manage, you provision those resources and control those resources in terms of usage of that resource, the disk and everything, right? If you go from the left side to the right, your operational overhead gets reduced. So if you look at the platform as a service, that's where you will have the ready-made platform which you can provision it, and you can just deploy your applications onto the platform, right? And in that case, you don't have to manage the actual hardware, but you are managing the instance, you are managing the cluster. It is not the actual hardware, but it is on top of that particular actual hardware. Google takes care of managing the actual hardware for the cluster, but you manage the performance of the cluster, and then you provision the cluster resources, right? If you go to software as a service, that's where you move towards more and more serverless environment. You don't even care about the cluster, provisioning those cluster or the resources for your applications to run. What you do is you typically just push your code or application to the platform, and platform start just running it. You are not worried about how much the cluster size is, or how many virtual machines you are using, the CPUs and all that, right? You're just careless about it. You just use the resources and do all other application level access permissions and all that. So that is purely so from left to right is purely a moving towards no operations kind of work, where left you are managing so many resources, and that's where IT operations come in. Then you have system operations, which is in between platform and infrastructure as a service, because IT ops major towards is when you are owning your own data center, right? SysOps is you have the resources available, and you are just managing, connecting those resources, managing operations around it, and this onwards up to no operations is what the public cloud environment is. DevOps, you are just utilizing existing cluster and management, and provisioning the resources based on its requirement. And ultimately, no ops means they have App Engine, right, as a resource. You just push a code, and the application will start running, and you are least bothered. You don't even know what are the resources which are running inside it. You are just build based on the traffic or the consumption of different hardware resources for those services. So in nutshell, we are looking at a different kind of resources, and typically if you look at IT organization, what they use the compute resources, and in typically we see a virtual machine or your server, right, a physical server, that is your compute resource, which is doing manipulation, calculation, accessing a database, and serving your customers. The second one as a resource is the storage, and compute and storage is typically only two resources which typically IT needs it. If you look at, or business needs it, sorry, IT is not the right word. IT needs, on top of it, IT needs, there are so many services, and we'll talk about it. So data is what the business needed as and when they want to have it, processing of that particular data and serving that data to the customer, right? and that serving is handled by the compute services. But to have either the data or the compute resource available for a user to access it, you need to have a connection, and you need to have control on that particular connection. And that's where Google's networking service comes in a play, and you have multiple options to use it. Beyond or on top of these three core services, you need to have identity and access management, so that resources are accessible to the person who needs to have access to, and all other people should not be able to access it. There are big data services, and this is another benefit from the Google Cloud Platform. They are very innovative in developing the data solutions and the big data work. They are really good at machine learning. And we understand more about it, how you can use the machine learning. But these are the core services you can think of, which enterprises use it as their own data center, install the software, have the hardware. Besides that, there are other management tools which are available for anyone to use it. It's like Stackdriver, offering like monitoring of IT resources and application resources, logging, error reporting, trace, like that, as well as the developer tools. So having all that information infrastructure available, how you will use the APIs inside your the applications, and that's where developer tools comes in a play to help any enterprise to build the service or use Google services inside the applications. Besides that, they have come up with another service offering. Google Cloud Endpoint was the only offering which they had it earlier as an API management tool. We'll talk about what is API management, and we'll get into how it benefits customer doing the API management. Last year, they have acquired a company called Apigee, and they were very prominent in doing the API management. So using Apigee, you can do API management, monetization, analytics, and whatnot. But it's not a marketing page, but we'll look at it. What is that? If at all you are moving to a public cloud environment for the first time, or you are having connection between your own data center because you have some services which you want to keep it in your data center, and you want to connect to Google for elasticity, then there are these data transfer services which they have created. And I think Google Storage service and BigQuery data transfer service, I have not seen this 2 years back, but this is available right now for customer to use it. That's it, guys, for this particular lecture. We will get into more details of resource hierarchies, projects, quota, infrastructure services, and different type of accounts, as well as pricing in next lecture. Thank you. Google Platform Overview, Part 2. In this particular lecture, we will look at resource and its hierarchies, projects, quota and limits, infrastructure services, GCP accounts. There are different type of accounts. What are those? And pricing. So in nutshell, what is resource? A resource is any component. As an example, virtual machine is a resource. Disk attached to that particular virtual machine is a resource. Or the network component in which the virtual machine is hosted is a resource. Your firewalls are a resource. Your database is your resource, right? All of those are resources in GCP. And those resources are organized in hierarchy manner. And we'll look at that. What is the hierarchy, resource hierarchy. Typically, if you look at any organization, the company has got multiple departments, and individual department will have some products like product 1 and product 2 here, but it could be anything, right? Whether it is a unit of that team, or whether it is unit of the department, or directly department requires the IT resources. So it could be anything. You can mix and match any hierarchy, you can create it. This is a part of, so organization and folders are a part of G Suite. We'll talk about that in subsequent lectures, but G Suite maintains organization and folders, and project and onwards, you can control that in Google Cloud Platform. So you already have organization built here in G Suite, and you do it. It is not mandatory though. If you want to build it organization, you can do it there, but you can have your individual accounts for a different project, different departments, and they are maintaining their own resources. But there are some restrictions, and we'll talk about that, how you can share the network and like that. Okay, but typically your resources are um, allocated to a project, and ultimately using project you can provision the resources. That's the container for your cloud resources. Hierarchies. So you want to implement, the way you want to give access to a different team or applications to different applications, and that is built out of identity and access management. But as well as you want to have the resources, the billing, right, which goes from top to up, right, where you want to bill it, whether you want to bill it at the project or you want to have the billing account created, taking say 4 or 5 different departments together, that you can define it. And the roll up happens from bottom to up for the billing. So typically identity and access management will happen from top to bottom. So if a particular person has got access to a project, all resources inside the project that person will have access to. But there are fine-grained access control which will need to enable for that particular person. But the way it works is IAM is top to bottom and billing is bottom to up, wherever you define it. There are policies in IAM, and we'll talk about that later, but the policies are the set of resources applies to rules or members. Resources inherit policy from its parent, as an example. So all these resources inherit properties from the parent, which is like project. Policies are union of parent and the resource. Like if at all we are talking about one particular person having access to App Engine, then those like union of what project has it plus what permissions or in terms of role has given to a particular person. If the parent less restrictive overrides more restrictive resource policy, as an example here, if the person has got a create resources policy, I'm just giving an example, create resources at the project level, but you can restrict whether he can create an App Engine or not, right? And that's how the hierarchy or hierarchy of IAM works. For the billing though, usually organization is the full container of all your resources inside it. Project is typically usually you will have the billing happen at the project level and not at the product level, but you can have one billing account created and taking the pay, talking about aggregating the payments for multiple projects. IAM role hierarchy, as we said, it's a top to bottom. There is nothing much, but just elaborative how and what you can do. As an example here, organization admin have full access over all the resources. Organization viewer view access to all the projects. Folder admin create and manage different folders. Folder viewer can only view the folders. Project creator can create a project, and resource roles like individual resource role here. So we saw there are some resources which are zonal, regional or global. Typically, if we carry that over here, typically the instances and disk are zonal, external IP at the regional level, and images, snapshot and network, it is at the global level. Typically, your billing happens for all those at the project level, billing and reporting at the project level. Typically, GCP resource manager. GCP manage means resource manager manage all the resource which is depicted here. Like this is the resource manager's work to maintain this hierarchy. So it is centrally managed hierarchy, centrally manage and track all your projects, manage IAM across your organization, manage organization and organization policies, create and manage cloud IAM policies, cloud console and IAM access, and manage cloud folders. And this is a part of resource manager. Service account. So you have two type of accounts in Google Cloud Platform, and we'll talk about service account later in one section. But in a high level, a service account is the account which is used for application to application access. As an example, right? Virtual machine wants to access GCP resources, cloud storage resources like images from cloud storage, or write images to the cloud storage, right? We will have a service account created which will be used by application inside the virtual machine, and that account will have access to the cloud storage. And this is fine grained, and you can define what that particular service account can do or can't do. And definitely this isolates the user level permissions, which is like user, if a employee leaves the organization, right, or a employee move from one organization to another organization, another department within an organization, then you don't want to go ahead and switch all those permissions to the new employee. It's additional work, right? So instead of that, if you use service account taking care of all application to application level communication, you are careless, like whether an employee joining in or leaving the organization. Used based on secure token, and there are three type of service accounts in nutshell. You can create your service account. You can use built-in service account for virtual machine and app engine, and used by Google API internally. So typically, these accounts are used by APIs. Now the service account which is used by API, you don't have any visibility. It is just created in the platform to use it. And we'll talk about that in demo section. When you open or enable the API access, how you get the API access using the service account. GCP project, as we already understand, project is a container for all your resources. Project takes care of billing for all the resources within that particular project. So what project does in nutshell, it tracks resources and its quota usage. You can have billing on those resources. You can manage permissions and credentials, and you can enable and disable API and the services within the project. Project use three identity attributes. One is project name, project has got a number, and project has got a identity as well, ID. You can interface with using Cloud Console or a resource management API to the project. Cloud resources and quotas. So typically, if you look at you want to have some level of quota or limits for your cloud resource, because what we understand that the cloud resources are infinite in nature, right? You don't want to see surprises in your cloud bill on a monthly saying that this is not the case, but your the revenue is say $100 and you got $120 cloud bill, right? As because you can go and use as much as you want. At the same time, you need to make sure that your IT spends are controlled. It is not actually intentional, but someone is monitoring your quota, right? And that's where you have quota and limits for those resources. So quotas are typically controls the budget. It limits your resource utilization at different levels, and you can definitely increase the quota if the organization is big and you need multiple resources. You can increase that quota. There are some limits which are enforced in GCP, and those limits you cannot increase. So that's the difference between quota and limits. So typically the limits are, you can think of platform limitations, and quota is something constraint which is put forward as a recommendation from Google, but you can still request for the quota to be increased, and Google will look at the different use cases and will enable additional limit, increase the quota for you. Project quotas. So typically the resources are subject to project quotas. How many resources you can create per project, how quickly you can make API request in a project, like rate limit. Some quota limits are applicable for region and zone as well, and you can increase this quota, as I said. The example of this quota is you have 5 network per project and you have 32 CPU per region, right? As an example, but these numbers may change when you see this particular, you know, a slide deck or training. GCP infrastructure management services. Typically, if you look at any cloud offering, right, or your own on-premises data center, or you procure any data center services from any other service provider, you will need to organize these resources. You will need to have the network, but you will again need to have some way of interfacing it to your resources, right? And that's where infrastructure management service comes in a play. You will have resource management manager, which organize your cloud resources in projects, folders, and ultimately individual resources. You have IAM, which is using which you can have fine-grained access control across all the resources. You can have audit also set up, or logging also set up on IAM, so that you see who is accessing what services. These are the services which is provided under Stackdriver as an umbrella for monitoring, logging, tracing, debugging, and error reporting. There are some CI/CD applications, or to make your deployment easy, you have deployment manager. You can just set up template, and you can create your own infrastructure. And then you have storage and scaling, right? Auto scaling or pub/sub. These are the additional services. Auto scaling actually makes the services elastic, in which usage of the virtual machine CPU goes certain 80% or 60%. You can configure a rule to spin up multiple of those virtual machines, and your service SLA is not hampered. So these are the infrastructure services which are available for Google Cloud Platform or any other service, any other cloud platform providers. Interactions. So how do you interact with the Google Cloud Platform? There are typically three ways you can interact with Google Cloud Platform. One is using UI. So you can just go to GCP console, log in there, and then just start provisioning the resources, or you can view the resources. Second option is command line interface, or CLI. You can install that in your computer, or you can go to Google Cloud Platform and you can spin off cloud shell, and you can interface with the cloud. And the third option you have is the endpoints or REST libraries, right? You can interact using the REST endpoints, and each and every activity which you do it using CLI or the console, you can do that with the REST APIs. You can use simple call command or postman to call the REST API, and you are done. You can provision the resources, monitor the resources using the REST API as well. So that's all around different aspect of Google Cloud Platform. Please let me know if you have any questions. Otherwise, we'll get into the next lecture, which is different certifications available on Google Cloud Platform. Let's understand what are those, so that we will focus on what is that it is that we need to focus on this particular training. Okay, thank you. In this lecture, we are going to see how you can get the free trial and $300 credit for Google Cloud Platform to try different services while learning Google Cloud Platform. If you go to cloud.google.com/free, you will actually get this particular UI, and you can find $300 credit, which you will get it or assigned to your account once you enable. Here you will get actually within my console, or you just need to log in here, and once you log in, you subscribe for 12 months credit, and you will be able to use $300 credit. If at all you are using it for this particular course or any course, $300 is almost sufficient. You just need to make sure that you when your lab is done, you need to delete those instances, those services, whatever you provisioned it. If at all you have stored the data on Google Cloud Storage, you just need to delete that particular data. That's how you will not be charged continuously. So you'll get $300 as a free credit, which you can use it for any paid service on Google Cloud Platform. There are always free products, and you can explore that as well, like instance hours per day. You will get 28 instance hours per day. Like you can launch 2 different instances and use it for say 14 hours, and it is going to be free. 5 GB of cloud storage, shared mem cache, search. And so if you look at all these are different services, and the free credits or free tier associated to all those services. These free services will not be considered under $300. $300 will be used only for the service which does not have free, or you have used the free tier and then you are using it more than the free tier. That's where your $300 is used. Majority of the cases you will be charged up to say $100 typically in 1 year, but this is, just keep in mind that this is for 12 months. After 12 months for your account, this will not be carried forward. So if at all you want to try and use it within 12 months, you can just go ahead and use it. But just keep in mind that these free tiers always available to you beyond your free period. Okay, that's the $300 or free trial subscription on Google Cloud Platform. If you face any challenges, there are a really good amount of help available there, but you can let me know if you have any questions while subscribing it. Otherwise you can just move to the next lecture. Thank you. In this section, let's go ahead and understand what are GCP interfaces which are available for you to use it. These interfaces, which means how you can interact with Google Cloud Platform using which tools. So the first one is Google Cloud Console, and this is the UI or the front end, which is web UI, or the mobile app UI, using which you can interact with the Google Cloud Platform. We are going to get into details into this section, but that's the first one. The second one is command line interface, where you use your gcloud command or BigQuery command or gsutil command. So that is your command line interface, and in that command line interface you have 2 different utilities which you can use it. The first one is Cloud SDK, and the second one is Cloud Shell. And the third one is API libraries, and these are the REST endpoints which you can use it to call from your programming interface. You can include that into Python or Java or any other programming interface, or you can use a Postman to hit a REST point URL, or you can use the simple utility called curl to interface with the Google Cloud Platform. So this is typically API and primarily used inside your programming language. So if you divide the whole aspect into the list, the first one is the console. Console again has a mobile app, so that is again another interface. There are plus and minuses in this too. The third one is Cloud Shell. Again, the interface, command line interface, SDK, command line interface, but this gets installed on your laptop or computer, and we need to actually go through the installation step for SDK, and we are going to do that in the next section. The Cloud API, and that's the command line interface. It is, you cannot just interact with Cloud API using your command line. You can do that with the curl utility, but that's not the whole purpose of Cloud API. So let's go ahead and understand the Cloud Console in the next chapter. Thanks. Cloud Console, this is the interface which you can use it to interface with Google Cloud Platform in the UI format. And here I just logged into Google Cloud Platform with my trial account. And if you come here, this is your home page. You will get the complete summary of what is available and what is not available. You can see the project information, what is the project, and all of that. We are going to see it anyways, but you'll get the project information, you'll get the resources information. So currently I have 3 versions of App Engine, 1 cloud storage bucket, 1 BigQuery dataset. You will have the traces if at all you configured it, and then there are kickstart guides or getting started guide. You can do API Explorer, you can go ahead and run around APIs, you can test those API, you can deploy pre-built solutions like Cloud Launcher, you can do monitoring, you can take a quick VM quick start, you can actually just go ahead and launch the VM or cloud function. So this is the getting started or quick start guide. Here is the API response that are available, whatever APIs which we have requested, and here are some dashboards which are available. Currently my app engine is not running, so you do not have any request responses. The status, if you go here, it says all services are normal. You can actually switch to dashboard and you can see if there are any disruptions. You can think there are some issues here, right? On 20th and 23rd, 22 to 23rd, but this is the whole dashboard which you have it. You can access billing and manage billing out of Google Console. You can do error reporting, and if there are any news out of Google Cloud Platform, and documentation. So this will point to the documentation. If you go here, if you click here, you can go to any services which you want. As an example, you can go to say compute engine resources and you can launch VM here, right? Or you can go to billing, you can manage billing, you can set up alerts, and all of that configuration you can do that from here. And we are going in details of all this in subsequent sections, but using Google Cloud Platform Console you can launch, decommission all those services, and it is very user friendly and you can access it through UI. So this is Google Cloud Console. So here are some of the features. It's a web admin UI. You can do resource management out of UI, DevOps on the go. So it has got a mobile app, but we are going to see that in separate chapter. You can do secure administration out of console, and you can get the data insight. We saw, your error reporting or the latency, you can get it out of Google Cloud Console. And here are some of the list which is there in the Google documentation as well, which you can go through. That's it for Google Console. I don't think there are so many questions out of Google Cloud Console. This is for your information. Thank you. Cloud SDK. Cloud SDK actually it's again a CLI, command line utility, and this does gets installed onto your laptop. So it is, you can think of shell in your laptop. We are going to install Cloud SDK in the next section because it is required as a part of this particular code structure or the certification. So Cloud SDK, typically it's the utility which you install on your laptop and do so many things with Cloud SDK. Let me go back to the documentation itself and show you. Where is my console? Yes. Cloud SDK. Okay. So using cloud, and this does gets installed, as I said, you can do Windows or Linux installation. But once you install, you will have all the capabilities of your Cloud Shell in your own laptop. Okay. So the high level tool, gcloud, inbuilt inside Cloud SDK, gsutil for cloud storage. You can use it from SDK, so you do not need to install anything else. BigQuery tool, kubectl for Kubernetes cluster, and it does get integrates with your PowerShell command, so you do not need to install any other environment. It does comes with the client libraries, cloud client libraries or API libraries, which you can directly use it, or you can optionally install some other component which you need it. But this has got ready-made tools, these tools, and you do not need to manage anything outside it. We are going to get into demo of this, how you install it and how you can initiate a particular project, or you can create a default environment with authentication in next section for the Cloud SDK. That's it guys for this particular lecture. If you have any questions, let me know. Otherwise, you can move to the next lecture. Cloud SDK. Cloud SDK actually it's again a CLI, command line utility, and this does gets installed onto your laptop. So it is, you can think of shell in your laptop. We are going to install Cloud SDK in the next section because it is required as a part of this particular code structure or the certification. So Cloud SDK, typically it's the utility which you install on your laptop and do so many things with Cloud SDK. Let me go back to the documentation itself and show you. Where is my console? Yes. Cloud SDK. Okay. So using Cloud, and this does gets installed, as I said, you can do Windows or Linux installation. But once you install, you will have all the capabilities of your Cloud Shell in your own laptop. Okay. So the high level tool, gcloud, inbuilt inside Cloud SDK, gsutil for cloud storage. You can use it from SDK, so you do not need to install anything else. BigQuery tool, kubectl for Kubernetes cluster, and it does get integrates with your PowerShell command, so you do not need to install any other environment. It does comes with the client libraries, cloud client libraries, or API libraries, which you can directly use it, or you can optionally install some other component which you need it. But this has got ready-made tools, these tools, and you do not need to manage anything outside it. We are going to get into demo of this, how you install it and how you can initiate a particular project, or you can create a default environment with authentication in next section for the Cloud SDK. That's it, guys, for this particular lecture. If you have any questions, let me know. Otherwise, you can move to the next lecture. Google Cloud Shell is the shell which you can use it out of Google Console, and this is another interface, and it's a CLI, it's a command line interface. Let me go back and show you from where you can launch on the shell. This is my console. You can just click this particular button to activate a shell. So it's getting provisioned. So now shell is launched. You have all those utility which are required to interact with the Google, like gcloud command. So you have gcloud command, you have BigQuery, you can BigQuery, you can do gsutil, and this is for cloud storage bucket. So you have everything installed in your console, and this is very good to get it started. If you do not want to install Cloud SDK, this is the first thing. If you want to interact or try your Google Cloud Platform commands, you can actually go ahead and open this in new window as a full screen mode. You see that in full screen, or you can actually you can customize this terminal. You want to have different colors, right? Or fonts or something like that. You can add additional sessions. The good part of this one is, if you install or run your local application here as a sandbox, you can actually see the web preview from here, right? If you click here, and I don't have anything running right now, but I can click on this and just you will get the response from here. I do not have anything currently running, but you will see this when we have a App Engine demo. So that's the Google Cloud Shell. Some of the features you can do. It's an admin machine. You can think of, you can't actually use it for your own application deployment. You'll have full power or access from anywhere. secure and fully authenticated, pre-installed and up to date. So all the libraries which are there, which you are using, including gcloud command, everything is up to date. It is developer ready, and it has got a 5 GB persistent disk in it, so you can store your local file. And you can already see that there are some of my folders and directories which are lying there for my demos. It's a web browser access. Using the web browser, you can run commands, so you do not need to install anything. It comes with 5 GB persistent storage. It is secure. Unless and until you log in, you will not be able to access it. And you will have all the developers tools which are required to deploy any applications into Google Cloud Platform using Cloud Shell. So if you look at what it provides, you will have shell interpreter, bash, sh, Linux utilities to install libraries if you want to have it, cloud SDKs, so gcloud, app engine SDK, and it's a sandbox, GS util, text editors, you have Emacs, Vim, and Nano, build packs, Gradle, and all those. These are already available out of the shell, which you can just go ahead and use it. And this is, you can think of, it's like command line interface just to go, right? You can go ahead and do one thing here. If you come back again, you can actually do the Explorer, file explorer, and this is, you can think of Windows Explorer like field. So all your directories will be listed. You can even create your own files here or modify the files here, right? And you can go and save the files. So this is, again, if you don't want to play or you don't know how to use the Vim or Nano, you can actually use this browser as well. But I do not prefer this as much because I just like Linux command line utilities to edit the files. That's it for Cloud Shell, guys. If you have any questions on Cloud Shell, let me know. Otherwise, you can move to the next lecture. Thanks. Cloud APIs. This is, you can think of, you can use it while in your programming, and it's a REST endpoint. It's a REST API which you can use it. Let me go to the console and show you how you can explore different APIs. Let me go back. If I go to the Cloud Console as a home page, you can go here, explore and enable APIs. And here you will see what are APIs executed in your duration. This one, you can actually change that duration or download those transactions. But let me go ahead and show you one example. I went inside Compute Engine APIs. In here, you will get the information, how many usage for your Compute Engine APIs. But you can go and try in API Explorer. So here, this is a sandbox. You can try different APIs. I can go here and let me try one Compute Engine instance create. So instance list, let me try this one. So what it needs project ID and the zone. Let me go here and get my project ID. This is my project ID. And zone, which zone I am referring, and I just need to put any zone. I'll just give US underscore hyphen east 1 as a zone. So it'll ask me permissions, which user, what it says, unknown zone. Okay, let me give 1A. I just gave the region US East 1 B. It says unknown zone. Let me go here and see if I have any virtual machine running there. So it says US East 1B, just copy paste. So here you go, the outcome, the instance name, what it's kind of compute instance 1, it's a name, and it will give all the details of IP addresses and all the information. So I have this IP address. And so API Explorer is really a good tool to explore these APIs, and you can query it and you can get the information out, and you can see the sample outcome. This is what you will get it in your programming interface, and this is the API request which you are putting it. That's the Cloud API, guys. If you have any questions on Cloud API, let me know. It's a programming interface. That's what you need to remember. If at all you want to try it, you can use API Explorer. That is another reminder. And if at all there is any questions, it will be around this one for you. If you want to try, say, REST endpoints, what is the option which you want to use it, right? And API Explorer is one of the option that you will get it, which you need to select it. That's it as the interfaces, guys. We are going to get into Cloud SDK installation in next section anyways. But if you have any questions on theory part, let me know. Otherwise, you can move to the next section. Thanks. Chapter 1.1, Designing the Overall Network Architecture. In this chapter, we are going to get into overall design aspect of network, and those aspect contains failover and disaster recovery. That is our first point. High availability, DNS strategy, business requirement, how you can map business requirement with the requirement with the SLA or SLOs, or you can think of network, meeting your SLAs, load balancing, optimizing, quota, hybrid network, identity and various security aspects, various clouds, and microsegmentation. Let's go ahead and start with the failover. So what is failover or disaster recovery? Failover means, so if one of your service is failed, what is you want to actually do with that? How you can actually make sure that the service is started, your business is not much impacted or not impacted at all because of your failure in some of the services in the backend, whether it is application server, whether it is database server, or whether it is web server. Your database, as an example, if your database is failed, then how you start a new database, or your cluster failed, what is that you want to actually do it or take it forward. This has got a complete strategy, how if something goes wrong in your system, how you can still continue serving your business, and that is what it is called as a failure or disaster recovery strategy. We are going to focus into much more into the context of the cloud here, and in Google Cloud especially. If you look at this is very simple case here. You have your consumers, like whether it is website or applications, mobile applications, they are accessing your services from the backend, and those backends are accessed via load balancer. So this is your load balancer here, right? And then load balancer is toggling between or sending the request based on the intelligent routing, and we are going to see in detail how load balancer actually does this to either zone 1 or zone 2 or region 1 or region 2, depends on where the customer is or the consumer is. So typically, if you look at in the Google's context, these zones or the regions are connected with their own private fiber optic cables, and this is across the globe. Okay, and all these data centers serving your data is actually connected to your load balancer, and this load balancer is global in nature. It does not actually sit inside one particular region or zone. So it is a global service. It is managed service from the Google itself. What happens is, if as an example, one of your zone actually, or the region itself. So region is logical grouping of the geographical location you can think of, and there are multiple zones inside the region. So either your region actually goes out, or zone, a particular zone goes out from the service. That's the physical location. Then your traffic is still served by another zone, another region, and that is where you can think of how you can manage the disaster recovery. But ultimately, you need to have a plan. You need to plan your services hosted in multiple zones or multiple regions, so that you can still go ahead and serve your customers. And this is, you can think of failover strategy or disaster recovery strategy. But there are, you can think of a different aspect how you can make sure that if something goes down in, say, zone 1 or region 1, and these instances are not accessible, right? How you can still serve customers without impacting them. As an example, if there are some sessions which are currently serving to a customer, and you have a state somewhere in your virtual machine, right? If that particular virtual machine or the zones goes down, what happened with that particular state, right? So you need to have a strategy to hold that particular state in persistent store somewhere, and you can use data stored or any other persistent mechanism to store your state, so that your customer is not actually seeing that happening. And this is very important. So for all the different level of your disaster recovery or failovers, you need to have a different strategy altogether. But this is in a high level context. You have a load balancer actually takes care of making sure that it will send the request to the backend instances. Only the healthy instances will be served. So, and this is a part of load balancer configuration. You configure health check also inside it, and that's how the request is routed to the healthy instance in the backend. So you need to have a considerations and examples here, like if your cloud SQL goes down, what is that you want to actually make sure, right? So one of the primary instance or master goes down in cloud SQL, like MySQL primary or master instance goes down. What do you do, right? So in cloud SQL, you have HA configuration. You can have high availability configuration in different zone altogether, and so that if the master goes out or the complete zone itself actually vanishes or disappears from the network, you can still toggle to the HA instance, and this does automatically by Google Cloud Platform. You can also have read replica, and you can actually promote read replica as a master, and you can do that. That is another way of actually doing it, but there are multiple ways in multiple services which you can make sure that the service is available. And if, say, backend processing or the virtual machine fails, then what is your strategy? That is again depends on what is that particular service is. As an example, if your virtual machine goes down, whatever processing which was done by that particular virtual machine, if that is very important for your customer and for your processing needs, then you need to store that data into either the cloud storage or any persistent storage. As an example, you want to save a game state. If you know that your customers are playing game and then you are maintaining the game state, then you want to store that particular game state in some persistent store like cloud storage, right? And that's how, if another machine comes up as a replacement of that particular virtual machine, then that machine should be able to serve the customer looking at those game state. So there are different aspect of failover and DR which you can implement it based on need and based on type of service for which you are creating a failure or disaster recovery. Definitely persistence is very important. You want to store that particular state in somewhere, so that if another instance come up, it can be actually processed from that particular state and onwards to your customers. So typically you need to have a disaster recovery or failure document, as well as the configurations, right? If at all something goes wrong in your system, you need to make sure that everything is intact. Your customer is still served based on your disaster recovery plan. Like if zone 1 failed, then you have zone 2, or one of the instance in zone 1 failed, then you have additional instances created out of it, we are going to see in detail, in fact theory as well as the demo, how you can actually fail over different instances. But that is a part of network, and you should be concerned about it, and you should make sure that you have written documents and you understood what services we are using it from the Google Cloud, and you have plan for disaster recovery as well. That's it guys for disaster recovery and failure. We are going to see SLA and SLO, which is like how you measure whether you are meeting business requirement. This is agreement and how you are actually complying to the agreement. Thanks. Let's go ahead and understand what is SLA and SLOs, because those are very important, and this is the contract you can think of between your business and IT as a service provider. Okay, so SLA is understand the business requirement for SLA, and this is what it means is what are those expectations which your business has it from IT, and this is complete agreement about your IT services which is consumed by your business. You, as an example, you are providing or hosting your website, right, as a business, and that particular website is served to the customer, right? And how much actually the load that website can take it, how much time it should be available if something goes wrong, within what time actually it should be available for customer to serve it. All of that contains in your SLA document, and that is the written document and agreed document between your IT and your business. So SLO is a typical measure of, you can think of IT attributes. So this is very in the context of business, and this is purely in the context of measurability, how you measure SLA, right? And that is in the form of availability, how much your service is available, like 24/7, 100% available. In the case of websites, yeah, that is definitely a requirement, but there is no service which is like 100% available. But you need to make sure that when your customer is not using, and if the service goes down as per agreement with the business, then you should be fine. If at all, as an example, if you are serving say Walmart or any other retail agency, right, local to your area, and if that shops are actually closed at 6 p.m. or 9 p.m. in the night and opens at 6 a.m. in the morning, from 9 to 6 a.m. even if your services goes down when no one is using it, then that is fine, that is absolutely okay, right? But you need to make sure that when shops are open until it gets closed, your services are available to serve it to the customer, like or the shops. So that is measurability of your availability. Throughput means if there are say 2 shops accessing or 1000 shops accessing, your service should not be actually should not go down, right? And that is your throughput. And again, this is a measurability. You need to have a measure of what is the throughput which you are expecting, and that you can measure it through different parameters or different matrices. Frequency response time, and this is another measure, and there are so many other measurements which you can define under SLOs, and this is very important document. Again, it has got matrices and derived, and you can use different IT state to measure and ultimately report it. As an example, you can create a different log or traces for the response time, whether you're still be able to say shop is able to see your service or the website, but at the same time the response is too slow that the customers are queuing up in the counter, right, to pay the bills. That is not acceptable. So you need to make sure that you have got acceptable level of response time from your website. So all of that is a measurability, and SLO means actually you can measure all those numbers in matrices in the form of any logs or any tools. There are hundreds of tools which are available which you can use it. Google Cloud Platform also gives you some tools which you can use it to measure all these numbers. So that is a part of SLO. And typically all these attributes talks about quality of service, quality of your software, right? And typically SLA is a measure of QoS, and that is the purpose of SLA, right? As an example here, right, 85% of your TCP replies should be within 1.5 seconds receiving a request, and this is your turnaround time for your any request, whether it is submitting a form or refreshing the page on your website, or getting the data from the backend to your mobile application. It could be anything. What it says is 85%. If so, this is not 100%. Depends on the peak load, or depends on one particular time. It can spike up. There are so many customer hitting to your backend services or websites because there are some promotions going on. It can actually go down. It can go down. Service may be impacted, but this definition SLA, what it defines is 85%, at least 85% of the TCP replies within 1.5 seconds after receiving the request. That was SLO and SLA, guys. If you have any questions on that, let me know. We are going to talk about high availability. We already saw that in failure and disaster recovery, but we'll just go a deep dive into it. Thank you. Options for high availability. We already saw load balancer as an option for high availability when one of the zone or region goes down because of some problem, or one of the virtual machine, which is like backend service, goes down. Then load balancer intelligently detect the bad VMs or the zones or the regions, and then route the traffic to the healthy ones. The additional thoughts around the high availability is additional VPN connection, and this is for the hybrid connectivity. So if at all you have, say, your data center and you have one VPN connection to the Google Cloud platform, you probably want to or you want to consider additional VPN connections if at all some problem happens to the first VPN connection, right? And that is the additional connection or additional high availability option. If at all you are using interconnection line, then definitely you want to add in additional interconnection line, which is a dedicated MPLS line from your data center to Google Cloud platform for high availability. This was purely in the context of the network. If you look at the database as such, then you can have the backup configured, backup and restore strategy configured for your databases, like whether it is Cloud SQL, whether it is Postgres SQL, or whether it is Cloud Spanner. Additionally, you can have read replica. Read replica serves multiple purposes, and we are going to get into details of that. You can think of for the database, but read replica actually serves the purpose if at all your master instance or the primary instance is receiving heavy read traffic. What you want to do is you need to route your traffic to the read replica. So you create a read replica, you route read traffic to the read replica. You can create multiple read replicas, but if something happens to your master node, then you can actually promote read replica to take even the write traffic as well. You can have high availability configuration for your Cloud SQL databases, like you can have standby master running all the time in different zone or region, and then you can, if at all first master goes down or the master goes down, then Cloud SQL automatically toggles to the backup or HA instance. Very specific to the applications, I would say start considering persistent store for your cache data or the persistent data, whether it is cloud data store or cloud storage for your game state or any session management or the data which is in the transient state, right? And which is like dependent on your virtual machine or any instance in the backend. So try to use persistent storage for your session data. That was in a high level. What is your high availability policy? Whenever you create a high availability, the policies, you need to have written documents, and then that document you want to actually test it, right? Test means you probably want to delete some of the VM instances in the backend, and then you want to see whether load balancer is distributing your traffic according to your policy or not. All of that, this should be testable enough so that if something happens, you have a plan, and you have a plan which is like working in actual scenarios. That's it for the high availability. If you have any questions around it, this is purely a theory, but if you have any questions around it, let me know. Otherwise, you can move to the next lecture, which is DNS strategy. DNS strategy. We'll cover actually more of the DNS and DNS strategy in the demo itself or the theory itself in detail. But in a high level, the cloud DNS, which Google Cloud platform provides, it has got 100% uptime SLA, and that's the only thing which you need to consider. As because it is 100% uptime SLA, you do not need to worry about whether some of the hosted zones going down or something, because it is highly available managed service provides to you. Additional thoughts around the cloud DNS is you can think of you cannot connect on-premises services using cloud DNS because it is a Google Cloud Platform service, and you will not be able to connect it to your on-premise or outside any service which is not in Google Cloud Platform. These may change in shorter period of time, but you can keep that in mind. Load balancer. Load balancer is a service which is available there right now on premises as well, or your own services as well. So what load balancer actually does? Load balancer actually take your traffic or the request from your client, whether it is mobile client or desktop website or any other TCP or HTTP clients. It takes the request from them and then it distributes the request in the backend instances. So you can think of it can distribute the request based on the type of request, based on the location, based on any number of parameters, right? So that's the load balancer. Load balancer actually takes the request from the client and send it to the backend to get that request fulfilled. There are multiple types of load balancer which are available out of Google Cloud Platform. And I have divided them into two different categories. One is the global load balancer and the second one is the regional load balancers. The global load balancer has got HTTP or HTTPS load balancing, SSL proxy load balancing, and TCP proxy load balancing. These are the global type of load balancer. There are regional load balancer. One is the regional external load balancer, and they also call it as a network load balancer in plain form. Rather than saying regional external load balancer. There is another load balancer which is regional internal load balancer, or which they call it as internal load balancer only. We are going to see in detail about this load balancer and even the demo as well. But these are the high level load balancer which are available for you to use it. They have given us a decision tree as well, in which case you want to use a specific load balancer over the other ones. As an example here, if your requirement is external requirement, whether the client is IPv6 or IPv4, the traffic is coming from the internet to your GCP connections, and depends on type of service, whether it is HTTP or HTTPS, you choose HTTP or HTTPS load balancing. If your traffic is TCP traffic, that's where you need to check whether it has got SSL in it. If there is an SSL offload, then you can probably use SSL proxy load balancer. If there is no SSL, then you just go ahead and use a TCP proxy load balancer. If the traffic is UDP traffic, then probably you want to check whether the client has got a global load balancer requirement and the traffic is IPv6. If it is IPv6 traffic, then there are currently no services which you can use it from Google Cloud Platform. But if it is not IPv6, it is IPv4 traffic, then you can use network TCP or UDP load balancing. If your requests are internal, purely internal in nature, your consumer is internal to your GCP like any other VM, then you should be using internal load balancing, whether it is GCP or UDP. It's internal load balancing. Here are some of the the port numbers based on which you can use it for different type of load balancers, and we are going to get into details of that. In a high level, if you look at the architecture diagram, Your global load balancer actually take the request from public internet, whether it is the users resides in US or Europe or Asia, right? So that's your global load balancer, and this is your requirement typically. um, if you look at the internal, if your one VM is calling another VM or another service inside it, like your web tier is calling application tier in the backend, then you can use internal load balancer there. But this is the high level representation of how you can use load balancers for your high availability or HA you can think of. Let's go ahead and look at optimizing it for latency, and we are going to see 3 different options that are available in the next lecture. Thank you.
Let us look at CDN. Let us look at how you can optimize your latency using CDN. If you look at the earlier architecture, usually if you are serving to the website or you are serving to the mobile applications, you are actually connecting to load balancer, and load balancer direct your request to the backend services. Consider a case wherein you have a static content. Static content means you have videos, images, or static text data, which usually doesn't get changed. What happens is, for each and every request, if CDN is not there, it will go back to the backend services and pull the data out. Even though it is static content, the request will go all the way back to the backend services. But if you enable CDN for the static content, what will happen is, all the data which is very static, it will be stored in the CDN locations, and there are around hundreds of locations, around I think 80 plus locations, which Google provides you out of cloud platform, wherein you can cache your content. As an example, if you have video content of say 10 MB, right, or 10 MB image, that will be stored in CDN location. And if at all you are accessing it from Asia or US, you will hit to the load balancer or the nearest CDN location. If the data is found there, it will be served from that particular location. We are going to get into details of the CDN, but overall that's the concept. It's a content delivery network, so your content is getting cached in all those CDN locations, and the content is served from there itself. There are two different advantage here. One is you are optimizing the latency to deliver your content, because the content is delivered from nearest to the customer CDN location. That is one benefit. But the second benefit is you are actually reducing the load from your backend services, like the load on your virtual machine or your cloud storage, and that is definitely a good advantage when you are serving millions of customers or the users to your applications. So that is the CDN. We are going to get into detailed theory as well as demo for CDN, but that's it for now. If you have any questions on high level understanding about the CDN, let me know. Otherwise, you can move to the next lecture. Thank you. Let us go ahead and understand the project quota. And there are two different quotas applicable here. One is per project quota, as well as the other one is per VPC. So VPC is, as we understand, it is virtual private network or virtual private cloud, which you created in Google Cloud Platform or any cloud platform that are available. So there are different quota per project and there are different quota for VPC. Let's go ahead and understand what is project quota. But before we get that, let me just tell you there are two different terminologies here. One is the quota and the second one is the limit. So the quota is, you can think of it as a constraint, which is suggested constraint or enforced by Google Cloud Platform. You can increase the quota limit by requesting it for that particular service. So it is applicable to a particular service or particular API. You can ask for increase in limit for that particular quota, And you can think of quota is there so that you avoid bill shocks. Say if at all you are using, say, number of virtual machines, and you don't even know that there are so many virtual machines are being used by your project because of the auto scaling or because of so many other parameters, and you get a monthly bill and you get a bill shock, right? This was not expected. So to avoid those kind of bill shocks, you have a project related quota, and though this is the limit which is recommended and enforced by Google Cloud Platform, but you can ask for increase in the quota. So that is the quota. The other part is the limit. Those are the hard limits which you cannot ask for an extension, right? And those are hard limit, you cannot extend it. If we talk about in the context of project, if you have a project, you can create up to 5 VPC network, and that's why you have different quota for a project and different quota for VPC. Looking at per project the quota, those are, you can think of number of API calls which you can make in a particular day, and that is project related quota. Whether you use it inside one VPC or multiple VPC, it's not really bothered. So that is the project level quota. You can also think about the number of virtual machines or the load balancer used by one particular project, and that is your project quota. If we talk about the VPC quota, some of the project quota VPC does take it, and you can say go up to 15,500 virtual machines per VPC. There is a quota for number of firewall rules which you can create. There is a quota for number of forwarding rules which you can enforce. There is a quota for number of cloud routers which you can create, and there are so many other parameters as well. But when we will see this in the Google Cloud Console when we see the demo, but that's the quota concept itself. That's it, guys, for quota. If you have any questions here, let me know. Otherwise, you can move to the next lecture. Thank you. Let us go ahead and understand what are hybrid connectivity options which are available. We already saw an introduction about the connectivity options which are available, but this is just a part of syllabus. That's what I'm reiterating, some part which is already covered. The first option is you can use VPN, and from Google Cloud Platform, you have Cloud VPN as an option to connect your data center, your on-premises offices with Google Cloud Platform. VPN is secured one, and you can add multiple tunnels to increase the throughput for your network. That's the VPN. It is secure, and it can be with or without dedicated connection. With Google Cloud Platform, you can increase number of channels for additional bandwidth. The second option that you have is Cloud Interconnect, and that is it is a dedicated interconnect option from your on-premises with Google, and you have two different options to connect you. One is direct connect to Google Cloud Platform, and that is they have some requirements to have it. You need to have at least 10 Gbps line. The second one is you should be available in Google's POP locations. If you are not available in Google's POP location, you need to go via partner interconnections, or even if you are available in Google's POP location, but your requirement is less than 10 GB, like 1.5 GB, right? Then in that case, you should go via partner interconnect. The third option that you have available, it is not purely for Google Cloud Platform. It is for all G Suite services, like all collaboration platform, or like Sheets, document storage, and like that, plus YouTube or any other social networking which is required for your organization, and you want to reduce the egress fees, and that is the benefit of peering. You do not have any SLA. Data does not get actually encrypted in the pipe. You need to keep that actually in mind, and you cannot exchange the network, your on-premise network, with Google. That is not allowed in peering. The whole purpose of peering is to save on egress fees. That's it for hybrid connectivity, guys. If you have any questions on hybrid connectivity, in nutshell, let me know. We are getting into details in the next section for all these topics, as well as the demo for all these topics. So if you have detail level questions, hold on to that, and you can ask it after the actual theory and demo. Thank you. This is very basic topic you can think of if you are learning Google Cloud Platform or networking onto the cloud. You already know these terminologies. I'm just trying to cover this because it is asked in the syllabus, so that if at all you are a new student or just passed out from the college and if you do not have any understanding, I doubt whether you have that, but still I'm just covering for the sake of syllabus here. There are multiple platform services which are available which you can use it. One is the software as a service, second one is the platform as a service, and third one is infrastructure as a service. But beyond that, traditionally what we know is there are organization or companies who are managing their own data center, because the amount of data which they are handling is huge, as well as there are security requirement which they cannot use any co-location facility or the data centers from the other vendors. So traditionally, if you look at if you are managing or your company is managing your own data center, they are managing each and everything which is required for the data center. And the one thing which is not here is the real estate business, like renting the location for the data center, maintaining the cooling and everything which is required for any building or real estate kind of requirement. They have to maintain it. And then onwards, it starts with the computing resources like network, the cabling, the storage, servers, virtualization, operating system which you install on the hardware, the middlewares, the runtimes, the data inside it, and the applications. So all of that is maintained and managed by you. So you will definitely need the real estate maintenance people, you will need the networking people, you will need the hardware people, you will need the operating system people who manage the operating system inside those hardwares, virtualizations, and all of that. Everything is managed by you, but because you are very big organization, you can spend that much money and have it done. The second one is the infrastructure as a service. That's where you look for a vendor like a public cloud platform, Google, and ask them to maintain their real estate business, their networking, their virtualization, and everything. And you're just using their virtual machines or the virtual services and onwards. The virtual machine in Google Cloud Platform is one of the example you can think of, is infrastructure as a service. Or if you are using, say, virtual machine, and then you are installing any custom database or any application and you are managing that, you are taking ownership of operating system, middleware, or anything which runs inside that particular operating system. And that is where Google is just providing infrastructure. It is data center plus physical location plus the networking, storage, all that virtualization platform which is required for you to launch and manage your virtual machine instances. And that is the infrastructure as a service. If you move up, that's where you can think of Google is managing operating system and middleware and runtime as well to run your application. And this is, you can think of App Engine, right? So App Engine provides, just you can just write a code and you can create a data model and you can deploy your application inside App Engine and it will start running. You are not managing underlying operating system, you are not managing middlewares or runtime. Everything is managed for you from Google side. That is a platform as a service. In software as a service, which is not typically a case of Google, yes, there are some instances wherein you can treat some of their services like Vision APIs, right? That is software as a service, but it is not typical software which end user will use it. So if you want to understand what is software as a service, Gmail is a software as a service, or you can think of Salesforce is software as a service, even though they are providing platform as well. But there are so many things which you can just use it readily, just configuring it and using it. There are so many vendors like software as a service which they provide, like QuickBooks, and they are providing everything out of the box, and you just need to subscribe for it and you can start using it. That is software as a service business. Typically, if you look at if at all you want to map this to say pizza making company, right? If at all you want to make your own pizza at home, you are actually you will need to have your own, like infrastructure or real estate, right? Then on top of it, you need to you should know how to cook it, right? You need to have toppings, you need to have all the dough preparation recipes, you need to have oven, gas, kitchen, everything you need to have it, which is done by you, and that is like you are maintaining your own data center. If you go to infrastructure as a service, that is where infrastructure is given by someone else, so the kitchen is provided by someone else, but you just take your dough, you take your toppings, you take your you know how to cook it, and you just take all those items together and you go to those providers and then just cook your own pizza based on whatever available resources which they are providing. The third one is platform as a service. That's where even dough is given by them. You just need to take your own toppings and your own recipe, and you can prepare your pizza. And the last one is everything is done by them, like Pizza Hut or Domino's, right? They are giving everything. You just need to tell them that I want this pizza, like veggie pizza with so and so toppings and well done or extra crunchy or something like that, and they will make it for you. Everything is done for you, you just need to ask for it, and that is software as a service typically. You can extend software as a service, platform as a service, and infrastructure as with beyond. There are co-location for facility vendors, or you can think of database as a service or container as a service, right? So there are multiple as a service came up, and which are available and widely used in the industry nowadays. You do not need to worry about it, but I'm just trying to tell you, 3 SaaS, PaaS, and IaaS is not the only thing which is as a service available. Many things are available as a service and which you can use it. That's it, guys. SaaS, PaaS, and IaaS. If at all you have any question around it, let me know. Otherwise, you can move to the next lecture. Thank you.
Cloud networking. Cloud networking is very much, or you can think of critical service that are available from any cloud providers right now there in the market. We use cloud networking to isolate your resources, cloud resources, from other companies or from public accesses. Let's go ahead and get into details of what is that we have available from Google Cloud Platform. Cloud networking is one of the 3 core services that are available from Google Cloud Platform or any cloud platform to say. In cloud networking, you can create a virtual private cloud, you can have load balancers, you can create firewalls, routes, subnetworks, CDN, as that you are actually using it from your own data center. In a high level, cloud networking divides into 3 different areas. The first one is the load balancer. That's where you take the traffic from your customer and distribute your traffic to the backend services, and we saw this in detail in our computing service. The second one is VPC, and that's where you create the virtual private cloud, which is, you can think of private networks in the cloud, in the global cloud, and you can spin off any resources inside that particular virtual environment or private environment so that others cannot actually access it. So VPC is one, and you have subnetworks, firewall, and VPN created inside the VPC to isolate different environments. But besides that, you go ahead and create a hybrid connectivity. Like if you have your data center and you have some applications running inside your data center, you want to connect your data center with the Google Cloud Platform, and that's where the VPN or the interconnections part also will come, and that is what we are going to see it in VPC as well as VPN or interconnections in this topic. We are also going to see DNS and CDN services. These are also the core services that are available, but those are, you can think of optional service or additional service which you can use it based on your requirement. But we are going to see this in detail in this particular section. So in nutshell, we are going to see Cloud VPC, which is the network inside the cloud. We are going to see Interconnect. Interconnect means connecting your data center with the Google Cloud Platform. We have already seen load balancer. We are going to see CDN, and we are going to see DNS here in this particular section. Cloud VPC. It is managed networking functionality for Google Cloud Platform resources. Using Cloud VPC, you can create a private network. What it means is you can provision your GCP resources, connect them with each other inside the VPC, and isolate them from one another using or creating different VPC or the subnet inside it. You can also define fine-grained networking policies with Google Cloud Platform, on-premises or other cloud infrastructure. Using VPC, you can think of it as comprehensive set of Google managed capabilities, including granular IP range selection. You can define routes, firewalls, and cloud routers as you are actually doing it in your own premises or your own data center. Let's look at some of the features for VPC. It is built, you can build private global data center like feel without managing hardware in terms of like hardware switches or routers, or building it on your own. You can have subnet, firewalls, route, or you can define the pairing inside VPC. You can monitor the network connections using flow logs, and it is global, shareable, and expandable by design. So you don't have to provision any resources. It is not a physical device, so that it gets bottlenecks when there is a problem or there is huge bandwidth utilized. It is managed functionality. Everything is managed by Google Cloud Platform, and it scales based on the requirement, so you don't have to worry about the scaling. It is software defined and it is not the hardware. I just wanted to reiterate that. It is possible to provision cloud resources. You can connect them with each other, and you can isolate them. You can create a subnet, and you can even isolate different environment like prod, dev, and test, right? And that is what VPC provides. There are different types of VPCs which are available. One is the default, which is created by default when you have an account. You can create auto mode VPC, or you can do custom mode VPC, and we are going to get into details of that. Some of the features of VPC in Google Cloud Platform. It is global in scope, so it is not specific to region or zones or a data center, right? It supports multi-tenancy. You can have private communication. You can define subnetworks. You can define firewalls. You can define routes. You can have a cloud router for BGP link. You can share the VPC. You can have access control managed via IAM. So in nutshell, VPC is a comprehensive set of, you can think of Google managed networking capabilities, including granular IP address range selection. You can define routes, firewalls, and it is virtual private network on the cloud, and it supports cloud router. And what do we mean by cloud router? We are going to just see it in the next slides. So VPC is a virtual version of traditional physical network that exists within and between your physical data center. So you can think of it is virtual version, and it is software defined, and it is not your physical devices inside your own data center. Each GCP project contains one or more VPC network. VPC is global in nature and allows global VM instances and other resources to communicate with each other via internal private IP addresses. So VPC itself, the concept of VPC itself is global in nature. It is not tied to a particular region or zone. So VPC does not have an IP range. So IP range is created within the VPC. You can create different subnetworks, so part of that particular network, and you can attach the IP ranges to those subnetwork. So if you look at the VPC, it is firewalled network, and it has got no IP ranges. It contains subnetworks, and subnetworks has IP ranges. You can have more than one subnetwork in a region for a given VPC. As an example, if at all you are deploying your services into, say, US East one of the region, you can have multiple environments created there, like dev, stage, performance testing, or UAT, and the production. You can create all of those as a different environments or different subnetworks, and that's the power of subnetworks. Some of the thoughts on project and VPC. All the objects associated with project, definitely, because VPC is contained within a project, so all the objects inside the VPC is also associated to a project. Each project starts with default VPC, and that is default which is created out of it. You don't have to create it, and it is in automate, so everything is created for you. You can go up to 5 networks per project, and this is the limit right now that we have it to create the VPCs. Let's go ahead and get into details of different type of VPCs that are available and its features. The first one is default VPC. So this VPC is created and already there when you have a project. So for each and every project you have default VPC. Subnets are created by default per region, per zone. Internet gateway also created. Firewalls also open between subnets so that all the resources can communicate with each other. Let's go ahead and browse this in the console. So if you look at, if you go to network and go to VPC network options, you just click on VPC network, and this is the default VPC which is created for you. You don't have to create the VPC, and these VPCs contains subnetworks that are created per region. All the subnetworks are created, the routes are defined for all those subnetworks so that it can talk to each other, and there are firewall rules also created for all increased traffic. There are firewall rules which are created, and you can attach these firewall rules to a particular instance, or you can have it for the whole subnetworks. Let's go back. So that's the default VPC that is created by default for you by Google platform per project. The second one is auto mode VPC, and this is, you can create a VPC here. If I go ahead and say create VPC network, you can either say custom VPC or auto mode VPC. If I say auto mode VPC, then this is what it changes. So you will have subnetworks routes created by default for you, and you do not need to worry about it. When you click on auto, that's where you need to add the subnetwork wherever you want to have it. As an example, right, this one. So I'll go back. So auto mode VPC has got a single subnet per region by default created. It has got fixed /20 CIDR range per subnet. You can expand that up to /16. Default network is auto mode network, and predefined IP ranges are there, so you are not creating any IP ranges. So if you look at this one, automatic, you have these subnet ranges already created, IP ranges already created, and that is by default. Firewall rules already created for you, okay, and the routes also created for you. You do not need to create anything in case of auto mode VPC. If at all you want to disable something, you can just go ahead and disable that. Custom mode VPC, no default subnets are created. If I just go ahead and make this as a custom VPC, let me just create it, custom VPC. And let me say custom, and I can just go ahead without any configuration. I can make dynamic routing rules, whether it is regional or global, and we are going to get in details here, but I'm just leaving it as is now. And you can have DNS policy also. You can just go ahead and create it. So the custom mode VPC is getting created. So it has got no manual, no default subnetworks. Manually created subnetworks can be valid. Any valid RFC 1918 IP range. Range do not have to be contiguous between the subnetworks, because you are defining your own subnetwork ranges, right? And you have full control of IP ranges. Going back here, if you look at this custom mode VPC does not have any subnetworks, and it is custom, right? No firewalls rules created, no dynamic routing. I can just go ahead and add subnetwork. My subnetwork US West 01, and I can go here US West 1. I can actually define IP ranges. And you can go up to 16 per IP ranges or CIDR ranges. You can have Google private access on or off. You can enable flow logs, and flow logs is very important when you want to audit who is accessing what data, and you want to monitor the network, and that's where flow log will be useful. We'll go ahead and get into it, but I'll just go ahead and add this for now. So it is creating my subnetwork inside custom VPC. It is not yet created, I think. Okay, yeah, it's ready now. So I have subnetworks created, but if you look at firewall rules, none of that is created. So if you look at this network, for this network, we have firewall rules, but no firewall rules created by default for custom network. The routes, if you look at the routes, there are two routes created. One is default gateway to the internet, and one for your subnetwork that is created. So routes are created for the subnetwork which you have it, but not for the other subnetworks which you have not created, or any other region or zones, right? If you want to connect to. So that's the custom VPC. So in VPC, as a summary, if you look at, you can create per project, you can create 5 networks, and that is by default, which is the quota which you get it from Google Cloud Platform. So you can create, say, prod, dev, stage, and all that network, or based on the department also you can create the network, and you can create different subnetwork to isolate different kind of environment like dev, stage, and prod, right? Those networks are global in nature. It is not tied to one particular region, and you can create any resources in any region within those network. It can talk to each other with the internal network communication, so it does not have to use external IP address to connect to each other or talk to each other. But if you are creating a resources in different network altogether, this communication is the external traffic, and the internet egress charges will be applied for this particular communication. Just need to keep this in mind. So if at all you are creating resources in different region within the network, then it is internal Google internal network, and there are no charges incurred as an internal to the network. There are some cross region charges which is minimum, but it is treated as an internal to the network. But if you are connecting two resources in different network altogether, even though they are in the same region, it is treated as internet egress traffic. Subnetworks and VPC. Subnetworks, or subnet in short form, is an isolated network within your virtual private cloud, and it is specific to region. So VPC is the global in nature, whereas subnetworks are specific to a region. If you look at this particular case here, you have two different network. One is the production and second one is dev stage network, and both these two networks are global in nature. It has got presence in region 1 and region 2. In region 1, you have sub network which is spanning across multiple zones, zone 1 and zone 2, but in region 2 it is only to a zone 2 of that particular region. That's the sub network as a backup network which is created. If you look at the resources from zone 2 of this particular subnet can talk to the resources inside this particular subnet in region 2 using the internal communication, provided you have firewall opened and routes defined, so that they understand that there is this particular instance and how to reach that particular instance. You can also have the resource from one particular network talking to another one via external IP address. Again, a firewall is the major role here, unless there is a firewall open and routes are defined to reach to those particular instances. So reserved addresses, you can actually have network addresses which are first addresses in the CIDR range, default gateway address, the second address in the CIDR range, reserved addresses, second last in the CIDR range, and broadcast address, that's the last address in the CIDR range. And these are the reserved addresses that you can think of. So what is reserved addresses? So out of whatever range you define for a particular subnet, the initial two addresses, which is like network address, that is your subnetwork. The second one is default gateway for that particular subnetwork. So this is reserved from the initial two, and the last two are reserved addresses, and the broadcast address in the CIDR range. These four addresses are not usable. If at all your subnetwork has got 256 addresses, 4 of them is not usable for you because it is reserved, and you will be able to only use 262 address range. So what is subnet? Subnet contains VPC contains subnetworks. Subnets are region specific. Subnetwork in single zone or multiple zone within the region. Using subnetwork, we can apply single firewall rules, all VM, even if they are in different zones. You can create multiple subnets within single region and zone to isolate resources on a different business needs. Each subnet has a contiguous 1918 IP space or the IP range. Virtual machine instances within VPC network can communicate with the instances in all other subnetwork within the same VPC regardless of their region using RFC 1918 private IP. And this is very important. So all the IP address, if you look at IP ranges, I'm going back here. So if at all you create the instance under US Central 1 using this particular address range, this instance can talk to any other instance within that particular network using internal IP address. We don't have to use external IP address. Okay, and that is very important within the VPC. You can isolate portion of your network, even the entire subnet, using the firewall rules, and those are very important. You can create firewall rules to block or open the connections between the networks. Subnetwork and the network. So we saw there are default network, auto network, and a custom network, right? So you can create auto subnetworks with specific zone. Firewalls are opened between subnetworks, and so all the resources can communicate with each other. And you can see the default VPC. So it is auto in nature, and you can actually see it auto or custom. You can convert this default into the custom, but once you convert this network into custom, you will not be able to take this back into auto mode, and that is very important consideration. You can always convert your auto network or default network into custom network and uh, modify the sub networks, firewall rules, or routes. In custom network, you can create a network within a specific zone or region. No firewall rules are open for communication. You have to open it explicitly, and this is very important. So if you look at the overall picture here, you have the region, you have zones, or you have sub networks within the zone or within the region, and your load balancer is actually communicating to your backend services or the instances within the services. Your traffic actually, if at all you have a website, the traffic will come to DNS, whether it is cloud DNS or you have any other DNS, and it will route to cloud load balancing, and then it will be forwarded to the backend instances. And this is very important. So you can have the instances within or inside the VPC networks, and you can even have these resources spanning across multiple regions, as because Google Cloud Load Balancer are global in nature, especially the HTTP and HTTPS. So look at this particular typical example here. Okay, your traffic, you have a default network inside Google Cloud Platform, and that cloud platform has got a different sub network created. One for region 2, so 2 subnetworks for region 2 and 1 subnetwork in region 1, and this region 1 and region 2 could be anywhere, because your VPC is global in nature, and your resources actually will sit inside those subnetworks. So whether it is one particular zone or multiple zones, if you look at this particular subnetwork 1, it has got 24 address range, 10.240.0.0/24 address range, and this second network has got 24 192.168.1.0/24. The third network, and this is very specific to zone A again, the third network is which has got a /16 address range, which is like more or bigger range, but this is spanning across multiple zones, so zone A as well as zone B. So this is the typical use case. You can mix and match the way we want to have it, but you cannot go beyond the region for one particular subnetwork. You need to have subnetwork within the region, maybe spanning across multiple zones. Routes and firewall rules. So what is routes? Routes are actually the way you can tell a particular VM how to reach to the particular instance or the particular resources using the routing mechanism. Whereas the firewall rules, you can put forward traffic control rules, right? Restrictions for egress or ingress traffic for your VM or the cloud resources. Let's get in details. So what is route? Route tells VM instance and the VPC network how to send a traffic from an instance to the destination, either inside the network or outside GCP network, and that is what it is defined in the routes. Each VPC comes with some system generated routes to route the traffic among its subnetworks and send the traffic from eligible instance to the internet. And some of the example here, and I can go back into our VPC network. So here is the route. Route says you can go to destination range 10.128.0.0/20, all those IP ranges inside it as a next hop, and the priority is defined here. You can go to default internet, and this is by default it is created, and we have seen that for custom as well as auto mode VPCs, a route has been created. So if you look at the network and routes, for all the default route, you can find the default route for each and every address range that we have. But for custom routes, because we have only one subnet, which is 10.10.0.0. So for that, there is one route created, and the second one is to the default gateway. You can just go ahead and delete it if you don't want any instance going out to the internet, because you may think that it is an internal service and instance should not go out to the internet, right? So that's how you can manage the route or control what your instances can and can't do. So some thoughts around cloud routers. All network have automatically created route to the internet and IP range in the network. The subnet route let instances and send traffic to any other instances or the resource within the same VPC network. The default route let the instances and send the traffic outside VPC network. That is internet gateway. Names automatically generated. Applies to a traffic egressing a VM. Forward traffic to most specific route. You can have traffic delivered only if it matches to the firewall rule. So you need to make sure that the firewall rule is open for that particular route. Then and then only it will go out. Otherwise, it will not go out. It will be blocked outside the VM instance. Created when the subnet is created and applies to tagged VM as well. Enable VM on the same subnet to communicate. So these are the properties of route. In essentially what we are saying here is the routes are created for subnetworks, and that is by default. You don't need to create it again. If you want to delete it, you can just go ahead and delete it. For route to work, you need to have firewall rules opened from that particular for those destination IP addresses. As an example routes here, and which we saw, the routes like 10.10.0.0 /20 or 1.146.0.0 /20 and default route to the internet, and this is another route example. Firewall rules, as we said, firewall rules, you can control the traffic from or to the cloud resources. In example here, if you look at the virtual machine, you can define traffic actually going out to the internet or coming in to this particular virtual machine. If I go back in the console, you can have these particular firewall rules directly created for you. But when you are creating a VM instance, I can go here, compute VM. So you can attach or detach firewall rules here, okay? And if you go and edit, you can't edit the firewall rules here, right? You can just go ahead and do it from the network tag. So all of these firewall rules are like network tags. If I go back, let me create another console here. That way we can switch in and switch out to the network. So you see these rules, right? The firewall rule, this is like targets. What is that you want to enforce it? You can actually go ahead and use default allow ICMP there or default allow SSH. I go back and here I can use, it says apply to all, right? I can go ahead and edit this. Specific tag, and I can say default ICMP traffic. Save. So now what I can do is I can go back to this particular instance and I can say default ICMP, and that's how ICMP will be allowed. So you can control the traffic to and from the instances using firewall rules. The actions, you can allow traffic or you can deny traffic. The conditions, the destination side range, like if you are hitting outside this network, that is the destination side range and that is egress traffic. Or if at all someone is coming inside your virtual machine, and that's where you define the ingress IP ranges. You can define protocol, you can define ports for it, and we saw that, right? So here you can define protocol. If I go protocol and port, it says TCP and 80, TCP and 443. So you can define port and protocol. Each VPC network implement distributed virtual firewalls. And if you look at the VPC, the concept of VPC itself is a private network and everything is blocked by default, right? So firewall allows you to control which packets can travel to which destinations. Each VPC network has two implied firewall rules that blocks all incoming connections and allow all outgoing connections from those network resources. And that's where we saw it's like 0.0.0/0, right? Each network has its own firewall controlling access to and from the instances. You can have allow rules as well as deny rules. You can have default. So the default network has got automatically created firewall rules. No manually created network has automatically created firewall rules. By default, allow for all outgoing traffic and deny all incoming traffic. You can have network tags and you can attach those tags to the VM instances. So you can attach the rules to the tags and you can attach those particular tags to the VM instances. We saw HTTP traffic, right? HTTP and HTTPS. Tags are used to use a defined string, and tags are applied to VM and not to IP addresses. So if you go back, we saw that there are tags you can create it. Can go ahead and create. So you can create the tags, right? And we saw ICMP tags. Routes and firewall rules are network resources and cannot be shared between the projects or the network. It is specific to a network. It maintains in a network table. Traffic, it is SDN routing, that is what it is used for. So subset of routes and rules for one VM is derived from the table, applied to traffic as it exits the VM, or when it is getting inside the VM. Especially traffic, SDN routing is actually when it is applied, it is going out from the VM. So if you look at these firewall rules and routes are not inside the VM, and this is very important. So whenever you are using it, you will not find these routes and firewall rules which is configured as a part of that particular OS. It is outside your VM instances. If there is no traffic matching both the routes, the rule is dropped. Allow traffics with route is delivered to a target, VM, service, or internal POP, not routing or switching. Firewall rules, typically it's a connection control. You have default and custom network. Default deny all ingress. Default allow all egress traffic. Ingress firewall rules, you have deny for everything. The second source filter allow the source range and tag for simpler rules inside the firewall rules. Egress rules, it has matched IP CIDR. IP addresses on Google Cloud Platform. There are two different type of addresses which you can have it. One is internal IP address and the second one is external IP address. So before we get into the whole conversation of IP address here, let me go ahead and launch one instance and we'll see IP addresses there. I can go ahead and create the instance and we'll see IP addresses. I'm just keeping everything default. So the instance is getting created, and this is where you see internal IP address as well as external IP addresses. So you can see this particular internal IP address, and this is within your subnetwork. If I take this particular zone, US East 1 B, so US East 1 B, and I can actually map 142 address there. So US East 1B. So if you look at US East 1, it has got 110.142.0.0/20. This is the address range, right? So whenever you are creating an instance, it will be in this particular region, it will be specific to these particular internal IP addresses. If I go back again to compute service, so you have internal IP address that is 10.142.0.116 and the external IP address. You can connect this external IP address from outside, but you cannot connect this internal IP from outside. So this internal IP is for communications within your network, within within your VPC. But if at all you want to talk to the network outside your VPC, or you want to talk to another VPC, then you should use external IP address. These external IP addresses has got a multiple aspect in it. You can either have it ephemeral, or you can have static IP address. If I go back, let me see if I can change the network here. So I can say internal IP ephemeral, external IP, it can be either ephemeral or static. I can go ahead and just create the static IP address, and this static IP address, if at all you're not attached to a particular instance, Google is going to charge you for holding the IP address. If at all it is attached to an instance, then there is no charge. There are different network tiers which are available, and this is a new concept, still in beta right now, but I will have another training, not training actually, one lecture created to understand what is the network tiers. But you can create IP addresses here. So if I say this one, I can just reserve it, and once you reserve it, you will get the IP address and you can attach it to the instance. So going back to the theory, so internal IP address allocated from the subnet range VM by DHCP. DHCP reservation is renewed every 25 hours. VM name plus IP is registered within the network scope DNS. Static IP stays with the VM until the VM is removed, and ephemeral IP is attached to VM forwarding rules and only stays until VM is stopped. So if at all you say you have static IP for internal IP address, it will stay there with that particular VM until you completely remove the VM. But if there is a ephemeral IP which is attached, that is dynamic in nature, if you stop the VM instance, the IP will go away. If you restart it again or start the instance again, the new IP will be assigned to that particular virtual machine. In case of static, we saw it is not going to go away. External IP address, it is assigned from the pool ephemeral. If you turn off or on machine, you get the new IP address, and that's the ephemeral behavior of again external IP address. You can have reserved or static IP address. you can reserve it, and you will be billed if at all you're not attached to the running VM, because that's how there is no cost. Google will not be able to charge you anything, right, if at all it is not attached to VM. That's why they charge it. VM doesn't know external IP address. It is mapped to the internal IP. So typically inside the VM, if at all you are seeing it, you will not know the external IP address. If I go back here and if I SSH here, it is connected now. IP config. So if you look at the IP addresses here, it says this address and the local host, right? So you do not have any address inside your VM. If you look at, I do not see this particular IP address here in the address range if I say if config. So going back again to our presentation, IP must belong to the IP range of subnet in case of internal IP address. So that's the everything about internal IP address. Auto mode VPC, IP comes from the region subnet. Custom mode VPC, you must specify which subnet IP should come. Legacy network, the IP address is assigned from the network's global IP ranges. If we look at the custom subnet, right, custom IP. So the network, if I say create instance, and if I go and choose different network, which is like my custom network. So instead of default, if I say custom VPC, I should be able to say that where actually that IP should come from. So ephemeral, say custom or automatic, I would say automatic IP forwarding, and if I say done, okay. So there is, if you look at, there is no subnetwork. If at all I have a multiple subnetwork in this particular region, right, then it will pop up you multiple subnetwork. You have to choose that manually here, and that is what it is saying. So what we have is, we have subnetwork in subnetwork in US West 1. Okay, let's go. And so if I go ahead and create the instance, I have actually subnet in US West 1 and any zone. Okay, so I should be able to choose the network. So I can choose default VPC. If I have multiple subnetwork, I need to actually choose which the IP address should come from which particular subnetwork. Okay, and this is what it is. I can just click done and create. So the IP address will come from the subnet which I have selected, that is from the custom VPC and my subnet in US West region. Going back to theory, each instance has a host name that can be resolved to an internal IP address. The host name is the same as the instance name, like fqd in hostname.c.projectid.internal. If I look at here and I just do sudo host name, and that is the instance name. So the host name, that is the instance name .c.project.internal. Okay. Going back again, name resolution is handled by internal DNS resolver provided as a part of compute engine and configured for the use of instance via DHCP. You don't have to do anything or configure anything here. Provided answer for internal and external addresses, and you can use an alternative DNS resolver if you want to have it. External IP address. External IP address. Instance with external IP address can allow connections from hosts outside the project and network, and this is very important. If at all you have multiple networks within the project, even it has to talk via external IP address. Users connect directly using external IP address. Admin can also publish public DNS record pointing to an instance. Public DNS records are not published automatically, so you have to publish it. DNS record for external IP address can be published using external DNS server if you want to have it, but you can use even internal DNS. The DNS zone can be hosted using Cloud DNS as a GCP service, and we are going to see that in detail in this particular section in another lecture. You can create zone and configure domain DNS to use it, or you can create, update, remove records manually via API, and those are like features of the Cloud DNS. That's it for external or internal IP address, guys. If you have any questions on external and internal IP address, let me know. Otherwise, move to the next lecture. That is routes and firewall rule for VPC. VPC other concepts. Shared VPC. So you may need to put forward say different department or applications or different units all together in different project for your budgeting or access permissions or whatnot, right? That need, right? That's where you will use shared VPC. So the concept of shared VPC is you have the host project, which is hosting your VPC, which is network, and that network is shared across multiple projects, and those multiple projects are called as the service project. So everything is controlled by the shared VPC in terms of network, and shared this particular VPC has got a security admin, and that is organization-wide network admin you can think of. And you don't need that particular admin or network admin for individual projects, and this is where the shared VPC concept comes in play. Individual project team, they do not have their own network. They may have their own network if at all they are managing some internal stuffs there, but they can use the shared VPC network for the VM instances or the resources on the cloud. Some of the terminologies on the shared VPC. Shared VPC host project. This host project actually hosts shared VPC, and it has got a network security administrator. Shared VPC service project, and these are the service projects which are using those networks from the shared VPC. And typically, if you look at this particular architecture, all those resources inside the service project will be billed to the service projects and not to the host project. So the billing still happens to the service project. It is just that they are using the backbone, the network backbone from the shared VPC network. These projects are standalone project. It could be under one organization or multiple. So shared VPC network is typically the network which is backbone for all the service projects. IAM rules and policies, and this is where it typically you can think of it differs, right? So we said you can have one particular network administrator or security administrator spanning across multiple projects, and that's where one administrator can manage the control the network for all the service projects. You have an organization, and in organization you have multiple projects, and that's the concept of organization. Nothing new here. You can have organization admin controlling the access permissions to the network admins for the shared VPC, and you can have shared VPC admin as a network admin. So service project also can have administrator, but ultimately the network is controlled by the shared VPC and not by the service project admin, you can still go ahead and get the permission attached to the service project administrator as a network, but they can only view the network and not modify the network. So you have network admin privileges like compute.network admin and security privileges like compute.security.admin. And that's it as a concept from the shared VPC. If you go to console here, you can go ahead and create shared VPC, and it says shared VPCs only available projects within an organization. So my project is not under an organization. If you look at, if I click on this particular project, oh my god, let me see, click here, open, how do I, yeah, details. If you look at no organization, if at all I have organization here which is defined from G Suite, then only I can create shared VPC which will share the VPC between the projects. VPC pairing, another concept where you can have multiple VPCs connected to each other, right? And that is where it may be required for different network individually managed by different projects or within the project, and you want to connect them to each other so that the resources can talk to each other, and that's where you use VPC pairing. It can be used to connect one to many VPCs subject to quota based on total number of VM in paired VPC. And this is very important because this actually goes to quota back to what you can do within one particular VPC, and this is applicable if at all you are pairing two different VPCs together. It is non-transitive nature, which means if A is paired with B and B is paired with C, you cannot expect actually the resources from A will be able to talk to C directly. So it is non-transitive in nature. Security policies remain independent and can limit communication ability between two VPCs, and these security policies are independent, right? And this is not same as share VPC. In VPC pairing, you have different administrator or network administrator or security administrator independent of each other. Like you have one VPC managed by one particular group of people and another VPC managed by another group of people. The quota and limit, as we said, there is a VPC quota, right? So the VPC quota, like 15,500 total number of VM you can create inside VPC. Share or pairing VPC goes with the same quota, and which means if at all you are pairing like 3 different VPCs together, then total number of virtual machine inside those 3 VPCs together should not cross more than 15,500. A network can have up to 25 network, 25 directly paired network in total. So you can up to 25 networks you can pair it together. So if I go back to the console, you can go here and do a VPC network pairing, and I can just go ahead and create. So I have this particular project, I'm just keeping the same project. I'm just creating a pairing for GCP project. This is going to take a while. I'm just going to pause it. So it is enabled now. VPC network pairing is enabled. I'm just going to go ahead and create it. I'm going to continue. So VPC pairing, your network, I don't have actually too many network here. Okay, I should have 2 different network here, right? Custom and default. VPC pairing, I can enable it for one node for this project, or if at all I have it in another project, and if I have access to it, then I can choose another project, but it is inside the same project. Custom VPC, the network name is custom VPC. The default is selected, so I want to connect from default to custom VPC. I'm going to just go ahead and create. This connection is being created, waiting for prior network. So this is one-way creation, right? So I need to go ahead and create another connection from custom VPC to default one. VPC peering other, and now this is going to go join. So, and this is controlled by each and every VPC, right? As because I have both the network within the project, I don't have to log in and log out, or don't have different permissions. But if at all, say one network is managed by one project team and the another network is managed by another project team, they can any of that individually can go ahead and disconnect that particular network. So VPC peering is established. Now the resources from the default network can talk to resources to custom VPC, provided the firewall rules are opened. So that's the VPC peering in a nutshell. So what is the difference between VPC peering and shared VPC, and when do you want to use it, right? So use cases when you want to use VPC peering versus shared VPC. If your networks are within your project, then shared VPC is not possible. You can do VPC peering. We just saw it. If you have multiple organizations, shared VPC is not possible, but you can do VPC peering with the multiple organizations. You can do network management, and this is very important aspect from the network and security standpoint, right? For shared VPC, you have one particular network administrator as a host project, and they manage the complete backbone of shared VPC. But in case of VPC peering, individual project team manage their own VPCs and control their own VPCs. As an example here, going back, if at all I, from say default network, I just went ahead and delete this peering, the peering will be vanished, and even custom VPC, they have this peering enabled. They will be waiting and they will not be able to connect it to the default network then onwards. So it is individually managed connections. That's what you can think of. VPC quotas and limits, we'll see it in next chapter. VPC quotas and limits. VPC do not support IPv6 within the network. So inside the VPC, it does not support IPv6. VPC only support IPv4 unicast or multicast. Multicast is not supported here within or inside VPC. VPC networks can have 15,500 virtual machine instances, and you cannot extend this number. There is no per subnet limit only at the VPC. So you can have one particular subnet having all the 15,500 virtual machines, or you can have multiple subnets having different number of virtual machines, but total number of virtual machines should not exceed 15,000 number of machines. So shared VPC, also you can actually look at what are the limitations for shared VPC. Number of service project that can attach to the host project is up to 100. Number of shared VPC host project you can have it is 100. Number of host project to which a service project can attach is 1. Okay, so this is very important. For peering, you need to look at peering limits per instance, number of instances, etc., like per network, secondary IP, maximum tags. So all of these are like additional limits which you can make sure that you understand it. Routers, firewall rules, and forwarding rules. How many rules you can create, how many firewall rules you can create, how many routers you can create it. So all of that impacts your quotas and limit, and probably you want to have a look at it. let's take a look at some of the security requirements that we have it for VPC. And this is the first one is the bastion host. So what you can do is, if there are, think of it, right? There are some instances which are internal to your VPC and should not be accessed outside your VPC network. And you can think of you have database application server you want to isolate completely, or you have some processing or backend processing instances which are not exposed outside. What you can do is you can take the external IP address out from that particular VM instance, right? And your internal clients are connecting to those particular VM instances as and when it is required, and you are good with that. In case if at all you want to have the maintenance, right? You want to install some software or upgrade some software there, or you want to troubleshoot certain things, right? At the time of maintenance, what you can do is you can create a bastion host. This is another virtual machine within the network, and that network you can open the firewall to connect it to that particular instance and do whatever activity you want to do it. This instance has got access from the outside only for that particular maintenance window, and once the maintenance is done, you can just delete that particular instance. And this host is called as a bastion host. It is used for temporary purpose or maintenance purpose to connect the internal virtual machine or the instances at the time of maintenance. All other time there is no access whatsoever from outside network to these particular instances you can think of. That's how you can isolate your internal servers from outside world. The second aspect of the security is when your the services, in fact the instances wants to connect to your internal instances, and this is the external the network. So you may have two different network, maybe your data center or the network resources from any other project wants to connect your internal instance. That's where you can just go ahead and use NAT gateway. So typically if you look at the instance one does not have external IP address, right? And definitely it is not accessible from outside world, and that is how we can protect it, right? The instance 2 you can configure as a NAT gateway with IP forwarding rule in configured into the instance 2. What happens is instance 3 can connect to instance 2, and that the traffic gets routed to instance 1, and you can have the firewall rules configured in instance 2 only get the connections from the instance 3 from the other network. And this is actually, you can think of when you want to isolate the instance, but at the same time you want to have system access, and then you have firewall the connections to your other network. And this is, you can do a NAT gateway. We are going to see this in the demo for NAT gateway as well as bastion host. We are going to get into a demo and see this in action for NAT gateway as well as bastion host, guys. Thank you. VPC flow logs. So VPC flow log records a sample of network flow sent from and received by a VM instances. And you can think of it as like the network log. Whenever the network is being accessed by external entities or by the system, everything is logged in VPC flow log. By default, it is not enabled. You need to while creating it, or you can update it to have the flow logs created. This log is definitely large in numbers, so while enabling it, you need to make sure that you enable it and you have wherever you are storing those flow logs, you have the retention policy mentioned. So these logs can be used for network monitoring, forensic, real-time security analysis, and expense optimizations. The log collection, the flow logs are collected by each VM connection every 5 seconds, and this is the data annotated and sent to Stackdriver logging with the data format described here. The logs are stored in Stackdriver logging for 30 days. If you wish to keep the log longer, you must export them in the destination. And we are going to see those flow logs shortly. Use cases, you can do network monitoring, understanding network usage, optimizing network traffic, and this is again very important. If at all your network traffic is continuously going to the region, or the resources are not really near to your customer, that's probably you can go ahead and increase the backend instances in the network wherein there is considerable amount of traffic, right? So you can have multiple use cases like that to understand or get into details of the flow log. The way you enable flow log is in the console. If you go, so if I go here in my network, if I click on edit, I should be able to see. Okay, if I go and create the network, I can go and enable flow logs here. Okay, so it is part of subnet. Let me go ahead and use existing one. Flow logs are off. You can just go ahead and edit, and you can switch on the flow logs. Right now, all the flow, all the network access for this particular, the instances resides within this subnetwork will be captured in Stackdriver logging. And if I go in Stackdriver logging, so it took some time for logs to get in. So what you can do is you can either type subnetwork, or you can just go to GCE subnetwork, right, for this particular subnetwork, and you can get the you can get the logs for that particular subnetwork. And that's, so you only see this particular subnet because I just enabled it for one particular subnetwork. You can go ahead and enable it for all other subnetwork, whatever you wanted. I can go here and VPC network. So if I go here, default network, I can click here and edit, and you can enable flow log for those subnetworks. So that's how you can get actually the flow logs. As an example here, I tried to connect it from Windows NT, right, and you can see the details. Compute engine, this is the timestamp, okay, and this is the period. So likewise, you can get the flow logs and get the analytics done on the flow logs. If you have any questions on the flow log, let me know. Otherwise, you can move to the next lecture. Thanks. VPC pricing. VPC is built for egress traffic, and that is to the internet varied by region to region. From one region to another region in the same network, or between the zones within the region. So you need to make sure that when you are designing the network, you are designing it properly. It is not built for traffic ingress VM to VM in the single zone, or traffic to GCE services, and there may be limit applied. You can actually go ahead and see the pricing documentation, because these might have changed when you are watching this particular video. Another thing to note here is they have come up with the standard tier and premium tier to look at, and very importantly, you need to make sure that you understand standard tier versus premium tier. You can think of standard tier is like any other network public cloud offerings that we have available, like AWS or Azure, which they use public internet most of the time to transfer your traffic until your service, where in Google's context, they have fiber optic network and point of presence in many locations. So they route their traffic via their own fiber optic network near to the customer, and that's the premium tier. So when I was using it last 2 years, it was all premium tier. That's what I can guess it for. But now they have created standard tier as well to reduce the pricing, which will be incurred by the customer. That's it for VPC, guys. In nutshell, we are going to get in detail of demo, but if you have any questions on theory, let me know. Otherwise, you can move to the next chapter. Thank you. Cloud networking, hybrid connectivity. We are going to get into details of the connection between your own premises to your VPC. And we already saw VPC, how you can create your private networking in public cloud environment. Now we are going to see how you can connect that private environment or private network with your own data center, if at all you have it, or your office. So hybrid connectivity, or the connection from your own office to your cloud or your private network, is a part of networking service, and networking service is a part of one of the 3 core services that are available in public cloud environment. We are going to see, we already saw VPC, that's your private networking in cloud. We are going to connect the VPC with your own premises using VPN or interconnections, and we are going to get into details of that right now. So to connect your own premises with GCP, you have multiple options, and you can use based on what is the use case that you have it. So the first option, and this is just copy paste you can think of from Google Cloud Platform. The first option is Google Cloud Interconnect. And what is that? It is so this is required wherein you want to have considerable amount of data exchange between your Google Cloud Platform and your own office, not your end customers, but your own office or your own data center. And that's where you use Cloud Interconnect. We are going to get into details of Interconnect shortly, but wanted to just give you a high level overview. The other option that you have, if you do not want to have dedicated connection, is Cloud VPN. And this is, you can think of it's like traditional VPN or IPsec VPN, which you can use it over public internet. There is no physical connection exists when you are using Cloud VPN. It is just going via public internet. And why you use it? You do not have actually the use case to connect your Cloud Interconnect, or to have a dedicated pipe from the GCP VPC to your own premises. And that's where you will start with the Cloud VPN. It is low cost as compared to Interconnect, and it has got its own benefit and disadvantage as well. But that's the second service. The third one is the peering, and this is not purely a part of Google Cloud Platform, but you can think of peering is required when you want to connect your Google Cloud Google platform like G Suite applications. You want to access all other Google services, and you want to take advantage of reducing ingress fee, and that's where you use peering. You have multiple options there in peering, as a direct peering and carrier peering, and we are going to see the differences in all of those shortly. So the first one is Cloud Interconnect. So Cloud Interconnect let you connect your own premise or the data center you can think of with Google Cloud Platform. The additional advantage which you get it out of Cloud Interconnect is you have dedicated connection to GCP directly, and that's where you can exchange the data, you can exchange the network configurations. Like if you have a sub-network kind of implementation in your own data center, and your resources, virtual machine or physical servers wants to connect to the GCP resources, or GCP wants to connect to your own servers, that's where Cloud Interconnect will be able to help you to have dedicated internet connection or interconnections between your premises with Google Cloud Platform. So high level features. It's a low latency, highly available service that you can use it to connect your on-premise to Google Cloud Platform. You can have dedicated and partner connection options. So you may have a location wherein you can get connected to Google for its POP location, but there are some companies, they do not have interconnections or the location exactly near to the Google POP location. That's where you can go with the partner connection option. It supports RFC 1918. What does this mean? This means is you can have network exchanges between your on-premises and cloud, and all of these resources can talk to each other. You can create IP space, IP ranges, that the way which we have seen it in VPC, right? The similar way you can have the network connections or support between your on-premise or the office with your GCP VPC. And it is a direct pipe or private pipe you can think of. It is like data center, from your data center to Google Cloud premises. Another option that we have is direct or partner peering. And why do you use it? So this is not, you can think of, you want to exchange the network between on-premises with Google Cloud platform. So everything is, you can think of, everything is there in your in the Google, and you want to just take down your egress fees and you want to have high speed connection, and that's where you use direct peering. You're not exchanging any network information with Google Cloud platform using peering option. So the features, you can have direct connections with Google or partner wherever, if you are not available there with the direct connection. You can have VPN, which you can configure, or direct internet, like public internet, and you want to reduce the cost of egress fees, right? And that's where you use direct peering. The third option that we have is Cloud VPN, and this VPN is, you can think of traditional VPN. So why do you use it? It has got a SLA, an SLA of 99.9 service availability. You can have site-to-site connections, and you can create multiple connections to cloud environment or GCP environment from your own data center or offices. It supports cloud router, and we are going to get into details of what is that and what is that means to us as a cloud router. But you can think of, if you want to exchange the network information from your own premises with the GCP, because that's how GCP service resources can discover your resources on premises, the cloud router can be used. And you can have encryption or secure traffic using Cloud VPN, and that's where you use Cloud VPN. So in total, what we are going to look at is Cloud Interconnect, Cloud Direct and Carrier Peering, Cloud VPN, and Cloud Router. Cloud Router is just an additional, you can think of, the service which you need to use it to announce the network changes if there are any. And we are going to get into details. This is high level, you can think of decision tree, and based on this decision tree, you want to use one particular service over the other service to connect your on-premise data or on-premise office or your data center to Google Cloud platform. If you look at very high level, do you need direct access to your private computing resource on GCP? The answer is no. That's where you go to peering options, right? So this is where you are just accessing Google Cloud, right, from on-premises, and not your cloud resources accessing your on-premise data, and that is where it differs, right? Do you need to connect your G Suite? Yes. And can you meet peering requirement? If at all you are there in Google's location, you can do direct peering. If at all you are not there, there are partners out there who can actually get you connected to Google with their own connections, and that's where you use carrier peering. So this side, that's where you want to exchange the data between your on-premises and Google Cloud platform with the interconnections or the networking steps, and that's where you take this route. Do you need to extend your data center to the cloud? Yes, that's the requirement. Do you encrypt the sensitive information at the application level? If you encrypt the sensitive information on the application level, you can just go ahead and get into Interconnect, because Interconnect does not provide you the encryption for that particular pipe. If at all you need an encryption because your application does not do it, you should go for Cloud VPN. Okay, so if you if your application is encrypting it or you do not need any encryption for your data, you can take the interconnect route. Can you meet Google's at one of our POPs location, and that's where it says if at all you are there in the POP location, that's where you can choose this route, or you just go ahead and talk to interconnect partner and get it connected to Google, right? Is your need 10 GB or more, and that is where you have direct connections, because if it is less than 10 GB, Google recommend it to go with the partner because it's less, it's cheaper, right? Not going in too much detail here, but the high level thought here is, if you need an SLA, that's where you will choose dedicated interconnect and VPN. If you are least bothered about SLA, you will choose direct peering or carrier peering. Also, more importantly, if you want to exchange the network from your own data center with Google, or you want to have direct connectivity between these two, your own data center and Google Cloud Platform, that's where you will choose dedicated interconnect or cloud VPN. If you do not need, your on-premises resources talking to Google Cloud Platform, that's where you choose direct peering and carrier peering. If you are just accessing G Suite applications or collaboration platform and you want to reduce the egress fee, you are just going to go ahead and use direct peering or carrier peering based on where you are or where you are located. Okay, that's in a nutshell. We are going to get into detail of cloud VPN in next lecture. Thank you. Where you can actually go and explore the hybrid connectivity options, you can go to the console and you can go inside the networking, and you have hybrid connectivity, and that's where you see three options, right? VPN and interconnects are the connection option, and cloud router is just exposing or announcing your internet changes or network changes. So if I go here, you will not be able to see peering option here because peering is supported out of G Suite connection and not as a part of Google Cloud Platform connection. So you can go here and create a VPN connection. If you want to have VPN connection, you can go here and do interconnect connections if at all you have data center and you can replicate, and you can have cloud router connected created out of this one. We are going to see in demo for VPN. I will not be able to show the demo for interconnect because I do not have the data center to connect to, but I can show you the demo from one region to another region on the Google Cloud Platform itself, and then we'll add cloud router as well to announce the network changes, and we are going to see that in the demo as well. So this is all about the hybrid connectivity, guys. If you have any questions on here, you can wait for the theory for individual services, or you can ask me in our questions. Thank you. Cloud VPN. This is, you can think of is the VPN service we traditionally known for on IPsec. Typically what happens is you want to actually connect your on-premise data center or your office with Google Cloud Platform, and this is go via internet channel. It is public internet, and you can connect to GCP using VPN gateway or cloud VPN gateway, and we are going to see that shortly. But it is used for your on-premise VPN to connect to the Google Cloud Platform VPN, and we are talking about this particular VPN. We are not talking about on-premises VPN. You may have this hardware device or the software device on premises, but we are talking about cloud VPN in the cloud for GCP. So some of the features of cloud VPN: you can connect securely on-premises network to GCP VPC through IPsec VPN. You have high throughput via IPsec communication tunnel or communication channels, which you can use it, and if you need more throughput, you can just add tunnels, and that's it. It is scalable to take your data. It supports IKA v1 and IKA v2 both, and it can even run over Google Cloud Interconnect. We are going to see that shortly for encryption. ECMP over multiple VPN tunnels to achieve greater overall throughput. Traffic is encrypted by VPN as a default. It supports static and dynamic routing via cloud router. Supports high throughput, secure, reliable, and it is managed service. You don't need to manage anything on the Google Cloud Platform. It is managed by Google. SLE is 99.9% on monthly service availability. You pay for individual tunnels, and if you add in more and more tunnels, you pay multiples of that tunnels. VPN utilize edge location across the globe, so your data gets routed to nearest edge location that you have it. Cloud VPN uses ESP in tunnel mode with authentication, so Cloud VPN does not support AH or ESP in transport mode, and this is just a note. So how does actually everything works, right? So you have VPN or connection in your own data center or your office, right? And you have different departments like marketing and legal, and you want to connect to Google Cloud Platform, wherein your VPC is spread across 2 different regions. VPC in nutshell, it is global in nature, but you have subnetworks in region 1 as well as in region 2, and you want to connect your VPN, data center VPN, to the cloud, and that's where you can have different VPN routers connected for per region, and that is one per region. So you're connecting to region 1, then you'll have one VPN connections, and if you want to support the region 2, then you may need to have another VPN connection. You will need to have public IP addresses on both the sides of the connection. It can be either global or regional. It can support up to 3 Gbps of data individual tunnel, and it can scale horizontally with multiple tunnels if you add it. In demo, we are actually going to connect one region to the another one with VPN connection, as because I do not have on-premises or the data center which I can get connected to these GCP services. Okay, so where I work, I cannot actually demonstrate the data going from their data center or the company which I work for from there to Google Cloud Platform, as it is not allowed. So I need to showcase the demo wherein we connect region 1 to region 2 with VPN, and on top of it we'll add cloud router so that you see exchange of networking in both the places. That's it for Cloud VPN. We are going to get into demo in next chapter, but let me just show you where you can go and see the demo. So you go to networking and you go to network services, not really, hybrid connectivity, and that's where you see VPN, cloud, interconnect, and cloud routers. If I go here, I can just create VPN connection, and I can explain where you want to where I want to connect it. Network, which network I want to connect it, say custom VPC. If I make it, the region, which region you want to connect to for that particular VPC, and you can create it. We are going to have a demo for this one, but this is where you can just go and create a VPN connectivity. That's it for VPN, guys. If you have any questions on theory, let me know. Otherwise, you can move to the next lecture, which is demo for VPN. Thanks. Cloud router on Google Cloud Platform. Cloud router actually help us announcing or informing your network changes on Google Cloud Platform or your network or data center to each other, and that's the use of cloud router. So if you look at this particular scenario here, you have Google Cloud Platform and you have one particular subnet in one region. It says 10.21.0.0.16, and you have connections, VPN or virtual private cloud, VPC you can think of, and you have these connections with some means, like either it is VPN or peering, right, or anything, right? And then you have your own sub networks inside your data center, like rack 1, rack 2, and up to rack 29, right? So consider a case where you have added rack 30 here, and now this address space is also available, and you have provision the servers to use the IP range from this particular rack, right? How do you inform these network information to here? Or you can think of how these the resources from GCP can get to know or discover self these servers, right? There is no mechanism here. So in cloud router space, what you have is you have cloud router, which if at all any network is added on Google Cloud Platform, it announces the network changes to your on-premises BGP, and vice versa. If there are any changes on the network on your data center, this announces the information into cloud router so that it understands that there is an additional network resources, or the machines or physical machines or database servers, right, that is available for these resources to use it. And that is the ultimately goal of cloud routers. So typically cloud router provides BGP routing. It dynamically discovers and advertises routes. It supports graceful restart. It supports ECMP, as because it is the software device and not the hardware device. It supports graceful restart. It supports ECMP traffic, primary and backup tunnel for failover. It supports MAID, as path length, as prepend. Some of the thoughts around cloud router, or remaining thoughts around cloud router, is one router per region, peers with BGP on premises, advertise all subnets of the regions, link local IPs for BGP, private ASN on GCP, and private or public ASN on premises. So typically, if you look at the architecture and how it works, right? If you take the earlier example wherein you have two regions, the resources in two regions in VPC, and you have three different subnetworks, right, or two different subnetworks existing. So, and you have VPN connectivity established with your own premises, like you may have some departments, and there are resources, computers, database servers, or application servers, and like that, right? So what happened is, after you establish all these connections and you make all those routes configuration inside it, there is another sub network created out of, say, employee or legal, right? Legal or a customer as a department, and they need some servers in Google Cloud Platform as well as on premises. Now you have created sub networks, but who will announce the routes to the data center networks, right? So that is taken care by the cloud router. So it is one per region. If at all you have multiple regions, you need to have those cloud router, and this cloud router is connected to your on-premises BGP link, and that's how it can exchange the network information from GCP with your own data center. And that is ultimately, it is making sure that the routes are in place for all the network additions, whether it is on premises or whether it is in GCP. So in a nutshell, what is a cloud router? Cloud router is fully distributed and managed cloud service. It scales with your network traffic. It is not a physical device that might cause a bottleneck. It is software defined network or component. When you extend your on-premise network to Google Cloud Platform, you can use cloud router to dynamically exchange routes between your Google Cloud network and your on-premise network. And cloud router peers with your on-premise VPN gateway or router. That routers exchange topology information through BGP protocol, and this is standard protocol. You don't have to learn it from scratch. It is standard protocol to exchange the route information between different network. That's it in nutshell, guys, on the cloud router. We are going to see the demo of cloud router inside VPN, and we are going to have only one particular demo for hybrid interconnect, and that is VPN and VPN with cloud router. Okay, if you have any questions on cloud router, let me know. Otherwise, you can move to the next lecture. Thank you. Cloud interconnect. We have two different ways you can connect your data center using dedicated connection, and that is peering, one option, and that's where you do not need to expose your networking, on-premise networking, onto the Google Cloud, or you want to access G Suite collaboration. suite from Google, and you want to reduce the egress fees from Google Cloud, from Google, right? And that's where you use peering. And peering, you have two options. One is direct peering and carrier peering. If you are available, your connection point is available at the Google's edge router, then you can do direct peering. Whereas when you don't have connections, you go with the partner, and that is what it is called as a carrier peering. And this is just to reduce your egress fee, and you have dedicated pipe. For interconnect though, it's a different aspect altogether. You have two different interconnects as well. One is dedicated interconnect with GCP, and second one is with the service provider. With the interconnect, you are accessing GCP, Google Cloud Platform network, from your premises, as well as you're making your network available to Google Cloud resources, so that they can access it and they can communicate with each other. So this is dual advantage. It is not purely in the context of G Suite, as we have seen peering is in. So let's go ahead and get in details of when to use which one. GCP interconnect, dedicated private interconnect. Is it third party? It says no, because it is direct connection with Google. It supports RFC 1918. Yes. Does it support encryption? And this is public IP. No, it is not supported. It is, in fact, it is not required, because you are having dedicated connections with the Google Cloud Platform, right? Does it meet SLA? Yes, it has got a SLA, and you'll have services provided under SLA. If at all you're not there in Google's network or connection, then you go with the partner, and that's where the dedicated partner interconnection will come in play. Either you are available in Google's POP location, or you may have the requirement which is less than 10 Gbps pipe. That's where you use Google Partner Network. It is third party. It can support NAT. It does not require public IP or external IP, and definitely this is under SLA. So interconnect option is under SLA. Direct pairing definitely is not under SLA. You have direct pairing and carrier pairing in peering options. Direct pairing is not a third party, whereas carrier or partner pairing is third party. You can have RFC 1918. You can do that. Means it's not that it is not supported, but you want to have the VPN connection on top of your peering option, right? And that's where you will be able to use RFC 1918 IP ranges. Does it support public IP or external IP? It is supported. In case of direct pairing, in case of carrier pairing, it is an optional, and it is depends on the ISP as well. So typically, if you look at the layers, the dedicated interconnect and partner interconnect, these are layer 2 services. So you have VLAN connection to your data center or office premises, whereas peering option is layer 3 interface, and these are without the SLA. But you can have RFC 1918 support using VPN connection. If you want to enable, say, encryption, you can do that with the VPN as well, right? Here are some of the examples which are thought process on different use cases when you use direct pairing versus cloud interconnect. I'm not going to get into details, but in nutshell, what you need to remember is Google Cloud Platform is not necessarily a requirement for direct pairing, whereas interconnect gets connected to Google Cloud Platform. So let's look at some of the aspect of interconnect here. So if you are available in Google's peering location, right, or Google's POP location, you do your connections with Google, and this is what you call it as a Google direct peering interconnect. Okay. This is via partner interconnect. So as an example, you are not available in Google's location, co-location facility. You go with the service partner. Service partner providers also has connections with Google from the backend, and then you just connect with service provider, and that's how you can connect your data center with the Google Cloud Platform. Some of the high-level thoughts on interconnect. Interconnect allows cloud platform customer to connect to Google via enterprise grade connection. Google Interconnect has high availability and low latency network as compared to traditional public interconnect. Google supports direct connection to its network through direct peering and carrier interconnect. So direct peering means, again, it's not a peering option. It is like direct interconnect and carrier interconnect. So high level features: enterprise grade connections, reduce egress pricing, and it is integrated with the partners as well. So you can reach out to any partners, and there are a whole lot of lists using which you can get it connected to Google for partner peering. So these are some of the latencies which are there for the regions for cloud interconnect connections. I'm not going in details. Some of the considerations which you need to make sure that you understand it while making those decisions. Minimum deployment per location should be location is 10 Gbps. That is minimum. If your traffic doesn't require that level of capacity, consider cloud VPN if at all you need encryption on top of it. The circuit between your network and Google's network is not encrypted. If you require additional data security, use application level encryption or your own VPN. So you can have on top of interconnect also, you can have VPN so that you your traffic is encrypted while in transit. Currently you can't use Google Cloud VPN in combination with dedicated connection, but you can use with your own VPN solution. And this is some of the consideration. This is dedicated interconnect, which has capacity 10 to 80 Gbps per interconnect. The cost is reduced egress cost, fees for each circuit and VLAN. Require you to have routing equipment in co-location facility. If you require additional security, use application level encryption, because encryption is not enabled by default. Where in case of Google Cloud VPN tunnel, it is encrypted by default, so you have encryption enabled. You can go from 1.5 Gbps up to 3 Gbps per tunnel, and this is per tunnel, and you can just add many more tunnels if at all it does not allow your existing requirement. Traffic is billed same as general network pricing, fees for each tunnel, and requires VPN device on your premises network. And these are in nutshell the cloud interconnect, right? So what we are saying here is you can connect to your own data center with Google, and depends on what type of that particular requirement is you choose either the peering option or interconnect. And in interconnect you have dedicated peering interconnect and partner peering interconnect. Both has got plus and minuses, but you need to be available in Google's co-location facility. On top of it, you can use Cloud VPN tunnel, and this is the option you can start with to get it connected to Google Cloud Platform. And if at all your requirement is really high, you can think about having interconnect on top of it. So that's it, guys, for hybrid interconnections. So the connection between your data center or your office premises with the Google Cloud Platform, either to reduce the egress fees or to have secure channel or connection, or you want to have SLA based, the connection. We will not have any demo on Cloud Interconnect as such, but we will definitely have a demo on VPN and VPN plus Cloud Router. And that's it for all the theory, guys. If you have any questions on the interconnect, VPN, peering, or Cloud Router, let me know. Otherwise, you can move to the demo section. Thank you. This is odd man out topic here, the container networking, and why it is actually required to be discussed here is because container uses different kind of networking than the virtual machines, and that's why they have, I think, included it here. Before we get into what is the container networking, let us just high level understand about what is container or what is Docker and why it is used. Looking at this particular architecture here, if you look at typically, if at all you are using virtualization, typical virtualization, right? That's where you have hardware, you have guest host OS, and then you install multiple guest OSs on top of it to support different applications. So you can allocate resources like CPUs, memory, and all that per guest operating system. But at the same time, if you look at you are running the complete operating system to run your application.
In containerization though, that is not actually what it happens. So you have a host operating system, and then you install, you create a container, and that container contains the library which is required for that particular application to run it. So it is not the full OS like in virtual machines. In containers, it's like just the binaries which is required to run that particular application, and you can, you can install as many as containers as your hardware supports, the capacity you have it. But that's the difference between virtualization and containerization. So typically, if you look at the Google container management system, which is Kubernetes, they have open sourced it, and now even Amazon and Azure is also providing services based on Kubernetes container engine or orchestration tool. Typically, in any container system, you have master who is actually managing the connections and all those nodes and life cycle of each and every node, as well as the container inside these nodes. So that's the Kubernetes architecture. Typically, master has got actually, you can think of it as endpoint or doorway to the cluster to manage the cluster, like number of nodes and what you can push it to the cluster, like what are those containers, like that. So master manages all those nodes, and it is not a worker node as such. Your nodes in the cluster are the worker nodes, and those are actually the nodes which runs your containers. And in Google context or in Kubernetes context, you can club one or more container together in one particular pod, so they call it as a pod. So that is the unit which gets deployed across the cluster and gets managed. You can enforce auto scaling policy per pod, like you can maintain, say, if you push one particular pod which serve your website, you can say at least 3 services should be running, and it can go up to say 20 based on your load on those services, right? So that is the pod. And this is very important for us to understand the networking of Kubernetes engine, or GKE, traditionally that's what they call it. Pod has got two different entities. One is IP address. So if at all your application has got two different container, one is, say as an example here, Nginx, and the second one is memcache as a cache, right? So the IP address is shared with all those containers. So how you can expose your services outside, if at all it is required, you can add different ports for different containers here, and that's how the networking differs from traditional virtual machine instances. The container also shares the storage as well as the disk on that particular network, but that is an additional thing. But in the context of networking, Google networking as such, pod has got an IP address which is shared between the containers. That's what you need to keep an understanding. That's it for container networking, guys. If you have any questions on container networking, let me know. Otherwise, you can move to the next lecture, which is SaaS PaaS and infrastructure as a service. Thanks. Implement a GCP VPC. Let's go ahead and get into GCP VPC. We will just reiterate some of the concepts which we already saw in earlier section. We are going to focus towards VPC, configuration, subnetwork, firewall, and routes in this particular lecture. So overall objectives here, implementing VPC is configure VPC and its component, VPC sharing, VPC peering, etc. all in demo. Configuring routes, again in demo. Kubernetes networking, again in demo. Maintaining firewall rules, again in demo. So all of this is a kind of demo here. Let's go ahead and get into it. Let's go ahead and configure VPC here as part of this demo. If you look at the syllabus to cover for us, is the first one is configure GCP VPC resources, CIDR range, subnet, firewall rules, etc. Okay, let's go ahead and get into it. So we'll start with VPC resources. So we'll start with VPC resources. We'll configure VPC.
We'll add subnets, firewalls, all of that. So let's go ahead and get started. So I want to log into console. To do that, let me switch my account. I can go here into section network, and I can go to VPC networks, and you can find I have created one custom VPC out of one of the demo, but let me just go ahead and delete those networks. And I have default network already there. So let me go ahead and create the network. This time, however, I'm going to create two different network. One is auto network and the second one is custom network. So I would want to name it as auto network. So if you look at this one, you will have the subnetworks created for all your zones, which you can use it. The firewall rules already created, and default it says it's regional network. So the routing mode, I can actually get into global routing mode. DNS policy, no policy. I'll just go ahead and create one. So this is auto network. Let me go ahead and create custom VPC network, but this time I want to create USA West subnet. I want to select US West. Here you need to give the IP ranges. So let me give 10.1. So it says invalid IP range. So 10.10. // 24. Okay, private Google access off. Let me switch it on. Flow log, and this is one of the point that how you can enable the logs, flow logs in the for the network. Here you can go and enable the flow logs. And it says turning VPC flow log doesn't affect performance, but the system generate large logs, and this is for each and every request through its travel. You will get the logs for it. So I can just say add another one, and I can say subnet USA East, and I just wanted to select US East region. Google private access on, flow logs on. If you want to have secondary IP ranges, you can create that. I'm not going to do it. What is the problem? Okay, subnet range. So the early one that I have is 10.0. I'll just go ahead and copy this and put it here. Just the 11. Done. So 2 subnetwork inside my custom VPC, and I'm enabling global routing. So auto network is created. If you look at auto network, all the subnets are created by default for each and every zone that you each and every region that you have. But when you create a custom VPC, it will create only subnetworks which you have created or which you have asked for. Okay, so that is the difference between auto and custom subnetworks. If you go to firewall rules, you can find all these firewall rules already there, and it is attached to the networks. Okay, click on it and you can find firewall rules. For auto mode network, there are no firewall rules which are attached. I'm just going to add it. Just wanted to attach an existing firewall rules. Add firewall rules. I want to give, say, firewall HTTP. So do you want to enable the firewall logs on? I can switch it on here. Network, which network you want to create firewall rules for. Auto network, you can define priority, and this priority defines which firewall rule to be applied and in which order if there are multiple firewall rules are applicable at the same time. It says traffic, egress or ingress. I'm saying ingress. Allow, this firewall rule is allow. The target is specified target tag, specified service account or all instance in the network. I'm just going to go all instance in the network. IP ranges, you want to give a specific IP ranges or apply to a specific sub network, you can do that. I'm just not going to filter it now. Second source filter, if at all you want to apply it. Protocol that you want to open, specified protocol, TCP, 80 enable. So if it is says allow all, then it will allow just all the traffic to this particular network, which is bad idea to do it. But I'm just, for auto network, I'm just going to say allow all and create. Source IP is, I want to allow it from the globe to all my network. So this is going to create or allow all my internal virtual machines to take any traffic from outside world, and it is all protocols. If I go to custom, I can create different firewall rules here. Add firewall rule. I can say custom HTTP, and what I want to do here is, for all egress traffic, I want to just enable egress traffic which is going out of the network, and that is as because these VMs are accessing specific HTTP links, destination IP to all. And I want to enable HTTP web incoming all instances, but in specific subnetwork. The subnetwork which I want to do is, assuming my web servers are in west zone. Okay, I don't have any other tag. I can actually tag it to service account, or you can create a tag, network tags, which you can apply it. you can put forward the port 80 80 80, create. So if you look at the routes are already created default to the internet gateway, so that all the VMs can access the internet, and the routes are created for each and every subnetworks that are created out of VPC creation. VPC peering, there is no VPC peering currently. There is no private service connection. There is no internal static addresses. So that's all, guys. We have covered VPC creation, subnetworks, and firewall rules. We will get into more details about VPC pairing in next lecture. Thanks. Let's go ahead and to configure the VPC peering within the projects. So I have the networks, two networks, auto network and custom network. Let me go ahead and do a peering. So I want to do network peering with auto and the custom, add peering. So within project, so auto network paired VPC within this particular project. Yes, I have another one which is custom VPC. I can go ahead and create that. So this pairing is getting created. I can go ahead and add another connection. Within project 2. So from custom, now this time other way around, to auto network and create. So this is waiting for peer network to connect. And once this is the peering is established, you will see peering is enabled. I'll pause the video. Now it is created. I think it took around 2 minutes to get it connected. So the peering is established now. Now the VMs from this particular custom VPC can talk to auto network, provided that your firewall rules are opened to do the pairing. So this is how you can actually do the pairing. If you have any questions on VPC pairing, let me know. Otherwise, you can move to the next lecture. Thanks. Let's go ahead and set up shared VPC. In this section, we are going to go ahead and set this shared VPC, but to have this enabled, you will need to do some pre-task, and the pre-task are, first thing first, you will need to have G Suite domain. To have this particular G Suite, you will have 14 days of trial, which you can subscribe for it. The way you can, so you just can, I'm just logged in now, but you can actually go for trial G Suite in Google, and then you will get to the link and you can subscribe for it. Once you log in and create the G Suite, you will have organization created. So this is your admin page. You can create, you can manage devices, billing, company profile and all that, but let me go here and show you what is that I have. I just have the company name, systech.inc, info.gcptrain is my domain, gcptrain.page. This is the free domain which I got it from Google itself. While registering, you will get to know how to get the free domain, but this is what I have. and everything is as you can think of as a default. I have not done anything beyond what I have it here. Next thing is you need to log in or get into console with the same user ID password. If you look at the user ID password, info@gcptrain.page, and then you can actually go ahead and create multiple projects there, but you should go here into organization. So that's how you'll be able to see the organization. This will take some time, so whenever you are creating G Suite, you will need to wait for at least 1 hour. I think I was waiting for 1 hour. I did not actually try in between, but you can even get it very faster. So yeah, you need to wait for some moment or some time to get this reflected. What you need to do is you will need to delegate the permissions to some user. Okay, so that's what I have done it. I have actually this particular user which I'm using it for my trainings. So I given shared VPC. You can just, the way you can do it is you can just add, and you can, as an example, I can just give one up. You can go ahead and give share VPC, share VPC admin, but at the same time you will need to give the network admin as well. That's what I did. Okay, but we'll talk about that. So here you need to give share VPC admin. Okay, so I have given it for this particular user and folder admin as well for this user. Then I logged in with that user and I can see the host project. Okay, I can go here and now I can set up share VPC. So I'm just enabling share VPC. Now it is asking me whether you want to share all the subnets or individual subnets. So what I can actually go ahead and do is, because I'm in US West, I can just select US West and US Central. Only these two VPCs with the service projects. So you have that understanding, right? There is a host project which hosts the shared VPC, and there are service projects which can access or utilize that particular network. So I'm sharing this particular default US Central and US West, and I can just say continue. I have already created the placeholders like service project and service project 2. I am just giving it to these two projects, those network access, and what they can actually do: compute instance admin, network admin, owners, and editors. All of that, those permissions I'm giving it. If at all Kubernetes access is required, I can just go ahead and enable Kubernetes, and I can say save. So it says for Kubernetes engine enabled, host project should have Kubernetes access. Let me go ahead and disable it for now. I'll show that in the network exam. Because in that case, I need to go to IAM, and I need to add here another role, and I should say Kubernetes engine admin. Then only I will be able to do that side. But anyway, I'm not doing it right now. So now share VPC is there. Okay, which other project can go ahead and use it? Let me go here and I can go to service project, and in network VPC. So it is taking some time to get it ready. I'll pause the video. Project host resource was not found. Resource was not found. Okay, let me just go ahead and share it with only one project and see if it can do. I think I have some problem with the project too, but I will check that. In service project, you have already attached that and you have already available. So I can go here in my service project and in my account and go to VPC. Network shared to my project. So this is where you can actually see it. Okay. So the project ID who has shared the 234413. Host project 234413, and you can see the shared network here. Okay. I can go ahead and manage that. I can say detach. And I can attach, and while attaching I can say now individual subnet, and I can select these two and save. So only those two subnets should be available in the shared. So let's go ahead and create some virtual machines there. Compute engine, create. And I should be able to select the shared networking. Network. So I can either say in this project or I can say network shared with me from the host project. Now, if you go here, the default network was shared, and there are multiple options here. So if I go back and say 10.142.0.0/20, and this is for US East 1 in zone 1, and so I was able to select the sub network which is from the other location, and I was able to create it. So in nutshell, what we have done is we have created G Suite account. Then we have given the permissions to this particular user, to create share VPC and manage share VPC. You can think of this particular user is now network administrator for your shared VPC. And then we shared the VPC with other projects. I tried to share it with 2 projects, but I think it was giving us some errors. On project 2, I think project 2 has got some problems in it. But yes, we were able to share that particular network with the other service projects. So if I go back, we have created the instance, and that instance is created in service project using the shared VPC. That's all, guys, on share VPC. If you have any questions on share VPC, let me know. I'm going to put forward a list of items which you need to do, like getting the admin console, providing the permissions or giving the permissions for the user to create the share VPC, and then managing the share VPC in the UI itself. If you have any questions on this one, let me know. Otherwise, you can move to the next lecture. Thank you. Configure routing on Google Cloud Platform. So let's understand what is routes. Routes define path for the network traffic to reach from source to destination. It is just a direction how to actually how source can reach to the destination, with associated definitely a protocols in it. Cloud router, this is the router you can think of. It's SDN, software defined network router on Google Cloud Platform, and it's a control plane device. It is not a typically your hardware device traditionally, which sits in your data center and takes the traffic. So it has got a control plane as well as the data plane as well in it. So we are going to look at a cloud router as well. We have already seen this as a hybrid network, but there are some bits and pieces which need to add it in as a part of the syllabus. So if you look at the syllabus, we have configure internal, static, and dynamic routing. Second one is the routing policies using tags and priorities. And third one is the configuring NAT instances. Let's go one by one. Internal, static, and dynamic routing. So typically there are multiple types of routes which some of those we have already seen. That is the first one is the default route and the route to the internet gateway. This is created by default when you create a network VPC. And if I go back to this one, you can actually see, let me go to the network. And in network, you can go to routes. You can see the route to the internet gateway is already created for you. So you don't have to create it again. And it is all destination IP addresses like open to the world. And this is to the internet gateway. Second one is subnet route. And if you look at all these other routes, these are the routes which are related to or linked to each and every subnet in the VPC. And if you look at the destination IP, I'll take this particular example, 10.152.0.0/20. If I take this one, 152.10.152, and if I go to VPC network, you can find there is Australia Southeast subnet, and there is route actually defined to reach this particular subnet. Gateway takes one particular IP address, that is the first IP address, and additional 02 address is again taken by the network, and all other the IP addresses from that one is available for you to assign it. But that way routes are actually created for each and every subnet in the network. And there are static route which you can go ahead and create. If I go here and I can create a route, I can actually define a different route here, and that is the static route. Dynamic route, that is the dynamic route, and there are multiple aspects to the dynamic route, and we are going to talk more about dynamic route as a cloud router. But if I have to explain what is the dynamic route, if I go to say default network, and I can say dynamic routing mode, and it says if I choose the regional one, cloud routes will learn the routes only in the region in which they are created, and this is regional specific dynamic route and the global dynamic route. So it is for all the regions. So the dynamic route is you don't define them in a static way, the way it is defined it for your subnets. It is dynamic in nature. Whenever you add the different subnetworks, it gets published automatically and you don't have to do anything else there. So that is the dynamic route. More in terms of static routing, any route is configured in default or custom routes, that is dynamic route. If you look at all those routes created by default here, by default by virtual network, all of these are like static routing. Static route can use any of the static route next hop, and you can manage it manually. Dynamic routing. We are going to see the example which we already saw, and this is a part of cloud router. And we are going to see that in here as well as a part of syllabus. Not much as important here, besides whatever we saw already. Dynamic routing, or the routes are managed by one or more cloud routers. So cloud router should be there to manage it. The destination always represent an IP range outside your VPC network, and their next hop are always BGP address pair. And if you look at, there is a BGP link, and this BGP link is available for you to publish the routes if there are any changes. As an example, if you have added, say, legal and customer as a department, and you have created subnetwork inside your data center, that will get dynamically published or announced by using cloud router, and that is the dynamic routing. We do not configure them manually as a static routing. Or you can think of, if one of your network gets additional subnetwork, and then you want to publish that to your own data center, right, network, and that is published via BGP link, and you do not need to manage it statically. It applies to VPN and cloud interconnects, and that's the dynamic routing. Let's look at some of the routing policies. Routing priorities, routing applicability. Let's look at how routing priorities impact the routes. A typical routing applicability is as follows. The first one is system generated routes applies to all instances in VPC network. Custom static route can apply to all instances or specific instances depending on tag attribute of the route. Dynamic routes applies to instance based on dynamic routing mode of VPC network. Routing orders, subnet routes are considered first and the high priority one. If a packet does not fit in the destination for subnet route, GCP look for another route with most specific destination. If more than one route has same most specific destination, GCP consider priority of the routes. If none of applicable or matches the specific destination, then GCP drops the packet. And for us, more important part is if more than one route has, right, most specific destination, GCP considers priority of a route. So it is based on BGP MED, multiplex exit discriminator. Lower the number indicate higher the priorities. For example, if a route priority value as 100, higher priority than one that has a priority of 200. So the more the priority, more the number is, the lower the priority is. Route and network tags. You can apply tags. It will be applied to an instance that have at least one of the listed tags in the routes. If you don't specify the tag, GCP applies to the route to all the instances in the network. Before we understand next hop, let's go ahead and look at so let's go ahead and create a route. I can say my route, and network, let me select auto network, which was created for earlier exercise, and let me give the route to priority 1000. Let me say web traffic default. I'm just putting anything here, okay? So the route is getting created here. So this route is created. So with the destination IP address is this particular range, priority, this particular instance tag is web traffic, and next hop is internet gateway. If I create instance with this particular tag, then this route gets applied. So you can think of that, right, as a priority or the tags which gets applied to the instance. Applicable instances, currently there are no instances right now, which will show it here, but whatever you create in Auto Network, they will be able to see this route. Going back again to the theory. So static routes, so next hop, what is next hop? Next hop is actually where that route should look at if it needs to choose the path, right? And that's the next hop. For static routes, and it forces actually the traffic to the next hop. So in our case, I mentioned that it is the internet gateway, and that will be like next hop for us. If you don't specify tag, GCP applies the routes to all the instances in the network. Okay. Cloud routers, and we saw that cloud router is the router which does the BGP announcement if there are network changes. What will happen if the cloud router gets failed, right? Think of it is as the network or SDN network or software defined network as such. It is not a data plane. So if it gets failed, if the data is currently following through or going from one source to the destination, it will not be impacted much. Okay. And it has got a property of graceful restart. So if at all it gets failed, it will get restarted automatically. So you don't have to worry about the cloud router failures. It has got you can create a high availability using multiple routers if at all you want to have it. So that if at all, say, the link from your own on-premise router goes down to the cloud router, then you will have multiple ways to connect to your Google Cloud Platform resources. Here are list of parameters which you pass it while you create the routes: name and description, network, destination IP range, which we saw, priority, next hop, and the network tag if at all you want to put it. There are different you can think of the next hop addresses, next hop gateways, next hop instances. You can put all of those, or VPN tunnels. And if you look at our routes, if I go back and if I click on create route, you can find this next hop, and you will have the gateway, instance, IP address, or VPN tunnel. And network tag, as we said, if at all you apply the tag to a particular instance, this route will get applied to that particular tags. Configure routing on Google Cloud Platform. So let's understand what is routes. Routes define path for the network traffic to reach from source to destination. It is just a direction how to actually how source can reach to the destination, with associated definitely a protocols in it. Cloud router, this is the router you can think of. It's SDN, software defined network router on Google Cloud Platform, and it's a control plane device. It is not a typically your hardware device traditionally, which sits in your data center and takes the traffic. So it has got a control plane as well as the data plane as well in it. So we are going to look at a cloud router as well. We have already seen this as a hybrid network, but there are some bits and pieces which need to add it in as a part of the syllabus. So if you look at the syllabus, we have configure internal, static, and dynamic routing. Second one is the routing policies using tags and priorities. And third one is the configuring NAT instances. Let's go one by one. Internal, static, and dynamic routing. So typically there are multiple types of routes which some of those we have already seen. That is the first one is the default route, and the route to the internet gateway. This is created by default when you create a network VPC. And if I go back to This one you can actually see. Let me go to the network. And in network, you can go to routes. You can see the route to the internet gateway is already created for you. So you don't have to create it again. And it is all destination IP addresses like open to the world. And this is to the internet gateway. Second one is subnet route. And if you look at all these other routes, these are the routes which are related to or linked to each and every subnet in the VPC. And if you look at the destination IP, I'll take this particular example, 10.152.0.0/20. If I take this one, 152.10.152, and if I go to VPC network, you can find there is Australia Southeast subnet, and there is route actually defined to reach this particular subnet. Gateway takes one particular IP address, that is the first IP address, and additional 02 address is again taken by the network, and all other the IP addresses from that one is available for you to assign it. But that way routes are actually created for each and every subnet in the network. And there are static route which you can go ahead and create. If I go here and I can create a route, I can actually define a different route here, and that is the static route. Dynamic route, that is the dynamic route, and there are multiple aspects to the dynamic route, and we are going to talk more about dynamic route as a cloud router. But if I have to explain what is the dynamic route, if I go to say default network, and I can say dynamic routing mode, and it says if I choose the regional one, cloud routes will learn the routes only in the region in which they are created, and this is regional specific dynamic route and the global dynamic routes, so it is for all the regions. So the dynamic route is you don't define them in a static way the way it is defined it for your subnets. It is dynamic in nature. Whenever you add the different subnetworks, it gets published automatically and you don't have to do anything else there. So that is the dynamic route. More in terms of static routing, any route is configured in default or custom routes, that is dynamic route. If you look at all those routes created by default here, by default by virtual network, all of these are like static routing. Static route can use any of the static route next hop, and you can manage it manually. Dynamic routing, we are going to see the example which we already saw, and this is a part of cloud router, and we are going to see that in here as well as a part of syllabus. Not much as important here besides whatever we saw already. Dynamic routing or the routes are managed by one or more cloud routers. So cloud router should be there to manage it. The destination always represent an IP range outside your VPC network, and their next hop are always BGP address pair. And if you look at there is a BGP link, and this BGP link is available for you to publish the routes if there are any changes. As an example, if you have added say legal and customer as a department and you have created subnetwork inside your data center, that will get dynamically published or announced by using cloud router, and that is the dynamic routing. We do not configure them manually as a static routing. Or you can think of if one of your network gets additional subnetwork, and then you want to publish that to your own data center, right, network, and that is published via BGP link, and you do not need to manage it statically. It applies to VPN and cloud interconnects, and that's the dynamic routing. Let's look at some of the routing policies. Routing priorities, routing applicability. Let's look at how routing priorities impact the routes. A typical routing applicability is as follows. The first one is system generated routes applies to all instances in VPC network. Custom static route can apply to all instances or specific instances depending on tag attribute of the route. Dynamic routes applies to instance based on dynamic routing mode of VPC network. Routing orders. Subnet routes are considered first and the high priority one. If a packet does not fit in the destination for subnet route, GCP look for another route with most specific destination. If more than one route has same most specific destination, GCP consider priority of the routes. If none of applicable or matches the specific destination, then GCP drops the packet. And for us, more important part is if more than one route has, right, most specific destination, GCP considers priority of a route. So it is based on BGP MED, multiplex exit discriminator. Lower the number indicate the higher the priorities. For example, if a route priority value is 100, higher priority than one that has a priority of 200. So the more the priority, more the number is, the lower the priority is. Route and network tags. You can apply tags. It will be applied to an instance that have at least one of the listed tags in the routes. If you don't specify the tag, GCP applies to the route to all the instances in the network. Before we understand next hop, let's go ahead and look at so let's go ahead and create a route. I can say my route and network. Let me select auto network, which was created for earlier exercise, and let me give the route to priority 1000. Let me say web traffic default. I'm just putting anything here, okay? So the route is getting created here. So this route is created. So with the destination IP address is this particular range, priority, this particular instance tag is web traffic, and next hop is internet gateway. If I create instance with this particular tag, then this route gets applied. So you can think of that, right, as a priority or the tags which gets applied to the instance. Applicable instances, currently there are no instances right now, which will show it here, but whatever you create in auto network, they will be able to see this route. Going back again to the theory. So static routes. So next hop, what is next hop? Next hop is actually where that route should look at if it needs to choose the path, right? And that's the next hop for static routes, and it forces actually the traffic to the next hop. So in our case, I mentioned that it is the internet gateway, and that will be like next hop for us. If you don't specify tag, GCP applies the routes to all the instances in the network. Okay. Cloud routers, and we saw that cloud router is the router which does the BGP announcement if there are network changes. What will happen if the cloud router gets failed, right? Think of it is as the network or SDN network or software defined network as such. It is not a data plane. So if it gets failed, if the data is currently following through or going from one source to the destination, it will not be impacted much. Okay, and it has got a property of graceful restart. So if at all it gets failed, it will get restarted automatically. So you don't have to worry about the cloud router failures. It has got you can create a high availability using multiple routers if at all you want to have it, so that if at all say the link from your own on-premise router goes down to the cloud router, then you will have multiple ways to connect to your Google Cloud Platform resources. Here are list of parameters which you pass it while you create the routes: name and description, network, destination IP range, which we saw, priority, next hop, and the network tag if at all you want to put it. There are different, you can think of the next hop addresses, next hop gateways, next hop instances. You can put all of those, or VPN tunnels. And if you look at our routes, if I go back and if I click on create route, you can find this next hop, and you will have the gateway, instance, IP address, or VPN tunnel. And network tag, as we said, if at all you apply the tag to a particular instance, this route will get applied to that particular tags. Clusters with shared VPC. We are not going to get into details of demo here because we have seen 2 clusters created, right? We'll just go ahead and put forward some thoughts around the cluster and shared VPC, how it'll impact. The clusters that use a shared VPC cannot use legacy network. It has to be alias IP, the later part, the later cluster which we created. You cannot convert existing cluster to shared VPC cluster. Quota does apply. There are some numbers which may get impacted, like number of nodes, number of networks which you are using it. Using the service account to create a cluster, having necessary permissions. So as we understand, right, and we already saw this for share VPC, there is a host project and then there is a service project or the service account. So all that permissions actually driven through service account. That service account using which you are creating a cluster should have enough permission to create or use the network resources from the host project, and that is very important, right? So that is the consideration you can think of when you create a cluster in shared VPC. There is another point for us as a private cluster. What is private cluster? So private clusters ensure that the traffic stays within your internal RFC 1918 address space. There is no external IP address range which is supplied to the pod or to the nodes, and that is very important, and that is what we call it as a private cluster. So cluster which is used internally within your GCP network. You can still go ahead and expose your master to outside world and keep all other items, all other nodes or pods inside your cluster, and you can use the load balancer to reach the traffic to the internal services. But that is the private cluster. Private cluster concept itself is that you don't want to have cluster access from outside world. Private cluster use, you can actually use HTTP load balancer or internal load balancer to accept the traffic. You can have VPC peering. So like the nodes are in different VPC and master is in different VPC. If at all that is the case, then in that case, you can have VPC peering to connect those nodes together. Private Google access. So typically if you look at, if at all you don't have access to the internet, then your cluster needs to have private connections to the Google services, right? And that's where you can use private Google access in the private clusters as well. There are some limitations for private clusters. Each private cluster you create uses unique VPC network peering. The size of RFC 1918 block for the cluster master must be /28. While GK can detect overlap with the cluster master address block, and it cannot detect overlap within the shared VPC network. And this is a very important consideration when you create a private cluster in shared VPC. And that's it for private clusters. Let's move ahead and understand the next concept here, the cluster network policy. If you look at the network policy, it is fine-grained control you can think of, or access permissions which you can enforce in your pod and services. If you look at the architecture here, your client accesses service, and service is abstracted layer on top of your pods, right? Depends on scalability, auto scaling, and all that. Pods can be one or multiple, but service actually takes care of routing your traffic to the backend. In GKE or Kubernetes environment, this particular service also called as a deployment in simple world. But with network policy, what you can do is you can define the policy between which service can talk to what pods in the backend, and that is possible using the network policies. It enables defense in depth. Example, in case of multi-application cluster, you can restrict communication between your application service and pods. You can define tenant per namespace, and which means you can define a different namespace for different applications. With the network policy, you can restrict communication between those namespaces. As an example here, consider this particular app is demo, and you created some namespace here. For each and every application, you can define one namespace and restrict the communication between your namespaces. That you can do with the network policies. The simple way to enable the network policy is enable network policy. That is while creating your cluster. Or you can even go ahead and update the network policy using update add-ons equal to network policy is equal to enabled, or enable network policy is equal to node. So you can give the same parameter here as well, the parameter which you use it while creating the cluster. But if you update the cluster using enable network policy, it will recreate the node pools, which is like deployment. So it is just that particular consideration which you need to have it. So that is all about network policy. The last point that we have is adding authorized network for cluster master access. What do we mean by that? So if you have a cluster, right, and that particular cluster used by only specific subnet range or CIDR range, you can actually add that authorized network in your cluster. That way your access for that particular cluster is restricted to only those particular client or CIDR ranges, and that is your authorized network. So you can configure authorized network to whitelist specific CIDR range and allow only IP address from that particular range to access cluster master. Authorized network compatible with all type of cluster, whether it is private cluster, IPLSS, or route-based cluster. A cluster can have no more than 20 authorized network CIDR ranges, and this is, you can think of a limitation. You can enable authorized network for private cluster as well. How to enable? You can actually just use this particular parameter like -- enable master authorized network, and you can provide what is that particular CIDR range is, right? If you have multiple CIDR ranges, you can provide multiple CIDR ranges. While updating the cluster, you can use the update command, cluster update, and you can give the same parameters: enable master authorized network, and CIDR ranges. You can actually verify the command using verify if the CIDR ranges are applied, and this is the describe command. I can actually give an example or the demo for this one. Master authorized network config CIDR block this one and enabled is true. You can go ahead and disable as well, so no enable master authorized network. And that's it for adding authorized network. So authorized network is typically, you can think of, you are providing access for your cluster to a specific CIDR blocks, and you can add as many CIDR blocks you want, and you can go ahead and verify it, or you can go ahead and disable that particular master authorized CIDR block as well, based on your need. That's it for the networking on Kubernetes engine, guys. If you have any questions on Kubernetes networking, let me know. Otherwise, you can move to the next lecture. Thank you. Configure and manage firewall rules as per the syllabus. What is firewall rule? We already saw as an overview or high level what is firewall rule in VPC. It is a kind of lock to your traffic in both the direction, whether it is egress or ingress, the traffic coming into your virtual machine or traffic going out of your virtual machine. As a syllabus, if I look at, there are 5 different aspects which are asked or will be asked in your exam: target network tag, service account, firewall rule priorities, network protocols, egress and ingress rules, and firewall rule logs. Let's take one by one. But before we jump onto the syllabus, let's understand what is firewall rule. So firewall rule let you allow or deny traffic to and from your virtual machine instances based on configuration you specify. While firewall rules are defined at the network level because you choose the network while creating a firewall rule, the connections are allowed or denied on per instance basis. So even though it is defined at network level, the connections or the traffic is allowed or denied at per instance basis. GCP firewall rules as an existing not only between your instance and other network, but you can define it individual instances within the same network. So you can actually apply the firewall rules within your network as well. Firewall rules only support IPv4 traffic. Each firewall rule action is either allow or deny. Each firewall rule applies to either incoming or outgoing traffic, which is ingress or egress traffic, but cannot be both. So you cannot create a firewall rule which will define ingress and out and egress traffic in one particular rule. When you create a firewall rule, you must select VPC network. So it is attached to a VPC network. GCP firewall rules are stateful, which means if the connections are or the data packets is sent from source to the destination with every 10 minutes, it is considered as a stateful. It is considered as stateful connection. Firewall rule cannot allow traffic in one direction while deny the associated traffic in the return. So you cannot have a traffic which is allowed, say like SSH traffic allowed from A to B, and you have denied traffic from B to A because there is no feedback or that is not the way the network works. GCP firewall rule do not reassembles fragmented TCP packets. There are some implied rules. Implied rules allow implied rules, which is like egress rule for all destination, which is internet gateway. This particular rule has got a lowest priority 65/535. So this is allowed. So all the traffic leaving your virtual machine is allowed by default unless and until you put forward the firewall rule which has got a higher priority and restricts some traffic. Implied deny ingress rule. An ingress rule whose action is deny the sources. So all ingress traffic coming to your virtual machine is always denied, even though it has got a lowest priority. These implied rules, you cannot remove it, but you can actually go ahead and change the priority of those rules, because if at all you want to use these priority numbers to some other rules, which based on your network design. Pre-populated rules for default rules. Default allow internal, so all internal communication is always allowed, like VM1 within the same network can talk to VM2 or VM3 like that. Default allow SSH, so this is a rule again created and by default for you. You just need to attach these tags to your virtual machine instances. Default allow RDP 3389 port. Default allow ICMP. There are some always allowed and always denied traffic. So if you look at what is always allowed traffic, the traffic which is DSCP, traffic for DNS resolution, traffic to get the instance metadata, and NTP. NTP is network time protocol using which the clock for the VM gets synced based on the requirement. There is always block traffic, whether it is GRE, maybe hacking, or some trying to continuously hit your services. Protocol other than TCP, UDP, and ICMP and IP. or egress traffic on TCP with the port number 25 SMTP. So all of these traffic is always blocked. Components of firewall rule. Firewall rule has got a priority associated to it. Direction, whether it is egress or ingress. Actions, allow or deny. Target, source in case of ingress. In case of egress, it is destination. Protocol and port. Let's go ahead and look at all these parameters. There is an additional attribute which is called enforcement status. Whether you want to enable the firewall right away or enable firewall, you can actually disable it for some time. Let's go ahead and look at the firewall rules. So if you look at, as we said, there are some default firewall rules which are created by default. Let me go ahead and choose. So if you look at all these firewall rules, like default allow HTTP, default allow HTTPS, I have created this my firewall. Default allow ICMP, internal, default allow RDP, SSH, and then I have some custom rules which are created. That is default allow SSH, custom HTTP, HTTP web, and firewall HTTP. I can give you an example here. I can create, say, my firewall web traffic. I can turn on the logs, and these are the logs using which we can see who is connecting your instances or connecting to backend your instances. And this note is very important. It is large number of log, because for each and every traffic connection you will have a log associated to that, and it will log continuously into Stackdriver. So you may incur major cost if at all you enable it. But for your sensitive traffic, you can just go ahead and use it. All other times you can just switch it off. You can choose the network, which network you want to connect to. I'm just leaving default as is. I can give priority here, and the priority actually goes from 0 to 65, 535. You can provide the direction, whether it is ingress coming into your VM or egress going out from your VM. Action, whether it is allowed or denied. Target, you can specify all instance in particular network. Specific tags, you want to actually attach it to a specific tag, or specified service account, and we are going to talk about it shortly. If at all you want to specify or use the tags, then you can give, say, traffic web as a tag. So this, whenever you attach a tag, it will be applicable to that. Destination IP ranges, I can give, say, the whole world, right? And I can say allow TCP 80, 80 traffic. So the firewall rule is getting created. So firewall rule is created. You can actually go ahead and edit the firewall rule. So you can change the loggings, you can change the priority, but you cannot change the egress or the action, direction and action, because that's how firewall is defined. And you can change the port or allow all. You can change the destination IP ranges, or you can choose different target altogether. So let me just save it. So that's the firewall rule. You can create ingress and egress both. So let's go ahead and see, when we say ingress traffic, right? Ingress firewall rule, what is that? So both of these rules has got a either allow or deny as an action. But what it changes, in case of ingress, it defines a target, and this target is whether you want to apply to all the instances inside your the network, or instances by service account, or instance by network tag, and the source from where actually that traffic is originated. And that's where you want to say the traffic coming in from the world, I'm going to allow it, or I want to allow traffic only from this particular IP ranges or this particular subnet, right? Or instances using a particular service account, or instances using a particular network tag. So apply this particular firewall rule to those, and then you can specify protocol and port. If you look at the egress rule, instead of source, it gets actually destination. So your traffic is leaving your virtual machine, and that's where you can specify the IP address or the IP ranges where you want to hit to. And again, target defines the source from which actually what you want to do. You want to actually apply this target this rule for all the instances in your VM, or by service account, or by network tags. If I go back here and see, so if you look at this one, default allow SSH, it says all instances in the network. It will be applied to all the instances in the network. You can actually change it to the network tag, and unless and until this particular network tag is there, the traffic will not be allowed. Even though this is attached to, say, default network, it will not be allowed. Okay. So that's the firewall ingress and egress rules. The priority, as we said, the lower integer or the lower priority indicates the higher priority. Default priority is 1000, and you can actually change that. Priority application based on the target, if at all there are same priorities. Highest rule applicable for protocol and port. Highest rule for allowing, say, ingress over the lowest priority, for denying the rule for the same target. A rule with deny actions override allow actions if the priority is same. So as an example, if your traffic is allowed from, say, network 1 to network 2, and at the same time, I'm just saying the word because it is applied to an instance actually, but I'm just saying high level thoughts, right? So if there are traffic allowed from network 1 to network 2, you cannot have traffic denied from network 2 to network 1, or you can think of likewise the VM instances. A rule with the same priority and the same action have the same results. Let us go ahead and understand the service account and firewall rules, because that is another topic which we have it and we have to cover it. So the instances, if you remember, the instances which use a service account, you can actually apply the service account rules or the permissions to an instances, and application running inside the VM can have the permissions which are associated to the service account. So you can allow the Google Cloud Storage, bucket creation, object modifications, or even object deletions to one service account. And if that service account is used by the client which is inside that particular virtual machine, then it can do all that things right together. But if at all, so the service account says only read the cloud storage bucket and not to modify any bucket or the objects, then that particular virtual machine instance will not be able to modify anything in Google Cloud Storage. Likewise, you can apply the same logic here and say that if at all service account A is used by a virtual machine virtual machine 1, then the permissions or the firewall rules, including the firewall rules you can think of, is getting associated to that particular instance. So in nutshell, what we are saying is, if say VM1 wants to talk to VM2, and when you define that particular communication and you attach it to the service account, if at all VM1 is using a service account, that particular service account, then only VM1 will be able to talk to VM2, and that is based on the service account. So both ingress or egress rules, you can use service account to specify target. For ingress rules, you can specify the source of incoming packets as a primary internal IP address of any VM in the network where VM uses particular service account. Service account must be created before the firewall rule, so you cannot have the future service account for the firewall rule. Firewall rule that uses service account identify that apply VM using service account or when the service account is attached to the new VM. You can think of once your firewall rule is created for a particular service account, it will be applicable immediately, right? If the virtual machine is created afterwards, even though it is using the service account, the new service account, it will be applicable. Likewise, means whenever it is using a traffic, so it is applicable to existing VM instances using the service account as well as the new VM instances which will be using the service account. So which one to choose, right? So whether we use a service account or the network tag. Network tag is very high level. You can attach it to the VM, or you can attach it to a different VM. You can think of service account is more stricter or granular control which you have it, and that is what you can use it inside your virtual machine, and that is very important aspect here. Even though the management using the network tag is very easy, and managing service account is somewhat complex than the network tags, because service account can be used for different purposes, giving permissions or access to different cloud services, and network is one of the additional facility which will be used by the service account. So if you want strict control, use service account. If you do not have strict control, then or you do not want to use strict control, then you can just straight away go ahead and use network tags. A network tag is an arbitrary attribute, and service account represent an identity associated with an instance, and that is very important. So here are some rules which you can which you need to remember while using the service account. You cannot use target service account and target tags together in firewall rules. So you cannot have, say, tags as well as the service account together. Changing service account for an instance requires stopping and restarting it. Adding or removing tags can be done while the instance is running. So this is an important actually distinction. Only one target service account can be specified per firewall rule. More than one target tags can be specified in the single firewall rule, and this is another distinction which you have it. Only one service account can be specified per ingress firewall rule. More than one source tag can be used or specified in single firewall rule, and this is the distinction which you have it. You identify instances by network tag. The firewall rule applies to the primary internal IP address of an instance. Logging. Logging can be used for different purposes, and we saw that there is a flag which you can use it. Either you can allow logging for the traffic, or you can decide by default it is off, but if you can actually choose to make it on for sensitive traffic. So firewall rule logging, you can use it for audit purpose, you can just use it for verification purpose, or you can analyze the log and understand your traffic, how the traffic is flowing from one to another one. Options for every firewall rule, only for TCP and UDP traffic and not ICMP and all other traffics. You cannot enable firewall logging for default rules or implied deny or implied allow rules. Log entries are written from the perspective of virtual machine instances, and this is very important. Connection record is created for traffic. Some of the considerations, if you look at logging and the type of virtual machine which you are using, for F1 micro, maximum number of connections in 5 seconds, that is 100 connections. G1 small, you can go up to 250 connections. Machine type with 1 to 8 CPUs, you can have 500 connections per vCPUs, and machine types with more than 8 vCPUs, you can go up to 4,000 connections, which is, you can think of, per CPU is like 500, and you can actually multiply uh, that to 8. But you can, even if you increase the vCPUs beyond 8, you will not get more than 4,000 connections logging. That's it for a firewall rules. If you have any questions on firewall rules, though it is theory or practical, let me know. Otherwise, you can move to the next lecture. Thank you very much. Load balancer, high availability, and auto scaling. This is, you can think of network service essentially, but that comes in compute service because it is related most of the services which we will use as a backend from the compute, and I do not actually, I'm not able to differentiate that because all other container service or app engine, they have got their own internal load balancer. Purely in the context of compute service, we can just see simple plain the learning way for the load balancer in terms of high availability as well as auto scaling in one particular chapter. This is considered as a load network service in your syllabus, but I'm actually teaching it here or taking it here because I find it most appropriate to the compute plus network, and this is the right time for you to understand load balancer. Let's go ahead and get started. What is load balancer? Load balancer actually takes the request from the customer or any user and distribute the backend, distribute it to the backend services. That's the load balancer. So whether the user is from anywhere, it will just take the request and distribute the traffic. How the traffic will be distributed, Google has its own way of actually doing it, and Google load balancer is, or you can think of external or HTTP load balancer is SDN device. It can actually route your traffic based on where the customer is located. Okay, so the external load balancer is facing outside your GCP, where internal load balancer is within your GCP and between your different services. So that's the difference between external and internal load balancers. In external load balancer, we have HTTP, HTTPS load balancer or SSL proxy load balancers. The regional load balancer, which is like external to the GCP, also considered as external load balancer, and that is also called as a network load balancer. Let's go ahead and get some benefits out of the load balancer. So you can actually scale your application because as and when it is required, you can spin up many more instances, and then the traffic is routed to the new instances. It supplies heavy traffic, detects and automatically removes unhealthy, and this is very specific in GCP world. Okay, it is not applicable to all the other installations, or I won't actually guarantee you that this is the same concept applied to GCP, AWS or Amazon. Okay, so it detects and automatically removes unhealthy virtual machine instances that become healthy again, are automatically added. The health check-in configuration is used to identify health checking for the instances. It reroutes the traffic to the closest virtual machine, and that's the intelligent routing. We will talk about that very shortly. Before we get in details of the load balancer in detail, first we need to understand the terminologies which we learned already, as an instance template, which is a global resource, and that template defines machine type, image, zone, and other instance property for the instance in managed instance group. Okay, what is the instance group? So using instance group, you can actually define auto scaling policies, and we have two different instance group. One is managed and second one is unmanaged instance group. You can actually just look at managed instance group actually points to the instances which are in the same template, and so all the instances which instance group is managing, it is identical in nature. It can be used for auto scaling. You can do rolling updates. changes to the instance will make the changes to all instances because everything is identical. Load balancing is possible for all those instances. Similarly, unmanaged is non-identical instances, and we saw this already. You cannot have auto scaling because it doesn't know which one to spin up, right, when the load is increasing. A rolling update can't be possible. You can make arbitrary changes to any instance, and that is advantage. It is just that you are managing group of instances together in unmanaged instance group. Load balancers, typically, as we said, you will get a request in your DNS or anywhere, and that is getting routed into multiple backend services, whether the service resides in one particular region or multiple region. That does not really problem, because this load balancer in Google's context is SDN device, and it is global in nature. You can either route plain simple the traffic to backend in round robin fashion, or based on the usage or CPU usage of the backend instances. But at the same time, you can route the traffic based on type of the request is. As an example here, if you look at if there is a static request, which goes back, it will go to some instances. If it is PHP request, it will go to some instances like PHP related instances, and if it is a video, then it will go to some other instances in the backend. You can actually do this with load balancer. We saw this already, like the load balancer and how load balancer works, how the traffic gets routed via cloud load balancer and gets into the backend, and how actually the traffic gets routed to the nearest to the user. And I'll just run through this one very quickly within a minute. I hope so. So DNS has actually connection with the load balancer, and that's where the IPs are configured. When there is a request initiated from the central location, the load balancer understand that the request is from central, and it will route the traffic to the backend instances, whether it is compute or any other backend, to the central. If the traffic is from east, it will get routed to the east. If the traffic is from west, it will get routed to west. Consider a case wherein there are considerable amount of users logged in from the west, and the number of requests are getting continuously increased, and the CPU utilization for those boxes get more than 80%. That's where autoscaler will kicks in and will try to create additional instance for those services. But at the same time, what will happen is some of the requests, as because in the process of auto scaling gets triggered and usage is say 70 or 80% high based on the threshold which is configured for auto scaler to trigger, the requests, some of the requests will get transferred to central backend instances, just to make sure that the requests are served in expected latency. And we are going to see this in actual demo. So once we have actually the additional backend from the west zone created, load balancer will create a connection and will start actually sending the traffic. In between, what will happen, what is considered like what happened is the central instances just disappeared, right? In this case, there is no one actually to serve the traffic from the backend. The load balancer understand that there is no one to serve this traffic from the central. It will just route it to next nearest location, and it's not only the location. On top of it, it will just try to calculate how many requests which are being served by the backend instances, plus the CPU utilization and all those parameters based on your again configuration, and it will route your traffic to the next available plus who has a capacity to serve the traffic, right? That is an intelligence which is built in load balancer, so that is taken care, so you're not experiencing any issues as such from the customer's point of view. There are different type of load balancer that we have it. I'll just go to the console and show you so that we can even get started there. So if you go here and look at networking service, I don't find it. Okay, so it should be in compute engine. I don't see it. Where is that? Oh my god, I need to just find it out, right? Network service. That's where it is. Load balancer. Okay, I need to delete this. If you go to create load balancer, you will be presented with this UI. So the first one is HTTP load balancer. Okay. Second one is TCP load balancer, and this actually used for TCP, SSL proxy, and TCP proxy. It is internet facing as well as internal to single or multiple region. HTTP load balancer, internet facing only, and it can actually have single or multiple region as a backend. UDP load balancer, this is again internet facing. It could be internal, internet facing, or internal single region. So you need to make sure that the single region is very important here. Okay. So in a high level, if you look at, there is a global load balancer and then there is a regional load balancer. In global load balancer, you have HTTPS load balancing, SSL proxy load balancing, TCP proxy load balancing, right? And then in regional, you have regional external and regional internal load balancing. For regional external, they call it as network load balancer, and for regional internal, they call it as just internal load balancer. This is the decision tree which we have it to choose between the load balancers, which one to use. The simple thumb rule is, if your traffic is HTTP or HTTPS traffic, just go ahead and use whether it is global or regional, or whatever you do, that just use HTTPS load balancer. If your traffic is TCP traffic and you do need SSL offload, you use SSL proxy load balancer. If you do not need SSL offload, that's where you can use TCP proxy or network load balancer. Okay, this is again the regional one. For internal IPv4 clients, it is just an internal load balancer. Whatever you have it, you just need to use internal load balancer. Load balancer ports, there are different ports supported by different load balancer, as because the protocol which we use it. As an example here, for HTTPS or HTTP, it will either use AT or ATT. For HTTPS, it is very standard 443 ports. For SSL proxy with TCP with SSL upload, you will have these options out of GCP provided. All of these are like numbers. I don't think you need to remember these numbers for your exam. You just need to understand that there are different ports which are available for different load balancers. This is internal architecture. I'm not sure whether you are bothered about it, but I just wanted to give you high level thoughts around it. When request actually comes from anywhere like DNS or any internet, the first thing which will kick in inside the load balancer is global forwarding rules, and that will pick that request. It will check the target proxy, URL map, and backend service which he has to hit, and it will hit the backend services. For the backend services to understand whether the instance is healthy or not currently, it uses the health check, and that information is available. It is an internal, you do not need to worry about it, but the backend service, you configure the actual endpoint, and health check, you configure different numbers like how much time you want to do a health check and what is the link for a health check. Let me go here and just click on start configuration. So what it asks? It asks you the name of load balancer, GCP train CELB. Okay, create. I just created. I have not created it. I need to give the configurations, right? What is the backend service which I have to give? One is backend service. Second one is I can just give a bucket to retrieve that information. Create backend service, and I have to give GCP train C backend. What is that? Your hop, next hop. So when load balancer actually looks at your request, where it should get routed, whether it is instance group or network endpoint group, I can actually configure that here. Network endpoint means any endpoint which is required to take your request, and it could be anything, right? I'm just putting here instance group and add backend service. I do not have any instance group right now, so to create, I'll just cancel it. What additional information it needs? The host and path rules, like host and path rule determine how your traffic will be directed, and you can direct your traffic to backend service or storage bucket. Any traffic not explicitly matched with the host, the path rule will be sent to a default traffic. Okay, I can actually go ahead and create, if there is GCP trainc.com for images, route it to, I do not have any backend configured, so any cloud bucket, GCP bucket that I have configured, so you can route it to bucket, or for PHP instance you can route it to virtual machines. Front end path, similar. Front end IP address, what is that? And this is specify IP address, port of and protocol. This address is the front end IP for your client request, and this is where it will hit. It's a HTTP protocol or HTTPS, because we are talking about HTTP load balancer here. And network service tier, whether it is a premium, current project level tier, or standard. And if you want to understand that, traffic traverse Google high quality Google backbone entering existing Google edge peering closest to the user. Standard means this will be routed to closest to region destined. So traffic enters and exits Google network at the peering point closest to the cloud region it's destined for originated. So this is standard means it can even take a public internet for a longer distance, and traffic will be routed like that. So premium is the standard right now which we are using. I'm not sure how this actually differs your pricing as of now, because this option was not available earlier. IPv4 or IPv6, which traffic you want to serve. I'll just put 80 there, and that's it, right? I can just name HTTP-LB, and you can add additional IP and ports. I just said this one, and you can add additional ones. I do not have complete configuration here. I just wanted to give you high level thoughts there. Let's go ahead and proceed further on HTTP load balancer in detail in next lecture. Let's go ahead and get deep into HTTP load balancer. It is global external load balancer type. Usually, HTTP load balancer or any load balancer use load distribution algorithm to route the traffic to the backend instances. In this particular case, HTTP load balancer actually does it's a request per second or CPU utilization of target backend instance. You can actually use the param balancing mode to provide this information. Session affinity. Usually, if session affinity is the term you can think of if one particular customer is logged into website and the backend service is maintaining it is all stateless, but it's a data and caching the data, right? So what you want to do is you want to always send the request from that particular customer back to the backend services. I would say same backend instance and not two multiple backend instances. So there is a session affinity which you can configure and use it. So session affinity sends all the requests from the same client to the same virtual machine instance as long as instance stays healthy and has capacity to serve the traffic. Okay, GCP HTTPS load balancing offers two type of session affinities. One is client IP affinity and generated cookies. So one is based on the client IP. That's how it will route the traffic, and the second one is based on the cookies it is set. WebSocket. HTTPS load balancer has native support for WebSocket protocol. Backend that uses WebSocket communication with the client can use HTTP load balancer as a front end for scale and availability. If your service requires longer lived connections, increase the timeout, and this is additional configuration which you can think of. If at all your backend is supporting WebSockets, in this case these are the considerations. Illegal request handling, how actually HTTP load balancer handles the illegal request, right? And this is some of the thoughts around it. So it will treat this request as illegal if it cannot pass the first line of the request, a header is missing, header or the first line contains invalid characters, content length is not valid, there are multiple content lengths, there are multiple transfer encoding keys, that there are unrecognized transfer encoding values, there is non-chunked body, no content length specified, body chunks are unparsable. So all of these situations where HTTP load balancer will treat that the request itself is illegal, and this will actually come to you as a cloud engineer to look at why the requests are not getting processed by HTTP load balancer. So these are the scenarios which you want to check it. Load balancer also blocks along with all these the request, it's also block the combination of request URL and the header is no longer than 15 KB. The request method does not allow a body, but request has one, and request contains upgrade header, HTTP version is unknown. In all these cases, HTTP load balancer will block the request. Timeout and retries. HTTP load balancer has a default response time of 30 seconds. HTTP load balancer has TCP timeout of 10 minutes, which is 600 seconds by default, and HTTP load balancer retries for all failed GET request, but does not retry post request. You can actually think that GET request is usually the read request, and post is you are submitting or making any change to the backend. So if that particular post request is failed, it will not retry. Logging, you can actually use Stackdriver logging for logging your connections, and you can use flow log for so much of your network communications if at all it is required. If your load balancer instance are running public operating system image supplied by compute engine, then firewall rules for the operating system will be configured automatically to allow load balancer traffic, which is like traffic from the load balancer. But if consider this case, right? If you are using your own custom VM, you have to configure the operating system firewall manually, because this is maintained by you and not by GCP. This is separate from the GCP firewall rule that must be created as a part of configuration. So if you look at, and we are going to see this in detail, the firewall rules which we configure, that is outside your virtual machine. It has got nothing to do with whatever you configure as a firewall rule inside the virtual machine. So it is outside the virtual machine. So, and that is why it is independent. Load balancing does not keep instance in a syncs, the backend instances. So it is responsibility of, in case of instance group you are using it is instance group's responsibility to keep them in a sync. HTTP load balancer does not support sending HTTP delete with the body to the load balancer. You can actually think that if at all you are sending HTTP delete, it should not have body in it. I will go back here and just for our illustration, I will use this image again. We have actually seen this many times, but we are going to refer this in our demo. What we are going to do is we do not have DNS. All Asia, Europe, and West, we are going to create these virtual machines. We have backend actually services which will support these clients. So I'm actually trying to mimic that someone is calling from or making the request from Asia, someone is making request from Europe, someone is making the request from US West. How do I do it? Because I'm located in US and that too East. How can I actually make a request to load balancer that I'm that I'm sitting in US West or Europe or Asia? The way I'm going to do here is I'm going to create a virtual machine in Asia, I'm going to create a virtual machine in Europe, I'm going to create virtual machine in US West, and that's how I'll make a request, and then we'll see how load balancer perform. Okay, and this is the only way which I can check it. I should have actually done these virtual machines from either AWS or any other cloud provider, but just for simplicity, I'm just doing it on a GCP. Okay. So what we are going to do is we are going to create first the instance group for Asia, instance group for Europe, instance group for US West, and then we are going to configure load balancer, which will hit the request to the backend and all these client as a virtual machine again. Okay, let's go ahead and get started. Create first the instance group. So for me to create an instance group, I need an instance template. I'll go ahead and create instance template. So the first thing first, I'm going to create the Asia comp. Let me go ahead and share this particular slide again. I just elaborated that what is that we are going to create as a part of load balancer demo. So what we are going to do is we need instance template for Asia, instance template for Europe, instance template for US West, and instance group so that we can manage autoscaling and multiple instances in the backend. Then we'll go ahead and configure load balancer on top of this one with health check inept. We are not going to have DNS, but the client from Asia, we are going to mimic creating one instance in Asia, one instance in Europe. I can actually use my desktop to mimic the the traffic from US, or I can actually just have a client instance created. But we'll see how it goes. What we are going to see here is once we create the instances, we are going to generate the traffic from different client instances. Okay, so let's do one step at a time. Let's go ahead and create instance template and instance group. What I'm going to do is I'm going to create the script, starter script, in which script I will have actually CPU utilization go high. So if you invoke that particular script via HTTP, the CPU utilization of that instance will go high, and that's how we will be able to demonstrate the autoscaling also for US West. Okay, or we can actually do it for any other instance. So let me jump back to console, and in console I have to create the instance template first. So I'll just mark this instance template IT hyphen Asia. For Asia, I'm going to create a small instance, so I'll be charged with less. And what I'm going to do is I'm going to click here and go to startup script. I have this particular readme and I have all the script which are ready to be downloaded by you and the script created. So for Asia, I have this particular startup script. What it does is it gets this frontend.asia Python script and it will execute. This will create an HTTP trigger, and whenever you call that API HTTP link, then this will burn some CPU. Okay, I'm going to just copy this over. So copy from /bin to here, not this dot. Okay. Okay, I'm not specifying any zone or region here, just to tell you. So this is Asia. instance template, create. Instance template is created now. I'm just going to click on the instance template and let me see. HTTP is traffic allowed because we want to hit the web server. Key is there. I'm just going to copy this instance template and create Europe. Same instance size, but I'm going to modify the startup script. This time I'm going to take Europe startup script. Okay. Create. Again, I'm going to copy over the same one to create USA instance group and change the startup script this one. Okay. Create. I'm not really worried about all other parameters right now. So instance templates are created as per our requirements. So instance template created for all three regions. Let me create instance group. I'll just prefix all those instance group with IG and Asia. I'm just using simple single zone location, or I can just use multiple zones and I can just select the region. So now I'm creating Asia. So I'm going to go ahead and use Asia East 1 instance template Asia. I'm going to switch on auto scaling for Asia. CPU utilization. This is a target CPU utilization, right? When do you want to trigger additional instances, and based on this one it will trigger an additional instances if at all. So we start with one instance, and if that particular instance goes over 60%, it will trigger multiple instances, and you can go up to 10 instances. Cooling down period 60 seconds, and this is where you try to avoid if there are any spikes low and high. You want to wait for 60 seconds to measure the CPU utilization, and then you take average, and then it can decide. So we have HTTP health check. Let me go here, or I can actually go ahead and create one. I'll just go ahead and create one. Create another health check. HTTP new for LB. Traffic is HTTP 80, port number 80. So interval to check the health, whether the instance is healthy, and we can wait for up to 5 seconds to respond back. Healthy thresholds consecutive to failures will be like unhealthy. Healthy is like consecutive 2, and unhealthy is consecutive 3 failures. Save. Okay. So that's it as a instance group, and let me just select whether I had chosen right things. Okay, create. I can create another one for Europe. Instance group Europe. Again single zone. This time I'm going to select somewhere in London. Any is fine. Europe. And health check same. Our load balance health check. All other things should be very same. I'm not going to change anything there. Creating another instance group, and this is instance group USA. USA health check HTTPLB create. So while we are creating this instance group, it will create the number of minimum instances that we have asked for, and you can actually see that is reflected here. I have this particular instance as an additional instance to mimic the USA traffic. So US East 1, that is my instance. So the third instance group is getting created. I can go, while this is creating, I can go here in network and services for load balancer. And currently it is in network service and load balancer. It may be somewhere else when you see this demo because Google is keep changing. Create load balancer. If I click on create load balancer, it will show me multiple options. I'm going to use HTTPS load balancer. I'm saying HTTP ALB demo. Backend services, I can give instance or bucket. Bucket means cloud storage bucket. We are going to see this later. I'm going to just use backend for load balancer demo, and I can start with Asia. Somehow we created multi-zone in Asia. That's fine. Utilization, this is balancing mode. This is CPU utilization. If it goes to 80%, then it will not send the request to this backend, and that is the utilization mode. The number of requests, if you mention 1000 requests per second, will make you decide to go to somewhere else. But I'm going to consider this CPU utilization of backend instances to make the decision where to transfer, and I'm not going to measure rates per second, because if at all the utilization is lower, then I'm fine with just hitting it. Done. I need to add another instance group as well. Europe, port 80, utilization same. I think what I can do is utilization is 60. Okay, auto scaling is already configured. And then US. So all the instances, so you can actually enable cloud CDN for this backend if at all you want to have it. And I'm going to use health check, which we created. Create. So we have backend, we have host rules if at all you want to, and this is where actually we saw it, right? So if at all you want to transfer image traffic to somewhere else, PHP to somewhere else, or your other web traffic to somewhere else, then this is how you can configure. You can just mention here images dot my GCP train.com, or you can mention here /images. It will route this to a particular backend service. As because we have just created one for this demo, if at all required, I'll go ahead and create, and this is the default backend it will hit to. I'm going to create another one if at all it is required, but I don't think it is required. Front end, and this is your HTTP endpoint, right? So I'm going to say LB demo. The protocol I'm going to use is HTTP, and rest all as it is. I can have an additional front end hitting to the same backends for this load balancer, but I do not have that requirement right now. I'm just going to use as is. So this is finally what we are going to create when I click on create. And this is the thing, right? You need a really good patience here, because it is going to hit You are going to, once the IPs are there, you are just trying to access it and you will not be able to see it. While this is being created, let us go back to virtual machine instances, compute VM, and so we have one particular instance that mimics our US West or my desktop. I need to have another client instance and third client instance, one in Europe, one in Asia. So let me go ahead and create those instances as well. CLT in Asia. I need to give Asia now. We have given, I think, Hong Kong. Let me give Tokyo, which is near. Anywhere, I'm fine. I just need a small instance. I don't need to enable this, but I'm just doing it for my sake. So that's the Asia one created. I'm going to create another one in Europe, in CLT, in instance that is Europe, and I'm going to choose near to London somewhere. Either I can actually host this in London, or let me choose Netherlands, and any zone is fine for me, and I'm going to use micro. So the instance is getting created. Let me go ahead and hit this Asia and see if it is working. So usually when you directly click on the external IP, it will hit to HTTPS. You need to make sure that you take out HTTPS there and then hit directly. So you have OK Asia. OK Europe. So this one we checked. Now US. So many of actually the student in my earlier course, they responded back saying that, when we click on this one, we get error. Says error connection refused, right? So you need to make sure that you have chosen right protocol, because the web server which we are trying to create here is HTTP and not HTTPS. We have not enabled SSL connection on it. Okay, so that's how you'll get it. I'm just going to delete these ones. Okay, now we have client in Europe, client in Asia, and client in US. But at the same time, if I hit the load balancer from my machine, it should go to US because I am currently in US. So let's go ahead and go back. Network service load balancer. So the HTTP load balancer is up and running. When you actually get this information, right, check here what are healthy instances. So it is not yet complete. If you look at the number of healthy instances, at least you should have one healthy instance here to serve the request. Okay, let me pause this video to get these instances in healthy state, and then we'll continue again. Now we see the instances. You have one instance for each of this instance group, which we have configured as a backend service here. Let's go ahead and hit this particular IP in our, okay, it says US West. All the time it says US West. That's wrong, right? Why it is saying only US West? Or have I actually configured wrong script everywhere? No, it should not. Yeah, the catch here is I'm sitting in US, and that's why it is routing my request to US West instances. Going back here, if you look at, if at all I'm sitting in Asia, then it will just route the traffic to backend in Asia, but in US West, it is getting routed to US West. I have another alternative too. go ahead and hit the request to this load balancer, mimicking that the instance is in, or the client is in, Asia. Okay, so I have Asia instance right now. I can just click on SSH. And what I'm going to do is I have created this curl script as well. Okay, I'm going to run these curl commands here as well. Okay, I just need to replace the IP address of my load balancer. What is it? 35.186 35.186.202.99. Don't forget to actually put HTTP colon there. Okay, so what this will do is every 2 seconds it will hit to this every 2 seconds it will hit to backend, not the backend, actually the load balancer, sorry, load balancer endpoint. This particular instance is in Asia somewhere, so it is the request is getting routed to Asia backend. Let me go ahead and create Europe client SSH terminal, and for the same command we should get the request routed to Europe. What is that? That is not good. Somehow this copy paste is not that much good. Okay, I'm just going to get this copy. It says Europe. Good. Let me go ahead and hit this one, and let's execute the same command. So this is client in US. It says US West, right? So everything is normal, everything is going, intelligent routing is working properly. Now what we need to do is we need to somehow create the load on US West. I'm just choosing the US West because this is there in my presentation, but we can choose any of this backend and create considerable amount of requests in US West. So let me go ahead and choose US West client. Where is US West client? This one. Okay, I'm just going to Control C. Okay, now what I'm going to do is I'm going to change the timer to 0.1 second. But let us just go ahead and review how many instances are running right now. So this is client, this is client, and this is client. Only one instance for each and every instance group is running right now. Okay, let's go ahead and create some traffic in US West. So what is this? Yeah, this is US West. Let's hit it continuously, and we can actually go ahead and US West, right? go to monitoring, and you can actually see the traffic going up for these guys. On 60% usage, it will go and hit the trigger another one. I will let pause this particular video and let this CPU burning go high, and then I'll come back. So if you look at this particular endpoint, the base endpoint will not give a CPU burner. I have another endpoint using which we can use the CPU burner, but we have seen that the requests are getting intelligently routed to their respective nearest backend services. So let me go ahead and hit the service which will do the CPU burning, and I want to actually use that for US West region. So this particular service, the endpoint / service, will hit heavily, and it will create a CPU usage. So if I go here, in US and monitoring, we should actually see the CPU. So I was able to just hit 25% with so many requests, but I have now service which will hit the CPU beyond 60%. We just should stick here for some time, and let me, so it's a US West. I'm just putting 2 seconds for Europe, and many more requests in US and in Asia. For Asia, we are going to run every 2 seconds a request. Hold on, I want to use this particular. So we are not going to burn too much of CPU in Asia and in Europe. We are hitting the same endpoint. So US West, why the request from Europe is getting routed to US West? Okay, we can check that. Maybe I have not changed the text there. So US East, let's burn CPU, okay, on the back end, and let us see. I don't want to burn CPU here. I'll just keep our normal curl command so that we know where it is hitting. So now US West is actually hitting considerable amount of a request. This is 2 seconds, so this is not that much, and we are not burning any CPUs in Europe. So this is our case. Let's go ahead and see the monitoring for US. Okay. Okay, so you can actually see for US, as because I was hitting too many requests, it has considered a spin off additional instances. For Europe also it has created additional instance because I mistakenly add number of the traffic. In Asia though, as because we are not at all hitting the service, right? So we are not actually hitting too many requests here. So let's go ahead, and what we do is kill some of the instances in Asia and let us see what happens. Asia, okay, you can't actually stop it. Asia, remove from the, do something, okay, do something there. Let us see what happens. So now nothing is essentially working properly. Asia, it should trigger additional instance, but in meantime it has to send the traffic over to some other location. This is Europe, this is Asia, so it has created additional instances. Delete. Let us see what happens. Okay, so this will not be applicable because we have used, okay, there are multiple instances getting created for Asia. Let me remove from group or delete instances. Let me just go ahead and delete the instances. Let us see what happens, whether the request still, okay. In meantime you can actually see that it, we have some of the requests already going to US West, as because we were deleting those instances, okay, and there was load on, if at all there was one instance, it was load on it. So additional request went to US West because that was near. If you look at the geography, that is what you can see it, right? That's what it is for load balancer, guys. If you have any questions, the way we have actually gone through was, so we created all this, we created the clients, and we burn actually CPU too much in US West, and then we deleted instead of Europe, depicted here in animation. We actually deleted, tried to delete the Asia, and the traffic actually went to US West because that was near. That's it, guys. If you have any questions on the demo, please let me know. Otherwise you can actually just move to the next load balancer theory. TCP and SSL load balancer, these are external load balancer, and we call it as a SSL proxy or TCP proxy load balancer as well. So typically why you will use it when you have SSL or TCP traffic and you do not have HTTP or HTTPS on top of it, then only you will use SSL proxy or TCP load balancer. SSL proxy intended for non-HTTP traffic. For HTTP traffic you just use HTTPS load balancer. SSL load balancer proxy at global load balancing layer. So this is again a global load balancer. SSL connections are terminated at the global layer and then proxied over balance to the instances across the backend via SSL or the TCP in the backend. While choosing to send the traffic over unencrypted TCP global load balancer, the instances enable you to offload SSL. So typically what it happens is your SSL configuration happens here in the load balancer, and then the internal communication is plain simple, and then you don't have to worry about those configuring those inside it. That is for SSL. Components, usually it has got a health checking, backend services, SSL certificate and key, and global forwarding rules, and this is same as of HTTP load balancer you can think of. It is just addition that SSL certificate for SSL. Benefits, it has intelligent routing, better utilization of virtual machine instances, certificate management, security patching, and it supports all these ports. Rejection or invalidation, it rejects the invalid HTTP request or response. Negotiate HTTP 2 and SPDY 3.1. You want to actually go ahead and look at it if at all it is required. I'm not sure it is required right now. Spread the request load evenly among all the instances. HTTP load balances each request separately, whereas SSL sent all bytes from the same SSL or TCP connection to the same backend instance, and that is actually a connection on, right? And for HTTP it is like each and every request is a separate, and you need to put forward session affinity to have those requests done. I'm not going in details of the demo for SSL load balancer. I just walk you through some of the terminologies which we have it. So to create an SSL or TCP load balancer, you just go to network services and load balancer and create load balancer, and that's where you choose either TCP or the internal. And in TCP or SSL or TCP, right, this SSL proxy or TCP proxy, those are like external, and you can have it either single zone or multi-zone. So what is that I want to do? It is from internet to my VM, only between my VM. So if I say only between my VM, that is an internal load balancer, that is you can treat it, right? Whether it is external facing, internet facing to VM, then you can actually choose this one. You can select multiple region or single region, and again you need to provide the name, TCP, and backend services. And again, this is like TCP, you have to select the region. I'll go US West 1, and existing instance group or existing instances. You can actually directly give the direct instances. I can just go ahead and create one example for you guys to understand. It just looks at the this is a part of instance group, and I think not yet deleted. Okay, I'm just creating one instance, and I'm not bothered about anything else but this traffics. Okay, I can actually add additional thing here and attach it. The only thing which you need to make sure that you have enabled additional network tags to enable TCP traffic. Okay, I'm not doing it because I'm not going to create it. I just wanted to show you that when you create an instance, it will appear there in the load balancer. So create load balancer, start. Okay, continue. I would say TCP or whatever SSL, right? Load balancer, region, whatever region, and select an existing instances. Let me see where I have created. Where I created the instance, I think it's US East 1 region. So US East 1, because that's how it will look at the instance. And pool failure, health check, you want to put it. Session affinity, you still want to give it. Front end configuration, same. TCP LB, and then you can either choose premium or standard. What do we mean by premium? I should have actually explained it. This will actually take all the traffic all the way near to your user using Google Fiber. Standard means this can take traffic anywhere using public internet as well. And then you can just give port here and then done, and then you can just create a click and it will be created. I do not have anything installed and I'm not intending right now to do full demo for SSL, but that's in nutshell SSL load balancer is. Internal load balancer. So regional internal load balancer. Load balances between your internal to your virtual VPC. Internal request stay internal to your VPC network region, likely resulting in lower latency. Internal load balancer work auto mode VPC, custom VPC network, legacy network. Internal load balancing can be also implemented in regionally managed instance group. This allows auto scale. So in nutshell, what we are saying here is it is an internal load balancer internal to your VPC. So the traffic stays within GCP, Google Cloud Platform, and it uses fiber if at all it has to use the fiber optic network connections. Restrictions internal to GCP: you cannot have hop to IP manually configured route. You cannot send traffic through VPN tunnels to the load balancer. So within it is within the GCP ecosystem. Limit: maximum number of 50 internal load balancer forwarding rule is allowed per network. Maximum 250 backend is allowed per internal load balancer forwarding rule. So you need to make sure that you understand it. So the way it works is typically if you look at any internal load balancer in large corporation or your own, there is a client request or client instance get hop onto load balancer, and this is physical device, and then the request is routed back to the backend. But in case of Google load balancer, internal load balancer, it is just proxying. So once the connection is established, it is talking to the backend services seamlessly, and there is no hop here in internal load balancer. So if you look at typical way how it works, you can have actually regional backend services, and this is the client instance talking wants to talk to US Central 1A instance, backend instance, or 1B, and then it is using the load balancer to go back. Selection algorithm here. By default, internal LB use 5 tuple hash. Client IP, client port, destination IP, destination port, and protocol, whether it is TCP or UDP. If you want to control how the traffic direct to the backend, you can use the following affinity. So hash 3 tuple and hash 2 tuple. Client IP, destination IP, and protocol, or just client IP and destination IP. Health check, you can still go ahead and configure TCP health check, SSL health check, and HTTP health check, and this is what we saw already. So multiple health checks are available for you, and depends on the load balancer which you use it, you can choose the health check. An internal load balancer, if we look at this overall architecture, this is the internal load balancer. This is within, you can actually already see this is within your GCP and not talking to any other external services. External load balancer, in the other word, balances load between system based on incoming IP protocol data such as address, port, and type. Network load balancing uses forward, and this is common for all your load balancer configurations. It is just given for your understanding and not just to repeat it, because many of you will just refer to the slides when you study those topics for the exam, and you should have it ready, and that's why I have actually this repeated theory everywhere. Network load balancer is a pass-through load balancer, and it does not have any hop to the connection. Terminologies, again, load distribution algorithm, target pool, session affinity, health checking, firewall rules, and network and load balancing. Some of the concepts on connection draining. So usually you can enable connection draining, and this is not critical for your exam, guys, but just for your understanding. Okay, so if you enable connection draining on the backend service to ensure that minimal interruption of your user when the instance is removed from the instance group, either manually or by the autoscaler. To enable connection draining, you can set timeout duration during which the backend service persists, then existing session being handled by the endpoint on the instance that will be removed. The backend service preserves the session until the timeout duration has lapsed. Okay, and we have seen and configured these numbers as well. Typically, you can have the duration between 1 to 3600 seconds. Load balancer pricing, it is very straightforward and very plain simple pricing. So for all regions, all load balancer, you have 0.025, which is like cents, 2.5 cents, 5 rules included, and 10 cents, actually 2.5 cents, 5 rules included, and 1 cent per additional rule. And GBs that will be processed by the load balancer will be 0.8 cents per hour per GB. Auto scaling, we saw the concepts of auto scaling, usually instance group. That's where we configure auto scaling. This allows applications to gracefully handle the traffic and reduce the cost when the resources require lower resources. You just define auto scaling property in auto scaling performs auto scaling based on the load, and there are different parameter requests per second or the CPU utilization. The terminology which we used in auto scaling is instance template, instance group, and auto scaling policy, which is attached to instance group. So the policies which we can use for auto scaling is CPU utilization, load balancing, serving capacity, Stackdriver monitoring matrices. You can actually trigger auto scaling based on cloud pub sub queuing workload. Some of the notes, auto scaling only work with managed instance group, and managed instance groups are not supported, and we saw this already in compute service. Do not use compute engine auto scaling with managed instance group that are owned by Google Container Engine, and Container Engine manages its own auto scaling. So we just need to make sure that we are not doing anything tweak there. Okay, usually if you want to understand what are the instances created by compute engine, it is GKE as a prefix. You can find it for all those instance group or the instances as well. We do not have much of demo left right now for a load balancer, guys. Whatever we saw, those are the demos for the load balancer. If you have any question related to any of the demo or theory part, let me know. Otherwise, you can actually move to the next service. Thank you.
Google Platform Network Services Cloud CDN. CDN means Content Delivery Network, and that's where you use Google's edge points or the CDN pop locations to cache your content. Let's go ahead and get into it. So Cloud CDN is a part of networking service. We have already seen the load balancer, and we are going to use load balancer in our example to enable the Cloud CDN on it, and we are going to see the logs. So what is Cloud CDN? Cloud CDN is low latency, low cost content delivery using Google Cloud Platform using its network. You can do logging, you can have VM and storage as a backend from which you can do a CDN or caching. You can enable or invalidate the links, and it supports any cast IP addresses. So if you look at, we saw this in our introduction section. These are the cables, the fiber optic cables which Google has laid, and this map might have changed already. We may have additional cables which Google has laid, but this is the fiber optic network which owned by Google. So all these blue lines, this is owned by Google, and green lines, that's where they have investment on these cables, right? And you see the dots, and dots are like locations. There are even other dots as well, like pop locations. But these black dots, these dots supports CDN location. So if you look at in India, there are 3 locations, or in South Africa, one is in Johannesburg. It supports the CDN or caching in this particular location. So overall, throughout the world, they have 80 plus pop locations. Those supports CDN, content caching. Okay. So what is CDN? CDN is a Google Cloud CDN leverage globally distributed edge caches to accelerate content delivery for website, application served out of Google Compute Engine.
A CDN lowers the network latency of load origins and reduce the serving cost. Once you have set up HTTP or S load balancer, you simply enable the CDN with a single checkbox and we are going to see it. So typically the way CDN works is there are end users, they are accessing some of the instances, whether it is a VM instance or cloud storage bucket. The static information get cached here in the CDN location, which is used by the end user without say reaching back to the backend services. So that's the CDN. It is caching in the POP location. That's what you can think of. High level features, caching at POP locations. So Google has around 80 plus POP locations around the world, using which you can cache the data. Global reach, SSL with no extra cost, and it has got seamless integration with load balancers. You have anycast IP support. You can do invalidation, you can do logins, and you can define the origins in CDN. So let us look at how it works in Google Cloud Platform. If you look at, there are the customers from across the globe accessing your services or the backend services, right, via HTTP load balancer. What happens is any customer actually trying to access some of the static content, it will be checked against whether that particular information is available in nearest CDN POP location. If that information is available and not yet invalidated, then the customer can see that information, and that is in a nutshell a caching layer, and using which you will have very fast access to that static content. Let us see this in action. How does it work? So step one, say as an example, this particular consumer request for snowman.jpg, okay, and that snowman jpg exists somewhere, whether it is in VM or in cloud storage. That request went to the POP location. POP location sees that there is no snowman right now available in the POP location, so it will check the nearest POP location, what if it is nearer than the backend, to check if the snowman is available there. Then it says there is no snowman here. Then the request will get forwarded via HTTP load balancer to the backend, and backend gets the data, gets the snowman, store it in local cache, and that is what it is called the term as a cache fill, and then the content is served back to the consumer. What happens next is, if at all the customer from the same region, that's what the assumption is trying to retrieve a snowman or the web page containing snowman, what it will do is it will get the snowman which is already cached without going back to the backend and deliver that snowman here to the new consumer, and that is what it is called as a cache hit. When next time someone gets it, someone try to access it, a snowman, then you will have snowman is available and then it is served. So all of that you can think of is the way customers are accessing the data, and the data is static data and you can cache it. Consider another case where there is a request goes to another POP location which supports CDN for say same snowman, okay. What will happen is it will check again the similar fashion if there is snowman available in the nearest cache. Yeah, it is found, and then it will be filled. So the cache will be filled here from the nearest POP location without going back to the backend, and the content is served to the consumer. And this is what it is called as a cache to cache fill. So expiration time and validation request for caches. Each cache entry in the Cloud CDN cache has expiration time defined by cache control, and these are the HTTP parameters. Cache control max age, and or expires header. Okay. If more than one is present, the cache control S max takes the precedence over cache control max age, and cache control max age, cache control max hyphen age takes precedence over expires. So you need to make sure that if your data is there in your in your VM instances or cloud storage bucket, uh, you want to cache it in CDN locations, but at the same time, you need to make sure that if there are any changes or updates to that particular data, the front end users are coming back to get those changes. So typically, if you look at how the CDN works in nutshell, when there is an expiration, right? Expiration happened, right? Or max age happens, right? There is a request. It checks for last modified, and that is the e tag. The request is sent to back if modified since or if none matches to that particular request, then it will give you the data back again, like snowman again back if it is modified since that particular time. If it is not modified since the time which it has cached, it will send 3 or 4 that is not modified response back to the CDN. So that's how you can avoid again cache filling for the same content. So how the caching is happening, right? Because you need to understand if at all there is a caching, there has to be some mechanism, because you don't want to cache each and everything that's there in the web server, not really a dynamic content, right? And that's where cache key comes in a play, right? If you look at this particular example, https://example.com/images/cat.jpg, this is the key in which the data will be cached, this image will be cached, right? So if any new request which will look like this one will go to cat.jpg and jpg and get the data out. You can have exact matches, you can have file path and file name always be a part of that particular exact match, but at the same time it determines which protocol you're using, host, query string as well, whether to include it or omit it. So when enable CDN, caching happens automatically for cacheable data like with the keys, HTTP headers to indicate that which response to be cached and which should not. It is possible to predict whether a particular request will be served out of cache or not. The data location settings of other cloud platform services. Data may be stored and serving location outside the region or zone of your own origin servers, and this is very important considerations if at all you're making decision to use CDN, right? So if at all there are HTTP caching, browser caching, right, that is happening outside Google platform, Google Cloud Platform cannot control that or invalidate that data. So cache invalidation, typically once an object is cached, it is normally remain in the cache until it expires or it is evicted, make out of a room for the new content. You control the expiration time through the normal web server configuration. Sometimes you might want to remove an object from the cache prior to its normal expiration time, and that's where you can use cache invalidation. You can check below information for invalidations like cat.jpg or /pictures. You want to invalidate all of that using the pattern, or from single host you want to invalidate everything, right? Everything is changed for that particular domain, but you want to look at the limitations which caches has, because you cannot do you cannot fire a continuous cache invalidation request for the content, and there are some limitations, and the limitations could be like the rate in which you are invalidating an object, or invalidation is like you want to invalidate for the whole example.com, or you want to invalidate for a specific content. So you need to make sure that all of these are considerations while you are deciding invalidating or use of invalidating a particular cache. Majority of this is done for is in jurisdiction of development work or planning work, and not really day in day out operations on the cloud platform. So there are some pricings which I have put forward on the CDN. You can go through it, and this continuously changes. You just need to keep watching. If at all you are really interested in understanding the price, do not refer this. Just look at Google Cloud pricing, because this might have already changed. We can get into detailed demo, but let me go ahead and share some thoughts where you can actually go and enable cloud CDN. So if you go to network and network services, that's where you can find cloud CDN, content delivery network. You can go ahead and add origins. I do not have anything right now, but you can go to load balancer, create load balancer, backend configuration, and you say create backend service. I don't have any backend service right now, but this is where you can actually go ahead and enable cloud CDN. But if you create or you want to use an existing load balancer, you can either change the load balancer or go and add origin and choose the load balancer which you have it for CDN. Okay, we are going to get into details if required for cloud CDN. But if you have any questions on theory for cloud CDN, let me know. Otherwise, you can move to the next lecture. Thank you. So as we saw, cloud DNS is one of the networking service that are available as a domain name service. It is reliable, resilient, low latency DNS serving from Google Cloud Platform worldwide. And what it does, it actually takes your name, domain name, and converts that into your IP address. And we are going to see this in demo. Some of the features: private zones. It is cost effective, and we are going to see the pricing aspect as well. It supports DNS forwarding, and it is 100% uptime and highly available. You can think of they are providing 100% uptime SLA on the DNS service. So Cloud DNS is searchable, reliable, managed authoritative domain name service out of Google Cloud Platform. It is low latency and high availability, and 100% uptime SLA. DNS translate your requests like google.com into the IP address, and that's the basic main use of DNS. Cloud DNS is programmable. You can easily publish and manage millions of DNS zones and records using simple interface or CLI. Some of the best features: enterprise grade connections. You have 100% low latency availability or SLA. Automatic scaling, cost effective. It supports any cast name servers, managed zones. You have managed zones inside it and managed through API or web. We are going to actually get into all of this shortly. So Cloud DNS is built around the project's managed zones, record set, and changes to the record set. So you have project, and inside that you are going to create the Cloud DNS. Inside Cloud DNS, you have managed zones. You can go ahead and do a record set collection or allocation, and you can do resource record charges as well. Performance and timing, propagation of changes. So if you make any changes to the hosted zones or cloud DNS, it is going to take some time because there is TTL, and there are many places the records are getting cached. So it takes actually time to resolve your IP addresses from the backend, and we are going to see this in demo as well. The changes push to DNS server, DNS resolve pickup, and the changes when their cache of the record are expired. And each and every domain DNS entry, for all these entry you have TTL time, and we are going to see that as well. That time to leave is actually defines for any caches who is actually storing that DNS, how much time it should keep that particular cache before it gets invalidated or deleted. So we are going to see TTL configuration as well. Some of the basic concepts I want to focus it here. These are the record types which you can use it for any DNS. It's not only specific to Cloud DNS, but the main thing is you do IP assignment using a record. Okay, map your host name to their IPv4 addresses. You use C names like aliases for your additional domain names, and we are going to use CNAME as well. And then you have name servers, and name servers is actually your domain DNS zones which you can connect to, and we are going to see that as well. And these are the only important attribute which you have it all other attributes are like based on the requirement, or if you want to understand, you can go ahead and do it. But for your case, these are the main attributes you are going to configure it. Some of the methods or the permissions that you need to have it to create a domain name, right? So DNS change, create DNS changes, create like updating record set, deleting the record set. If you want to create DNS record, then definitely you need to manage zones permission for the project and for you. There are other permissions also, depends on the roles, like DNS admin can do each and everything, DNS owner or DNS editor, all of these can do each and everything to the DNS. They can create, delete, manage zones and all that. So this is like group of permissions which are attached to the roles. The other roles that are like DNS reader or roles viewer, and these are like just to read only. They cannot make any changes to the DNS records. The pricing, if you look at the pricing is very cheap. And when I say cheap, right, 0 to 1 billion queries, 40 cents per million queries per month, and this is the bucket is calculated per month. If you go over 1 billion, it is going to be 20 cents per million queries per month. For zones, it is going to be 20 cents per zone. For managed zones, it is if there are more than 25, like 26 up to 10,000, it is going to charge you 10 cents per managed zones per month. So they have given this particular example here. If at all you are very small, one website company, right, and you need say 5 zones, the zone cost will be like based on 20 cents per zones. It is going to be $1. If you assume that you have 10 million queries per month, so the queries cost will translate based on 40 cents per million queries. It is going to be $4. So total it is going to be $5 per month as your DNS cost, considering these parameters. Okay. So we are going to get into Cloud DNS demo in detail, where we will register a domain name which is not inside Google Cloud Platform. It is outside Google Cloud Platform. You can have domain registration without even having Google Cloud Platform. So we are going to do a domain registration. We are going to create DNS, Cloud DNS records, and we are going to map it and use some services from Google Cloud Platform to expose that information outside world using that domain. Okay. So if you have any questions on theory, let me know. Otherwise, you can move to the demo. Thank you. So to start with, I'm going to domain.google.com to get the domain name the way I want to have it. I'm just going to search the domain name which I would like to get it. So I got googlecloudcertification.com as an exact match because the other domain which I was trying is not available. I went ahead and put my payment information and all other information which is required to register the domain, and the form is submitted. I'm waiting the registration to get done. So the domain name is getting registered, and this is not a part of Google Cloud Platform. This is outside Google Cloud Platform as a domain name service or registration service. Okay, it's just a registry. I think it is taking time. Yeah, it's ready now. We can go here and check different information. You can go and click DNS and see this name servers, and this is very important for us because this is what we are going to use it to configure it. Your domain will stop serving because the domain has been verified. Okay, let me go back to email and confirm that. Here No. Okay, yeah, let me click verify email. Now it is, the email has been verified. Dismiss. So we have the name servers, and that is our interest, to get those name servers, and this is what we are going to use it in DNS. So this is our domain name, googlecloudcertification.com, which we are going to use it. Let me just go ahead and hit that and see if anything is there. It says IP, nothing is, site can't be reached, IP address could not be found. So there is no IP address association or the name server association done. So let me go back and go to network and DNS, cloud DNS, and then, so there are no policies and zones. Okay, let me go. Yeah, so cloud DNS zones, just give my domain name, Google Cloud Certification, and I have the same domain name .com. I'm not going to select this DNS check, but I'm going to put forward some description there. So Google Cloud Training Certification, create. So if you look at what we got this the name server information, and these are the hosted zones. What I'm going to do is I'm going to take these name servers and put it here in our domain registry. So we are going to remove this, and we are going to take this Google domain name to custom one. So let me just align a little bit so that we see it, what we are trying to do it. Okay, now let me add NS Cloud C1 Google Cloud domain, copy paste. If I click C, okay, 2 or more required. Let me just add it, all others, copy paste. Just copy paste C3, just change to C3, add one more, change to C4, and save. So we have added name servers here. That's how traffic will be routed to this name servers, and name server will try to locate your IP address from the backend, but we have not configured any IP address yet. So let me go ahead and add record set, and this record set will allow me to add a record, and that is IP address mapping. So let me go ahead and put here IP address, IPv4. What's my load balancer IP address? I have multiple accounts, I need to just change it. GCP project, go to load balancer. Okay, I don't have any instance. There is an instance group, but I don't have any active virtual machine. Let me go back to load balancer. So I have this particular IP 35.186.202.99. Just copy paste it here, create. So a record is created which will map your google.com to this one. Okay, sorry, I should have not put the www there. We'll go ahead and add cname for that as an alias. So it's saved. I'll go ahead and add cname to route even www. That is our alias. com create. Now we have cname, so it can take google cloud certification.com as well as google cloud certification.com. So now we have DNS created and we have everything set up. So let me, if I hit it here, so this will take some time, guys, because DNS propagation definitely takes some time. We'll be back. I'll pause the video and we'll be back after some time. So it's been a while now. Let me go ahead and just copy paste and then try to hit the link. Refresh. Yes, it is hitting to our backend, and right now my load balancer is pointing to cloud storage bucket, so that's why it is showing me. And now your Google Cloud certification, that is working. Let me go back and see if I have any virtual machine. Okay, I don't have any virtual machine. I'm going to create one virtual machines from marketplace. I'm going to go to marketplace and create the instance, the lamp one, just Apache. LAMP. I'm just using quick methods to launch any instance which has got web server in it. I'm least bothered about all other things. So here you go. I'm just keeping everything same. Let me just go and use small one, and everything is same, just HTTP is allowed. I'm going to use default network. Deploy. So it is getting deployed. Now it is deployed. I just pause the video. So you see the external IP address. I'm just going to copy it and put that in my DNS. Go back to network service, DNS, edit. I'm just going to change that IP address and save. So this has been saved, but it is not going to replicate the traffic as it is or quickly. The TTL, or time to live, that's what we have configured, is 300 seconds, and that is 5 minutes. So if I go back here, nothing has been changed. It is still pointing to my cloud storage. You can see it. We need to wait for some time for the DNS to get propagated. I'll pause the video. It's been around 15 minutes. Let me go ahead and refresh it. So it is pointing to Apache on Debian. So means our domain name is working. It is hitting our DNS service and ultimately hitting our backend API IP address to get the services. Let me go back and try to add additional subdomain. network service DNS. So it is, this IP address is getting mapped. Let me add additional subdomain. And this images will point to my load balancer IP address. Let me go ahead and get the load balancer IP address. So it is, the backend is load balancer. My buckets IP address is 35.185. Let me just copy it over and put it here. Delete. So if at all I put images.googlecloudcertification.com, it should point to the images. Images means the cloud storage bucket. So this is subdomain. This is how you can create the subdomain. So currently images.googlecloudcertification.com is not working, but we can come back after some time and see it is working and it is hitting to our cloud storage bucket. So I'll pause. I'm going to pause the video for. It's been 10 minutes now. Let me go ahead and hit it. Hit the images.googlecloudcertification.com. Yeah, it appears actually it is hitting properly to my cloud storage bucket. Let me go ahead and copy the image name and then paste it here. Yeah, it is getting routed to our subdomain, which is images.googlecloudcertification.com, and this is the image which is there on my cloud storage bucket. Again, going back, my plain domain name Google Cloud Certification, it is hitting back to Apache. So we have created domain, we have created subdomain as well, and they are pointing to two different IP addresses in the backend. So as a part of this particular demo, what we have done, we have actually went to the domain name service and got the domain name. I did not actually went to GoDaddy because GoDaddy I'm having some problem in mapping it. So I went to domain.google.com, and this is not inside the Google Cloud Platform service. It is outside Google Cloud Platform, and I just booked this one, registered this domain, and then I went ahead and changed this one. So there are default name servers which was there, so I just changed this one name server back to, if I go here, DNS names with these name servers. That's how the whenever the call goes to googlecloudplatform.com, it will be routed to these backend services, and then we have mapping for those. Ultimately it will be routed to either this IP address or that IP address based on what is that we are hitting it. Okay, so we have created the backend service, which is our LAMP, and attached here for googlecloudcertification.com as a main domain, and then we have created subdomain, which is images.google.cloudcertification.com, and we mapped it to our load balancer, and our load balancer is pointing to cloud storage bucket where we have some images. Okay, so that's it for Cloud DNS. If you have any questions on Cloud DNS, let me know. Otherwise you can move to next lecture. Thank you. Implementing hybrid interconnectivity. In this particular section, we are going to get into details of configuring interconnect, configuring site-to-site IP sec VPN, and we are going to get into demo only because we already saw theory. Configuring cloud router for reliability, again demo only and not the theory. We already saw cloud router as a theory. So we are going to see configuring interconnect in the next lecture. Thank you. Cloud interconnect. In this lecture, we are going to cover some topic around cloud interconnect. We are not going to have a detailed demo of cloud interconnect, just high level thought around the partner interconnect, which is layer 3 versus layer 3 connectivity, virtualizing using VLAN attachment and bulk storage upload. As because I do not have any VPN which I can demonstrate, or my own network which I can demonstrate to connect it to GCP, because where I work it is not allowed for me to demonstrate that. But I'm going to get into some level or some thoughts around these 2 points and some more detail around the bulk storage upload. We already saw these ones as interconnect options, but if you want to map it to layer 2 and layer 3, and this is again the slide from the Google website, GCP website. So you can have, for layer 2 you have direct connectivity, interconnection options, that is dedicated interconnect and partner interconnect, and that's where you have RFC 1918 address space exchanges. If at all you do not need address space exchanges, you just want to access your GCP services or Google services, and you want to reduce egress fees, that's where you can use direct peering versus and carrier peering. You can have, on top of it, you can have VPN tunnel created, so that your traffic gets encrypted on those peering connections. But this is layer 2 and layer 3 connections. If at all there are any questions around layer 3 versus layer 2 connections, then definitely this is the diagram which you need to remember and answer appropriate questions. VLAN attachment, this is purely if you look at what does it mean by VLAN attachment. There are VLAN attachment, you can look for partner options. Let me go here. So you can actually get into details of how you can attach the VLANs. In fact, I can go in here and I can show you in cloud interconnect. Networking, you can go to hybrid connectivity here, and you can go here and I can say dedicated interconnect. I can have an option like first one is dedicated and second one is the partner. The restrictions, what is required, all of that is already covered. I'm just giving you high level thoughts around it. But if I choose, say, partner interconnect and continue, it will ask you, this VLAN attachment. I already have a service provider or find service provider. Let me go ahead and cancel it and get started. Let me select the dedicated interconnections, continue. Order new dedicated connections or add VLAN to an existing dedicated connections. I would say order new. I can create, say, my interconnect. Choose facility, I can choose facility. Let me choose it from, I can say select this one. Next. For redundancy, I can use another one connection. Backup. Interconnect, I can choose a different location altogether in New York, because if at all this particular connection goes down, I should have a backup. The company name, Stack info at, I'm just giving an option here just to reach to that point and I can actually place an order, right? If I have a interconnection option, you can go here, or you can actually choose dedicated, continue, and you can add VLAN attachment on top of existing dedicated connections. I do not have existing interconnection option, so I will not be able to choose it, but that's where you can use VLAN attachment. Bulk storage upload. If you want to transfer the data onto Google Cloud Platform from your own data center or on premises, there are multiple options which are available for you to do it. The list of options that we have is online transfer and offline transfer. Online transfer, in that case, you can use Google Storage Bucket online transfer, which is Google Cloud storage. You can use S3 bucket transfer, or you can actually go ahead and give the list of URLs to transfer the data, right? So online transfer, and in online transfer itself, you have cloud storage transfer service. Okay. The second one is transfer appliance, and this transfer appliance is the device which you can actually get it if the data is more than 20 terabytes. That's where you use transfer appliance service. You can take the data, you can order the transfer appliance. Once the device is arrived, you can transfer the data into the transfer appliance and ship it back to Google, and Google will make sure that they will upload the data in your desired location, okay, in Google Cloud Platform. That's another offline service. But besides that, you have BigQuery data transfer service also, where you can actually schedule the big jobs and transfer the data onto BigQuery. Here is some of the numbers which you can actually use it to understand how much time it is going to take for your data. As an example here, if your data is 100 gigabit or GBs and you have 10 Mbps line, it is going to take 30 hours of time to upload 100 GB. And if your data is somewhere around 100 terabytes and you have 1 Gbps line, it is going to take 12 days. And this is actually the time which it is going to take when your data transfer speed is very consistent in nature, and you are going to get. And this particular matrix will help you to understand what service to use it. I just put forward some of the images which are available for me. You can even see this online as well. These are the transfer appliances which will be shipped by Google to you using one of their shipping provider. You can actually take this device, load your data, and then ship it back to the Google, and Google will transfer your data back from this transfer appliance to the cloud storage or your desired location. That's it, guys, on this particular topic. If you have any questions around it, let me know. Otherwise, you can move to the next lecture. Thank you. Hello, Cloud VPN demo. So what we are going to do is we are going to create two different network here. As we saw earlier, I will not be able to create anything as a data center connection, but what I'm going to do is I'm going to create two different network in the same project, and then I'm going to connect them with a VPN, and then we are going to test the connectivity. So the steps are we are going to create the networks, independent networks. We are going to create the VM and open the firewall so that they can communicate. We are going to create VPN gateway, and that is how there is a connection between the two networks. We are going to reserve the static IP for both the networks. We are going to create forwarding rules so that if there are requests for a specific IP address and that is from the other network, it will be forwarded perfectly to that particular network. And then we are going to create tunnel, and the tunnel is the way for your traffic to flow from one network to another. We are going to create a route, and then we are going to create virtual machine in we are going to test the connectivity between virtual machine 1 and virtual machine 2 between the network, and that's once the connectivity is established, you can think of VPN is set up properly. So let's go ahead. I have created this cheat sheet which you can use it if you want to try it on your own. Let me go to the console to start the connection. So if you look at here in my dashboard, I need to go to VPC networks to create the network, and the network which I need, both the network are custom network. Okay, I already have one custom network which I don't want it now. I'm going to delete this particular custom network. I will let it get delete, but in the meantime I'm going to create VPC1, and this is custom network. I'm going to create subnetworks, and the subnetwork is this one, subnetwork 1. Subnet 1, and the region which I'm going to select for this subnet is Europe West 1. I'm going to give IP range. I am going to use the similar IP range which I have used earlier on my earlier demos, and create. So VPC1 is getting created. Let me create another one, VPC2, and in here I'm going to create subnetwork 2, and this subnetwork 2 is related to which one? Subnet 2 is related to Asia East 1. IP range I'm going to use it 1010.2. Create. The next steps are we need to create a virtual machine and open firewall between them, right? So let me go ahead and create one virtual machine in each network slash subnetwork. So I need to create one virtual machine in this subnetwork, and second one is in the another one. Let me go to the compute service. VM1, and this I want it for Europe West 1, Europe West 1B. I'm going to select small micro, and in networking I'm going to select my network for Europe. So that's the VPC1 and that's the subnet 1. I'm going to keep all other thing as same. Create. I'm going to launch another VM, VM2, and this is in Asia East 1. And I'm going to select another network that is now VPC for my subnet 2. All other things are same. Create. So my step number 2 part 1 is over. I need to open the firewall, so I can create firewall, I need to go to network, firewall rules. Okay, there are, you can see there are firewall rules already created for default network, but I'm going to create it for VPC1 and VPC2. So let me create VPC1 firewall. The network is VPC1. And what I'm going to do is I need to open this traffic. And to specify from anywhere /0, and all instance in the network I'm going to keep that. All instance in the network should be applied this particular firewall rule. VPC1 allow ICMP and SSH. Create. I'm going to create another firewall. This time it is VPC2 to VPC2 all instance 0.0.0.0/0 all connections. Okay, now this particular step is over. Now step number 3, let's go ahead and create a VPN gateway. So what you to do this, you need to execute gcloud command. You can actually execute gcloud command using your own shell. You can download and install SDK, Google SDK, or what you can do is you can go to cloud shell in the console itself. To pop up cloud shell, you just go here, and then we are going to launch connections from here. What it does is it check first the project ID, what project ID we are using it. If it is the same project, then we are good. If you are using multiple projects, you want to specify the project ID here and carry on to create VPN1 and VPN2 connections. Okay, so I'm going to use gcloud training, and that's the project ID. So I'm not going to modify this one. Let me go ahead and create the VPN1. Typically this is, you can think of this is very hard way of doing it. You have option to execute some of the commands from the front end itself, consolidating all other steps together, but this is, you can think of hard way of doing it. I'm going to create another demo with the cloud router, and there I'll show you how you can create VPN connection using the UI. So this one is created now. For your VPN1, I'm going to create gateway for VPN2 for Asia. So you have VPN1 and VPN2 gateway created for VPC1 and VPC2 respectively. Step number 4, reserve static IP address for each network. So let's go ahead and reserve the static IP address. I have given the command here, gcloud command. So what it will do is it will take the addresses for the region, and the region we are saying is Europe West 1. So there is static IP created. I'm going to create another one for Asia East. Okay, this is again created. If you can actually see the list of addresses which you have reserved, you can see it here, right? or you can go to external IP addresses and then you can find those two IP addresses here, right, with their names. What I'm going to do is I'm going to create environment variable for those IP addresses for easy use hereafter in all the scripts. So VPN1, and that's VPN1 is Europe. VPN2 address is this one, which is Asia. So we have created this environment variable, and let's go ahead and create the forwarding rule. For forwarding rule, you need to create it for ESP, UDP 500 and UDP 4500. So let me go ahead and create it for ESP first. Good. ESP2. And then UDP 500. UDP 4500. And for VPN2 as well. So okay, I should have given the different names, but they should be fine. These are just names to it. VPN2, VPN2. Okay, so yeah, we can leave it here. There is no problem with it. Verify external IP addresses. You can go ahead and check the external IP addresses here, and then you can run VPN gateway. So this is VPN gateway list. So we are done with step 5 as well. Let's go to step 6. So you want to create VPN tunnel. So tunnel from VPC1 to VPC2 and then VPC2 to VPC1. I have created this command so that you can use it directly. Okay, the tunnel has been created. You want to verify that with the command here. Okay, gcloud tunnel list. Now create the route between VPC 122 and 221. So this is just a route creation. one route is created. Second route is again created. Okay. It's all good. So let's go ahead and test the connectivity. Let me go to virtual machine, compute engine, virtual machine instances. Okay. Launch VM1. Okay, ping. So from VM1 we want to ping VM2. Okay, it is not known. Let me ping 10.10.2.2. Right, that's the VM2 IP address. See, the connection is going. So in nutshell, what we have done is we have let me go here. So what we have done is we have created this particular network, this network, then we have created virtual machine inside it, then we have opened the firewall so that these virtual machine instances can accept the connection, and then we have created these gateways. We have reserved the static IP addresses for both the network. We have created forwarding rules so that this particular network understand if set of IP range where the request should be forwarded to. We have created a tunnel. Then we have created routes, and then we have tested the connectivity between VM1 and VM2. This is how you can go ahead and create the VPN connection, guys. If you have any question on this one, let me know. I'm going to put forward these cheat sheet into resources section. You can actually download that and utilize it for your own lab purpose. Thank you. In this particular demo, what we are going to do is we want to do the routing based on this is based on the router, and we will follow the same process, but this time we will use the UI. What I'm going to do is I'm going to utilize the existing virtual network as well as the gateways. I'm just going to modify certain things, and just let me go to console so that we can start doing it. What I want to do is, so this was the virtual machines which we have created earlier for our the VPN, which is based on the router static routing. Let me go to interconnect VPN. You can actually see those tunnels, VPN gateways are there, right? If you click on the VPN gateway, you can see all those forwarding rules configured and tunnel associated to it. These tunnels are route based. You can see it, or you can just go here, tunnel, and then click on it and then see. And this is route based tunnels. One is in Europe West and the other one is in Asia East, one tunnel, and the connection is established. So what I'm going to do is I'm going to delete these tunnels, and I'm going to create another tunnels for our gateways. So let me go ahead and let me go to VPN1, and I'm going to delete this particular tunnel. Let me go to VPN2 and delete this tunnel. Okay, so there are no tunnels now, it's only gateways. Hello, so what I have done is I have just redrawn the architecture which we want to implement. So we are going to use router 1. I just put forward some labels here so that we can understand we are going to use the same process from creating network, virtual machine, firewall, VPN gateway, reserve IP for both network, creating forward rules. All of this is created in our earlier lab. The only thing which I am going to do is I have already deleted the tunnels, and I'm going to create router, I'm going to create tunnels with the BGP session, and then I'm going to test the connectivity. And additionally, what I'm going to do is I'm going to add additional network, which is additional subnetwork in Europe West. That's the subnetwork 3. And then I'm going to create a virtual machine 3 inside it. And then I'm going to test the VM3 to VM2 connectivity. Just to reiterate, I'm going to create router CR1 with ASN 001 and then CR2 with ASN 65002 while creating the BGP link. So if I have to say create the BGP link from here to here, I'm going to use 65002 as a ASN for this particular router, which is router 2, and vice versa. I'm going to rotate the IP addresses as well for both the things. So let's go ahead and go to this one. Tunnels. I don't know what is happening to this one. This was earlier tunnel which we had it. So what I'm going to do is I have deleted those tunnels. I'm going to create or add the tunnels. But before I do that, let me go to the interconnect and create some routers. So router is the first router which I'm going to create is CR1, and that is in VPC 1, this one, Europe, and then I'm going to create it in Europe West 1, Google ASM, which I'm going to use it 001, create router. I'm going to create another router which is CR2. This time it is VPC2 and it's in Asia East 1, and I'm going to use a different ASN and create. Okay, the routers are now created. Let me go to the VPN connection and add the tunnel. So this is VPC1 and VPN connection 1. So let me go ahead and create the tunnel. Tunnel 1 from 1 to 2. So what we want to create tunnel from this one to here. So 1 to 2. Okay. The IP address which we are going to use it here is for this particular network, and that's the second IP address which we want to use it. I have for Asia, this is the IP address which we are going to use it. So from Europe to Asia, so that's the destination IP. I'm going to select router CR1, and here I'm going to create a BGP session. Here BGP 122 and peer ASN. This peer ASN comes from, so now I'm creating this one, so I should be using this router's ASN, which is 65002. That's the peer ASN, and then I'm going to use one IP, this 169.254.0.1, and the same with 2, right? Okay, and create. Okay, and give any of your secret name. That's one. It takes some time actually to show that up here. I'm going to create another tunnel under VPN2, add tunnel. This is tunnel 2 for me. Tunnel 2, and this is from 2 to 1. And here I'm going to use the other IP address, which is now we want connection from Asia to Europe. Okay. Router which are here is CR2, and the BGP session here we want to create BGP 2 to 1, from 2 to 1. The ASN here is 65001 if you look at the architecture here. So for first router it's 65001, and then I'm going to reverse the IP address because that's how it gets connected for the peer IP. So 169.254.0.2, 169.254.0.1, and that's it. Create. So tunnel must be creating here. Okay. So I'm going to pause the video for these tunnels to get created, and then we'll come back. Okay, we see the tunnels has been created. I think there is still some resources getting allocated and like that status here, but we are going to check the ping if it goes from, wow, that works. So you can actually see that the connection between two instances. Let me go to compute virtual machine. So between these two instances, so I am in VM1, I'm connecting from VM1 to VM2, and the connection is established now. That is the dynamic routing. I'm going to add the subnet here again, and we'll see that whether the connection is still exists and working fine. Let me go to VPN1 and see if there are, we can see the traffic for this one, monitoring. Okay, so there is a kind of connection or traffic which is going or flowing through. Okay, tunnel 1 to 2, and then let me see tunnel 2 to 1. There is no data. So let me do one thing. Let me go here, virtual machine 2, that's in Asia, and ping virtual machine 1, and let us see if we get the traffic in the monitoring. Ping 10.10.1.1, 1.2. Okay. Tunnel 2, monitoring. You can see there is a traffic, very small, in the graph that is flowing through. We can probably wait for some more time and then see the actual traffic which is going. But now what I want to actually do is come back to our this thing. I want to go ahead and create another subnet in VPC1 and one virtual machine inside it. So let me go to networks, VPC network, and then in VPC1, which is in Europe, I want to create another subnet, add subnet. Okay, so in the meantime, what I'm going to do is I'm going to add subnet. So subnet 3, it's in VPC1, and then I'm going to add it to the same region because otherwise I need to have another cloud router which I need to create. So 10.12.1.2 0/24. That's my IP range. Let me go ahead and create it. Okay, now let me go ahead and create virtual machine. Okay, this is VM3. Europe. Okay, Europe West 1B. Okay, small instance, micro instance, and let me go and modify the networking parameter. I want to use VPC1 and there is subnet 3 which I can use. Done. Create. So virtual machine is getting created. So what I'm going to show is I should be able to ping from VM1 to VM3 seamlessly without modifying the network, because a router is already there which is taking care, announcing these networks. Okay. Yeah, for BGP to actually refresh the network, it takes some time. If we don't get the response very early, then you can wait for some time and then do it. Okay, here we are. Ping 10.10.2.2. Let me just see. There is a connection already exists with VM2. Now let me ping to VM3. See, there is connection exists. So what we want to do is we want to test from VM2 to VM3 connectivity. Ping 10.12.1.2. See, the connection is going. So we have connectivity from VM2 to VM3, which is in different network altogether. We have connectivity, and that is how a BGP routing or dynamic cloud router will help us to discover network. That's it, guys, for dynamic. I'm going to put this particular document for your reference so that whenever you want to try it, you can actually get this particular information and then go ahead and create your own cloud router. That's it for the demo. Let me know if you have any question. Make sure that you delete all the resources when you are done with the demo. Section 5, implementing network security. Network security is very important in cloud environment, especially public cloud environment, because you are, or the enterprises are uploading their data or managing their data inside the public environment. And it's not only one particular company hosting their data in one data center. There are multiple companies hosting their data in those multiple environment or data centers. So security is very important, and especially network security is really most important for us to consider when we are trying to or planning to move into the public cloud environment. Looking at the objectives for this particular section, we will look at configuring identity and access management, which is IAM, configuring cloud armor policies, and we are going to get into details of how do you do that. Configuring third-party device insertion into VPC using multi-NIC. I'm not going to get into details too much, but I'm going to give you high-level overview about how you do that. Managing SSH keys, and this is very generic topic, not related to network as a security, but definitely SSH is a network entity. But how do you manage, how do you use SSH keys? That's what we are going to look at. If you look at the wheel for your Google Cloud Platform, in its core there is a VPC, and when you say there is a VPC. It is in itself, it's a firewall, right? Whatever resources which you create in Google Cloud Platform is associated to one particular VPC. VPC has got the firewalls, IAM policies, private access to Google services, bastion woods, and routers and gateways and all that, right? So all of that is the component of VPC. The second comes Cloud Interconnect, and in Cloud Interconnect you have multiple options which you can use it. You can go ahead and connect your on-premises with Google Cloud Platform, but at the same time you can encrypt the traffic which goes out from your data center to Google Cloud Platform or vice versa. The next layer comes in isolation, auditing, and compliance, and that is where you go ahead and put forward different measures like logging, monitoring, compliances, third-party virtual appliances to protect your data, or to monitor or do audit about your data, who's accessing, from which location the data is being accessed or applications are being accessed. The next layer is Google Global Load Balancer, and that is the outermost layer you can think of. It is located in edge network, and even you can protect load balancer or the external network in Google's premises, and we are going to see how Cloud Armor actually help us to do that. This is overall as a wheel, which you have it as a security measures. So while looking at the firewalls, or how you can actually block the traffic, how you can take a measures to restrict the traffic, we already saw the firewalls. We saw the traditional firewall, and we already saw the firewall, how you can configure ingress egress traffic. You can allow and deny the traffic in both the directions, and you can configure that in each and every level, and that is very important. So you can cover that using the firewall, and firewall is one of the best security measure which you can do it to protect the resources. Some of the properties of firewalls, it's both the direction. You can have ingress or egress firewall rules created. It is stateful in nature, and you can do a flexible grouping, and that is, you can use network tags, service accounts, networks, or instances to configure the firewall rules. This is one of the slide which I took it from Google itself, and what it says is you can restrict the communication using routes and firewall rules, and you can allow only the traffic which is permitted. Just don't be open everything to communicate with each other. Just make sure that what are the services which are required for you to use from those instances. How many instances should be connected to your VMs or App Engine or any other like database services, right? You can go ahead and put forward many measures and apply firewall rules in fine-grained level. Another topic here, if you look at the security measure, is to enable the VPC logs, and VPC logs plus firewall logs. Those are like very it is going to take considerable amount of space, because it is going to create a log entry for each and every network connections. So keep that in mind. What VPC flow logs or firewall logs provides is real-time visibility into network availability and performance, security analytics, network forensics, who is connecting, which part it is connecting, which data is being accessed by which clients. You can have all those configured. So once you have the data or the logs, you can actually put that in a BigQuery and you can run analytics on top of it. You can have traffic planning based on the flow logs. Example here for the flow log is it can track the VM to VM communication, VM to interconnect communication, VM to internet communication, and traffic between VM and Google services in productions. So flow log definitely help you to understand the network inside, and firewall logs on top of VPC flow log definitely help you who is trying to access some data or the instances. If you look at the whole Google Cloud Platform network or the communication in between, it is, you can think of it as like TLS everywhere. So you do not need to worry about whether the data is getting encrypted or not, right? So it is TLS like everywhere. We are going to see how you can protect the outside connection using Cloud Armor. And again, this is from Google Cloud Platform. I just got lazy and not have created anything else as a slide, but I'm going to use this slide to explain Cloud Armor. That's it, guys. As an introduction, we are going to get into configuring identity and access management in Google Cloud Platform in next lecture. Thank you. Cloud IAM, fine-grained access control and visibility for centrally managed cloud resources. So in high level, you can control the access permissions of your cloud resources. That's the Cloud IAM, identity and access management in the long form. Cloud IAM is context aware, which means it understands the context wherein the access permissions are provided. It has got a built-in audit trail, so your audit logs are streamed and you can use it to do any analysis purpose. It is very simple to configure and we are going to see that in demo. And you can do resource control, granular resource control for enterprise identity. Before I'm getting into too much of theory, let me go back and get into the console. Here I'm in console. I can actually go here, identity and access management and admin, and I can click in here. So I can go ahead and add a member here. I can add the new member, and this is your actual user who wants to have access to your database resources. Let me go ahead and add my Google ID here and give permission. I can give either basic permissions like primitive permissions like editor, owner, or viewer as a project role, or I can give specific role like billing project manager, or I can give the logging administrator or monitoring person, right? Or I can give storage admin and like that. Let me just go ahead and give the high level as a editor role for this particular project. If I have to add another role, I can go ahead and add another role here, but I'm fine with that right now. I'll just do save. So I have added Tanaji as a editor role here. If I go here, I should be able to see. I think I should have got the notification. So I can go ahead and search the project. What was the project name? GCP project. So I can see, I can switch to that particular GCP project, and this is this project. Okay, so that's how you can provide access to your project or any particular resources to any user. Okay, I can go ahead and revoke that access. I'll just go ahead and delete. So that particular user is gone. If I go here again, and if I want to launch something, and try to launch. It will say you do not have sufficient permission to view this particular page. Okay, so this is how IAM works. You can give permissions or add users. The second one is you can go ahead and either use custom roles or you can create your own custom roles. So and that's the rules. You can go here and check the service accounts. It's a different topic altogether, but we are going to see this. If you want to provide access to a particular application and not the user, that's where you create a service account. So you can, so this is roles section. You can go ahead and create a different role. You can see all the roles which are available. It is predefined role. If you click on any of the role, like let me go here and say app engine admin, right? If you click here, you will get all these permissions. So if you assign app engine admin to someone, then that person will get all these permissions assigned. Okay, you can use either existing roles which are predefined for you, or you can go ahead and create a custom role, and you can mix and match all the permissions or the permissions from the existing roles. So this is a custom role. I can say I want, so let me create this role for database administrator. I can add permissions based on the existing role like cloud SQL. So I have multiple things as a cloud SQL here. So I can select all. And so those are the roles which I have it, and I have these permissions. I can actually select all these permissions. You can just change this. Okay, and you can say add, but I want to add cloud spanner as well. Okay, and I want to add all these permissions. Okay, I can say add once I have added all the permissions. Now I can just go ahead and hit create button. So database administrator role is created. I can go ahead and assign database administrator role here to any member. So I can just go ahead and add member. I'll just try to add my name again, and role is database administrator created today. So with my role, I will be able to create Cloud SQL and manage Cloud SQL and Cloud Spanner. So that's all about Cloud IAM and the rules. You can create custom roles. You can go ahead and click on edit logs here. Who's who are actually creating the roles. You can enable auditing on those. Let me go back to theory again here. So what Cloud IAM provides, it enables you to grant access to the cloud resources at fine-grained level, well beyond the project level access. Cloud IAM provides a simple, consistent access control interface to all cloud platform services. You can have multiple level of access permissions, and we just saw you can mix and match the roles and its permissions, individual object and instance to an organization level. So in nutshell, what it does, it actually provides, it defines who should get what access, like admin, Google account or service account or cloud identity, all of those. So that's the user for the Cloud IAM, and can do what, like read, write and execute. We just saw you can give say admin permission to someone, right? You can create that particular role, and you can give it. And what resources, it's like cloud SQL, cloud storage, app engine, or virtual machine, like that. So the terminologies which cloud IAM uses is the resource. Resource means the end resource on which you define the permissions. The second one is the permissions, like create database, create instance, and like that. And the last one is the roles, and the roles are the collection of, you can think of permissions together. There are predefined system roles, as well as you can define your own roles. So in roles, you have primitive roles. We saw that you can give just project, admin, editor, or viewer role, or you can have fine-grained user-defined roles. So we saw predefined roles, and we saw custom roles as well. We created one custom role. So users, who are the users for Cloud IAM? It could be anything, like I just gave my Google account, danajimusli@gmail.com, or it could be G Suite admin, or it could be Google Groups. If you assign a role to Google Groups, then you will be able to assign that particular permissions or role, or manage the control to the whole group. And if at all, say, group contains 100 users, then 100 users will get access to those resources. GCP does not create user or manage users. This is done using G Suite admin. So typically in Google Cloud Platform, we do not manage an identity. We just use the identity, whether it is part of G Suite admin, or your any Google account or Google Groups. But GCP does not actually do any user administration. So you cannot go here and say add new user here. It is everything is like existing user. You are just adding that as a member. So we are going to get into service account in the next lecture, but service account is typically used by an application to application communication, or you want to provide or restrict one particular application doing a certain specific things and not everything, right? As in like administrator. We are going to see service account in the next lecture. Typically projects roles that what we have, I have tried to assign editor role to my ID, but the project role, you have viewer, owner. You can manage access control for the project and all resources, including setup of billing, and then you can have an editor role as well. Product specific roles, there are product specific roles, like for Cloud SQL. Cloud SQL has different roles which are created, right? Cloud admin or reader, right? Or the viewer, Cloud SQL reader. And then there are permissions attached to those roles. And then you have organization rule, like owner, resource manager, organization admin. And this is a part of G Suite consideration, and not a part of Google Cloud Platform. Just another representation of primitive roles. So you have owner, editor, and viewer roles, and you can have billing administrator as a project level primitive roles. So what is the difference between editor and owner, right? Editor has viewer all permissions and permissions for actions that modify a state of particular resource, but owner can actually do too many things, and it can manage the access permissions, it can create roles, it can give permissions to others, and even it can control set up and control the billing account and control the project or the billing for a particular project. So there are predefined roles which we already saw, which are already there. You can just go ahead and explore it. There would be some questions based on if you want to provide access to a particular user, like GCE network administrator access, then do you need to create your own access permission policies, or you can actually use it from existing topic, or how you can create whether IAM provides you or allows you to create custom roles, or you can use just existing roles out of platform. So predefined roles has got a, the permissions included into it, and there are multiple combined roles also, which you should be least bothered about it, because if at all say one particular role has got a two or three different permissions, so you can combine two different roles together to create a new role, or you can combine multiple permissions together. You can add a permissions to an existing role as an additional permission, or you can just remove one particular permission out of the role. You can do all of that, and we have seen, right, when I was creating a custom role, you can mix and match all those possibilities while creating the custom roles. So this is just a high level flow. It starts from project to a service to billing, enable APIs, create service account, and set up IAM policies. But this is the typical flow wherein if at all you are planning to launch a GAE App Engine instance, you need to have you need to enable Google enable billing for your project. You need to enable API. You need to create a service account to have permissions to, so that App Engine can do certain things like access database services and all that. And you should be able to set IAM policies, who should have access to this GAE and who shouldn't have. Typically this is the flow. It is top to bottom, and Google Cloud Platform actually limits itself to project and resources. All above the organization setup is a part of G Suite, and this is the hierarchy. We saw this already, but this is just a representation how IAM role works. If at all the company has got a organization has got a IAM owner, right, and it has got a multiple departments, or organization has got a folder admin or the department admin, you can think of in real sense, and then he should have access to create project and manage its resources. But in GCP, if you look at it only starts with the project and onwards. You can just link your organization to your GCP project, but beyond that you can't actually manage this folder structure or organization structure in Google Cloud Platform. Like the roles, you have policies which are defined. So all the resources inherits policies from its parent. Policies are union of a parent and the resource itself. So if at all say parent is less restrictive, which overrides more restrictive policy by the child. And this is in G Suite in nutshell. I just gave one example here for the policies, IAM policies. Here it is different organization structure. There are organization administrator, there are project creator, there are instant administrator, there are some network specific people, like Robert is only look after network. Robert is also looked after the security admin or security part of a project. James can do disk administrator. James can be a project manager or instant administrator as well. So you can mix and match all these different roles. You can create a specific role for your organization need, and you can manage it everything in your IAM. So what are best practices? Use groups if there are multiple number of employees which are available and you're using it, and they want to have access to Google Cloud Platform resources. Use groups, and that way you can completely take out the permission for a particular group, or you can give permissions to a particular group. That way you don't have to manage individual permissions for say tens of people, right? Enable audit on policy changes, and this is very important, and we are going to see that audit logs. But this is very important when someone is providing access to someone else, right? If he has permission, then you need to make sure that that is informed or that is tracked, who has given policy to which user or the service account. Follow the principle of least privilege, and this is very important because if there are some group of people who does not need to have, say, administrator access, and just for sake of simplicity you have provided access to the whole group as a administrator access on, as an example, Cloud SQL, they can accidentally or intentionally can go ahead and delete some data and which you don't know, right, which you can't control. That is one aspect. But at the same time, if you do not want to expose your customer sensitive information, you should not give even the read permissions to the group of people who should not have the access to say Cloud SQL, if at all you are storing the data in Cloud SQL. So follow the principle of least privileges. Don't just simplify it for the sake of simplifying your access permissions. Control what service account can do, and this is again very important. Sometimes we tend to give access to a user account, and user account is again used by an applications to do all this activity inside the cloud platform. But Google has very nice thing which is like service account, and using service account, this is not a actually service account of a person. This is system level access, and you can create a one service account and you can assign that particular service account to a particular instance or the resource, and then the access permissions are maintained or managed using that particular service account. Auditing, this is another topic, and we are going to see that in the next the lecture after that. But you can have auditing logs also incorporated or enabled, so that whenever there are policy changes, user getting added or user getting access to the cloud resources, you can trigger a pub/sub notification, or you can have alerting policies defined in Stackdriver logging. Okay. If at all you create a pub/sub notification, you can have cloud function responding or sending just a mail to network administrator that the access has been provided to so and so users. Again, you can take all that data into BigQuery and you can do analysis on those access logs as well. So one is admin log and the second one is data access log, and this is where you will have by default this is not enabled, but if at all you want to collect the data access log, it's a huge in size. You need to have some tool, and BigQuery is what it is suggested by Google, and you can define a sync to BigQuery and you can run analytics based on the data in the BigQuery. That's it guys for Cloud IAM. If you have any questions on Cloud IAM, let me know. In the next section we are going to get into service account. Thank you. Configuring Cloud Armor policies. The network security edge layer or load balancer layer. So how it does, right? We have seen cloud the firewall rules inside Google Cloud Platform. That's where you can protect the network, you can protect subnetwork, you can protect virtual machine instances. Ultimately everything is getting applied at virtual machine instances, right? That is there, and those are all like backend services if at all you are not exposing it to outside directly. How you can actually protect the traffic in the edge itself, right, or pop location itself, and that is for your Google load balancer. Consider a case wherein the website my app is being accessed by the users around the globe, and you want to restrict some of the users which are either from Russia or from say India or from US. You can actually do that in using Cloud Armor policies. So what it does is you can just go ahead and configure Cloud Armor policy, which will allow traffic from a specific client, and it can deny traffic from specific client or a group of or the site range, right? And that is what the use of Cloud Armor. Let's go ahead and get into the details here. You can go to network security and Cloud Armor. You can create policy. You can say my first Cloud Armor policy. What you can do, you can actually deny or allow. It's the same like firewall, the way you configure it. If you deny, you can actually give the status whether it is 403, 404, or 502, because that's the status which is not coming in from the backend. If you click on allow, then there is the status, whatever it is coming from the backend, that will be handed over back. So I'm just clicking on deny, and I'm saying just either I can say forbidden means not allowed for you, or I can say not found, just to say that there is nothing like that exist. I can actually just fake it, right? Next step, I can actually add more rules, and I can just say what is that particular rule is. I'm not putting anything, I'm just doing next step, apply policies to the target. So I do not have any HTTP load balancer here, but if you have load balancer or target instances or something, you can actually select that and just click done and create a policy, and this policy will be applied to your target. More importantly, here you can have multiple rules inside one particular policy, but this is not the case with the firewall rules, right? Firewall rule either can have allow or deny, or one particular target and sources, right? Depends on what type of that particular firewall rule is. But in Cloud Armor, you can have multiple rules defined inside one particular policy, and you can apply that to your backend instances. Okay, so that's all about Cloud Armor. So just high level thoughts around it. It's layer 3 to layer 7 protect, because it is not a network layer directly. It is network service offering, predefined rule, cross-site scripting and SQL injection, that is already there. You don't have to do it. We already saw how to configure it. It is IP based control. You can actually think of, you can provide the CIDR range, and you can allow or deny. I can click here, I can go, it says all IPs. I can say edit, and let me go ahead and create new policy. Second policy, okay, my second policy. Next, I can add condition like I want to restrict the communication from the CIDR range. I want to say deny, forbidden, and I can actually say configure as a preview mode only, and I can define the priority. Done. Create policy. So you have this particular policy using which you can either allow or deny. So we saw how to blacklist. In the similar range, you can go ahead and whitelist. The way we blacklisted some of these rules, you can actually go ahead and whitelist as well. So if I went ahead and created the policy whitelist third policy, it says allow, and next step I want to add a rule which says web traffic, and I want to allow it from 200 dot okay 120.0.0.0 slash all the ranges. Okay, and I want to say allow traffic, priority 200. Done. Create policy. Got it, right? So you can have different type of policies. Blacklist and whitelist. That's the Cloud Armor, guys. If you have any questions on Cloud Armor, let me know. Otherwise, you can move to the next lecture. Thank you. Configuring third-party device insertion into VPC using multi-NIC interface. Okay. Uh, the virtual machines on Google Cloud Platform supports multiple NIC interfaces. I'm just giving you an example how you can insert it. I'm not going to get into details of actually launching it, but as an example, Barracuda firewalls, right? You can launch the instance, and let me go here. Resources, deploy pre-built solutions, and this is Barracuda firewall as an example, right? You can take this and you can launch it. This is $37 per month, and you can bring your own licenses. So you can inject all these kind of third-party devices into Google Cloud Platform, because your virtual machine supports multiple NICs, and using, like as an example here, you can use Barracuda firewall. Probably you are using it on your on-premises. That's how you want to use it in the Google Cloud Platform as well. You can do that. And that's it, guys. I do not have any other example to explain it to you as a third-party device insertion. There are multiple. Definitely you can go and explore if at all you want to do it, but that is the concept in a nutshell. Okay. If you have any questions on this, you can let me know. Otherwise, you can move to the next lecture. Thank you. Managing keys for SSH access. Let's go ahead and get into details of SSH keys. This is not a new topic anyways. Majority of us knows what is SSH keys, right? So SSH key is used to connect VM instances for GCE or any service that has got a SSH access to connect the instance, right? So that is the SSH key. Compute Engine automatically manages the key for SSH, but you can manage the key by yourself as advanced users. You will need to manage it very carefully because losing that particular key may take away your access to that particular instance. So keep that in mind. SSH key has public key as well as private key. Private key is your own key, and public key is the configured onto your instances. And using private key, you can actually go ahead and connect to your compute engine. Multiple methods you can have it to manage SSH key metadata. You can use console, you can use gcloud command. You can have APIs to manage it programmatically if you want to do that. Steps to add user. Typically, if you look at how you can add a user for virtual machine, right? You can actually use you can create a new SSH key if at all user is not an existing user onto Google Cloud Platform, right? If the user has user already there in the Google Cloud Platform and has the SSH key, you just go ahead and add that particular key as an authorized key so that the user can access the instance. You can go ahead and do a format, add, edit, remove, and apply expiration time for the SSH key, and that is, you can think of additional thing for the users. If at all, say, user is no longer working with your company or in the cloud environment or in your department, you can just go ahead and remove it. You can apply some expiration time if at all he is due to remove, say, due to go on Friday or something like that, right? So all of this is, you can think of managing your SSH keys into Google Cloud Platform. How you apply the keys? You can use public key metadata to add and remove the users into Google Cloud Platform. So adding and removing the project-wide keys, you can actually do that in together. Let me go back here. And as I said, you can go to compute metadata and SSH key. Can go to compute metadata and in SSH keys. So these are the SSH keys which you have it. Anyway, I'm just going to remove it so I can just show it to you. You can edit those. I can just say delete, right? Delete, or you can add another or additional keys if you want, and you can even give the name for that particular key. Okay, so that is you can think of the project wide. You can manage it. You can use gcloud command, project info and describe. You will be able to see it. Information as a metadata. You can actually see, the SSH keys, username, colon, and the existing key value for the username. Okay. Alternatively, you can use gcloud compute project info, add metadata file and SSH key, and this is the path of your SSH key. I'm not going to give you a demo. It is very basic thing to handle. If I go back, on an instance level, you can say create new instance, security, and this is where you can actually block project wide SSH key. If at all you want to use your own key for that particular instance, because it is handling sensitive data, you can have your own keys, or you can attach that particular key here. Okay, and that's it, guys. As a SSH key, it is very basic topic, but you need to have understanding on how you can manage the SSH key. You can, using gcloud command, you can attach the SSH keys. You can view the SSH keys, and you can, even using the console, you can add and remove the SSH keys. That's it for this particular section, guys. If you have any questions, let me know. Otherwise, you can move to the next lecture. Thank you. Stackdriver. Using Stackdriver, you can do cloud monitoring, logging, trace, debug, and error reporting. We already saw the core services like computing, database, storage, and networking, right? But all of these services needs provisioning, monitoring, auto scaling, load balancing, right? So all of that, we need to have some infrastructure services who are managing those resources in the cloud, right? And that's where resource monitoring comes in a play as a Stackdriver offering. Stackdriver monitoring does platform or system application matrices. You can do health check, uptime check. You can create multiple dashboards where you can monitor, and you can configure even alerts in Stackdriver monitoring. In Stackdriver logging, you can have platform, system, or application log. You can do log search, view, or filtration. You can do log-based matrices. You can do debug in a production using Stackdriver debug. You can take conditional snapshot, and it has got IDE integration as well. Using Stackdriver trace, you can do latency monitoring per URL latency sampling. And in error reporting, you can do error notification and error dashboards. So how Stackdriver is used? Stackdriver is actually a multi-platform cloud monitoring service. You can have GCP projects. You can monitor GCP projects in terms of monitoring, debugging, error reporting, logging, and trace. But you can also do that with AWS projects, right? So you can do AWS monitoring as well. So Stackdriver works with GCP as well as AWS. Stackdriver needs to have host project to have an account, and you can enable billing account around the host project. This host project is in Google Cloud Platform, so you cannot have. So if at all the services which are there in AWS, you cannot have its account used in GCP. You need to have a host project account to have this monitoring enabled. So when we say Stackdriver is very much integrated with all the services about out of GCP. Okay, so what are the benefits having actually the pre-integration, right? So you can do monitor multiple clouds, AWS and GCP, and those connectors are already available in Stackdriver. You can identify trends and prevent issues. You can reduce monitoring overhead. You can improve signal to noise ratio, and this means is you need to have a good responses over the bad resources. That's where you using Stackdriver you can actually improve that, and you can fix the problem very quickly if you understand it very early. Let's go ahead and get into Stackdriver monitoring. Stackdriver monitoring. You can monitor cloud resources using Stackdriver monitoring. So what it does, you can do uptime monitoring using Stackdriver monitoring. You can set alerts so that you will get notified if something something is failed in Stackdriver. You can get actually the existing matrices, but you can, on top of it, you can define your own matrices. You can configure health check for the instances or the cloud resources. Some of the features, it is full stack monitoring that is available. You can monitor each and every resource out of Google Cloud Platform. For the cloud platform like AWS or GCP, or you can actually configure it for hybrid deployments as well. You can identify trends and prevent issues very early. You can reduce the monitoring with alerts. You can improve signal to noise ratio. You can fix the problem faster. Some of the features, you can have smart defaults which are already configured, and if you launch the cloud resources, you will start getting monitoring. You can just click enable Stackdriver account and you can start monitoring those resources without any configuration as such, but you can have your dynamic configuration as well for your need. You can monitor almost all the components of GCP. You can have matrices which ingest the data and you can generate the insight out of those data. You can do uptime and health check. You can customize your own matrices and get the alerts out of it, and it has got integration with Stackdriver logging as well, so you can switch back and forth, or you can drill down and look at the logs if at all some failures are happening. Some of the basic terminologies, there are metric type based on, say, CPU utilization, the way you want to choose the matrices. You can have time series and label matrices, and you can have labels as well for those matrices. You can use cloud monitoring as well based on the GCP resource labels, and if you remember, you can actually attach label to virtual machine. You can attach labels to GKE or cloud functions, right? And this is where you can pull the matrices based on the labels as well. Monitored resources, the resources which you have put forward monitoring on top of it, that's the monitoring resource. You can do a different kind of aggregation for those matrices. So you can say average CPU utilization, and you can define alert or some of instances, and then you can define some alert. So typically metric data hold up to 6 weeks and get deleted afterwards. When all the points in time series have expired, Stackdriver monitoring delete the time series data. So you can think of, if you have a matrices, the data which is created, and if all the points, if at all we see, say, time series data, right? And time series data is a sequential data based on your time, whether it is hour, whether it is days, right? If at all last time of that is expired, then monitoring will delete the data. Deleted time series do not appear in Stackdriver monitoring chart or Stackdriver monitoring API, so it will not be available once it is deleted. Cloud platform collects CPU utilization matrices for compute engine instances every minute, and you can access the data in 3 to 4 minutes after it is being recorded. So that is, you can think of lead time which it will take. There are additional delays before you can access the first data point in the time series based on the network latency or where it is configured. When you use Stackdriver monitoring API, write a new data point to an existing time series, you can access the data in few seconds. And those are actually some of the thoughts which you can think of if at all you are waiting for the data to come. When you write the first data point to a new time series, you might have to wait a couple of minutes before you can access. So If you are creating a completely new time series data, then probably you need to wait for a couple of minutes. But if it is existing time series data, you are just injecting some data points, then I think it should be available in some seconds. Typically, you can actually do finding anomalies. You can investigate transient performance of anomalies. You can reconfigure unbalanced cluster if at all that is what the issue is. You can replace contained instances. You can upsize busy instances if at all vertical scaling is required for, say, Cloud SQL instances. You can even prevent the resource exhaustion in case of there are resources are getting exhausted continuously. You can add many more resources on top of it, and then you can make best use of Stackdriver monitoring. Before we getting into too much of details right now, let's go ahead and get into console. Okay, here we are in the console. Let me go to Stackdriver and walk you through different services that are available. In Stackdriver, you have monitoring, debug, trace, logging, error reporting, and profiler. And profiler is a fresh new service that are available right now in 2018. Let's go ahead and get started with the monitoring. So if you look at when you click on monitoring, you will get routed to the different link altogether, and that's where you need to have the workspace created for your GCP project. Okay, this is my GCP project. If I go back and say toggle my project to, say, the other new project, which is very fresh, and if I click on Stackdriver monitoring, so the workspace is not created. You can either create the new workspace for the new project, or you can add it to an existing workspace. Okay, so I have this particular project, GCP project, as my existing project. I can just go ahead and continue. And add my all new resources into the existing Stackdriver account. Okay, and that's how it works. Let me switch back again to GCP project and go in here. So if you look at, there are multiple aspects that are available for you. The first one is where you can do uptime monitoring. You can set the alerts for the policies. You can create different dashboards for you to monitor it. You can have uptime check. So I have created this for App Engine, and it is currently down. And that is what it says, but we can go ahead and delete this. Okay, that is already configured and deleted instance, but I can go ahead and configure different policies altogether. Currently the instance is down. App Engine, you're monitoring App Engine resources, groups, if at all I have created a groups. Then incident, if there are any incidents which are reported, and yesterday I think there is one incident which is created. And the events, right? You can actually see the events where if it is solved, it is created. What you can do is you can switch between 1 hour, last 1 hour, to 6 hours, 1 day, 1 week, or 6 weeks, like that, right? Or you can define the custom time and you can get the details out of it. In resources section, that's where you see Matrix Explorer. Let me go here. And what you can do is you can have GC VM instances. So that is my resource. And what you can do, you want to say do CPU utilization for compute engine. And let me put 1 month. And you can actually find there are multiple instances which I have it last several days now. So you can find there are 20% crossed sometime, right? All these machine instances, and you can hover on these points and you can get the details of what has happened on that particular day or that particular incident. Okay. and I can apply a filter based on the project ID, instance ID, or zone. So I can say instance ID. I can, so these were actually so many instances that I had it. You can find the instance utilization here. Let me put one day, like this particular instance ID. You can do group by based on the instance name, project ID, and like that. Let me take out all that, and I can say group by based on instance name, and you can find that for 1 month. You can find this group by. Let me just go ahead and do group by based on the project ID. So you'll have, for my project, what was the CPU utilization on an average. Then you can do aggregation. What is that you want to do? Mean, count, sum, max. If I say max, you will say max utilization at that particular point in time. I can give, let me go ahead and just choose the count will not give us, because that will just add up all the CPU utilization. I would say mean. So you can have this particular metric. You can add additional metric to your same dashboard. So I can say again, VM instance. I can say CPU, no, memory. Memory utilization is not available with this one. Let me see disk IO. Disk read operations. Okay, as well as I can say I can do all of that the same. So you can find this additional graph also added. You can do different colors for the charts, right? So stats mode, you can enable different thresholds which you can put it, and then you can say 500. So you can put this threshold and you can save the chart. So the dashboard, where you want to put the dashboard, I can say new dashboard. I can give VM instance monitoring. And if you go here, dashboards, you can say, oh, that is, looks like that was not created. Okay, let me go back again. Resources, Matrix Explorer, view options. So I have this particular dashboard created yesterday, but let me go ahead and create the new one quickly. VM, the same theme, I'm going to choose it. CPU utilization, and I'm going to do it for 1 month. I want to group by based on project ID. Add. Again, I want to do VM instances, and this time I'm going to read operations because that is impacting performance. And again, the same group by, because I already have a group by on the project. I can use the same one. and you can go and options, you can do either thresholds, compare it with past, right? So I can put forward threshold which is like 500, and then you can choose different mode colors. Okay, and I say save chart. I can say okay, yeah, it is. I think it was there, VM instance monitoring each. I should have it. It takes some time, I guess. Yeah, I have it. So you can find these dashboards that are available for you. Okay. So that was dashboards. You can create dashboards out of your own configuration, or you can just use Metric Explorer and create it. The next thing is you can actually do monitoring based on the instances directly. If I click here, or if I click here as an example, say App Engine, I can pull the metrics related to App Engine directly, right? So if there are any problems with the App Engine, it will give you some logs out of it. You can click here and directly switch to Stackdriver logging, and that is where we said, you know, there is an integration and you don't have to worry about integrating it again, monitoring versus that. You can actually go ahead and put forward alerts for all your you can define the policy and define alerts, and I can go. So here if you look at this one, it says this was today's. It says CPU utilization went really bad and it will fire an alert. We can go ahead and configure one of the alert and see. I can say uptime monitoring. I have to, so let me go ahead and enable my GCP service because currently it is disabled. The App Engine is enabled right now, so we should be able to monitor App Engine endpoint. To get the endpoint, we saw this already. I can click on here. So I just copied it. And then I can go and create uptime check. So here I don't have to give this one and not even this one. It is just this endpoint, test it. So it says 200, okay. So this is good. App Engine uptime check. I'm going to save it. It says create alerting policy. I can go ahead and click create alerts if at all that goes down. So App Engine uptime check, conditions, trigger a percentage series violate, number of time series, or all time series violates. So what is that? I'll say the first one, at least 5 gets failed, get me alert, okay. I'll just save it. So that is the condition which we have configured, and then it will say what do you want, right? I want email, and I should get the email. For those, add notification. So this is my email. I can say, hi, please look into engine service. This is the message which that person will get it. Name of this particular policy, I say GAE, app engine instance check. So I have created the uptime check policy. Let me go ahead and disable application. So application is disabled. Okay. So after some time I should get the email. So after some time I should get an email from Stackdriver. Okay. Let's wait for the email. So you can actually see here the instance has been created. The machine is off, means the service is off from last some time, like around 10 minutes. You can find this instance, right? So you go ahead and say acknowledge so that you understood. So others will get to know that, yeah, you acknowledged it, someone is working on it. So acknowledged by whom, right? You can actually create an event by yourself that the work is going on, a maintenance window, right? And let's actually go ahead and explore more about alerting, uptime check, and dashboards in the next demo. Thank you. So let's go ahead and finish our theory. So in Stackdriver monitoring, our Stackdriver account actually provides control to Stackdriver features and billing account. A Stackdriver account can be a single GCP project, or it can contain multiple GCP project, and we saw that you can connect multiple GCP project to it. And AWS account, you can have any number of Stackdriver account if you want. There is no limit on it. Usually Stackdriver offers basic and premium service tiers for each Stackdriver account. There is no charge for basic tier, but there is some limit on the Stackdriver functionality that you can use it. But Premier is chargeable. The resources that are chargeable only if they are running or in runnable state. Okay, so GCP resource which are chargeable, each app engine standard environment instance running or not idle, each compute engine VM instance, each container engine node instance in the cluster, each cloud SQL instance. In AWS, you have EC2 VM instances, Elastic Load Balancer, Elastic Cluster, RDS instance, SQS queues, or SNS topic, or DynamoDB table. If you look at the pricing, only for Stackdriver monitoring, I have the detail map for all the services. Price basic tier, free. Premium tier, you have 8 per chargeable resource per month, prorated hourly. So if you are using Stackdriver monitoring premium tier for say 2 hours, you will be prorated only for 2 hours, and it will be somewhere around in fraction of seconds. Supported clouds, GCP only for the basic tier. For premium, you can have GCP as well as AWS. Log allotment 50 GB per project per month. In Premier, you have 50 GB per project per month plus 10 GB per chargeable resource per month. Log retention period, audit log 30 days, other logs 7 days. In case of Premium, audit log you can store it for 30 days, otherwise other logs also you can store it for 30 days. Metric allotment, you do not have any metric allotment defined, but in premium tier you have 500 series per chargeable resources and 250 metric type per project. Metric data retention, In basic tier you have 6 weeks, in premium also you have 6 weeks, and then after you can either store it in cloud storage or you can inject that in BigQuery. Alerting policy, some limitations are there. There are no limitations in premium tier. Stackdriver VM agent, you can actually have VM agent installed here. In premium tier you can have logging agent as well as monitoring agent. So Stackdriver error reporting, debugger and trace is for GCP services, and in premium tier you have GCP as well as AWS if supported that particular service. Okay, mobile application included, and I have put forward one UI screen that I got it for the instance. So in my application, what it says is uptime, it has been breached. Check GCP project this. Okay, so this particular app instance GAE is failing. It says continuously 8 minutes now, and this is particular URL. So this is from my mobile, the instance which was created some time back. So you will have mobile support as well. You can have monitoring filters which you can incorporate, or you can create an incident reporting. So you put forward conditions, and that's what we did it. You will have incident created and you will get the notifications, or you can take actions like acknowledged, and you can restart the app engine or take any other actions. So using monitoring filters, you can retrieve time series data, you can define resources in a group, list group members. So you can create a specific group and monitor that particular resources, and you can define multiple resources in that particular group. You can list metric descriptors, you can list monitored resources descriptor. I think that's it for Stackdriver monitoring. If you have any question on Stackdriver monitoring, let me know. We can get in details of all those in common demo section, where we will go through monitoring, logging, all of that service together. Okay, but if you have any questions on whatever we covered on Stackdriver monitoring, let me know. Otherwise you can move to the next service. Thank you. Stackdriver logging. You can store, analyze, search, monitor, and alert on the log data and the events from GCP as well as AWS services. So again, like monitoring, logging is also a multi-cloud service that we can use it. So what is it used for? You can actually do log management with Alert. You can have Splunk and log entries integration. It is integrated with GCP and service like BigQuery, and you can have it on AWS as well as GCP. Some of the features, you can have real-time, almost real-time log management analysis, seamless resolve the issues, looking at the logs and work effectively to resolve them. It is scalable and fully managed service. You don't have to manage any resources to do the logging. All your cloud logs in one particular place rather than spread across multiple applications, and you can get real-time insights on what is happening on the instances or the services, cloud services. Some of the features, you can have custom logs, ingestion APIs. You can have AWS integration with the agent. You can have log retention up to 30 days. Longer period can be used cloud storage, so you can store the log in cloud storage and again do analysis on it. You can do log search. You can have log based matrices created. You can do alerting based on the logs. You can have advanced analytics with the BigQuery, so the data which is stored in the big cloud storage, as well as you can think of data which is stored in BigQuery. Archive with the cloud storage. You can stream log with PubSub streamer. You can have Splunk and log entries integration as well, and you can do audit logging as well. And we are going to see audit logging in the next section, but yeah, you can do audit logging as well. High level concepts. So you need to have a project for logging, which is like Stackdriver logging, and that project can be shared across all your resources project or AWS projects. Log entries, the individual entry which is there in the logging, that is logging entry, and it has got defined set of attributes which we can use it to define different matrices around it, and you will have logs. You have a retention period attached to the log entries, and based on that the logs will be deleted. Like log retention is 30 days, and there are different logging for different type of retention period for different type of logs. You have monitored resources again here, so the resource from which you are pulling the logs out. You have filters, and you can apply different filters to get the dashboards or the reports out of logs. You can export the log using the sinks, and sink can be your cloud storage bucket or your PubSub or your BigQuery. You can have log based matrices, and those metrics are created. You can create it from the UI itself. And you have audit logs. Those audit log is based on, you can think of when the resource is getting created or someone is trying to access the resource, and you want to put forward some logs there, because we want to make sure that right people are getting right service or system access, and not some people trying to access a data which is not accessible by them. You can actually get that monitored as well. You can have access control logs. You have different service tiers, and you need to have Stackdriver account, as we said. So why we use typical logging, or the logging which is there in the Stackdriver? So Stackdriver logs, right? You can have Stackdriver logs. Stackdriver logging receives, index, and store the log entries from many sources, including the Google Cloud Platform, Amazon, AWS, VM instances running Stackdriver logging, which is with the fronted agent, and any other user applications. So all log entries in Stackdrivers are represented using single type log entry, and that is very important. And you can define the keys around it and get the statistics out of it, which defines certain common data for all the log entries, as well as carrying individual payloads. Exporting log, you can actually go ahead and export the log. So you need to have sink to export the log. So where you want to export it. The process, once you configure the sink, all new entries will start exporting that into the sink. Not the old one will be exported. Depends on type of sink. Either it is batch or near real time, like PubSub, right? Cloud storage is in the batch. You can probably check if the cloud storage account has access to cloud storage, BigQuery, or PubSub configuration, because that is what it is required for you to push the logs inside those sinks. Type of logs, you have audit log, which is like admin data access or the control log, and we are going to see this again in the next section. You have agent log, you have logs available in Stackdriver logging. And there are some standard information about App Engine. You have audit log, App Engine flexible. You can get the audit log. The agent log, you can get it from the compute engine. But yeah, that's the typical the use cases, what type of log available from which service, but you can have your own application log as well. Logging pricing, this is the high level pricing that we have. We have free alertment, which is like 50 GB per project per month, but there are overhead charges like 50 cents per GB, and this is an optional if you go for premium tier, right? Free logs, cloud audit logging, these are like loggings which are excluded from the log alertment, and you will not be considered under the 50 GB alertment. The more, if you want to look at the logging, probably you can go to App Engine logs or Compute Engine logs or logging agent filters, which we use it, Stackdriver agent, Stackdriver account in details. But let's go ahead and get into the demo or the overview of Stackdriver logging. Let's go ahead and get in details of the console right now. For Stackdriver logging, you can go Stackdriver logging from multiple locations. One is you can go to your individual service, like here in App Engine, and you can go directly into logging from there, or you can go from Stackdriver logging directly, right? Uh, so there are multiple ways, right? Or you can actually go to say Stackdriver monitoring UI and click on logging and select yeah. So there are multiple ways you can reach to Stackdriver logging. When you go to Stackdriver logging in the UI, you will be presented with different options, right? You can go ahead and create metric. You can go ahead and export, or you can go to logs, log-based metrics which are available out of system, or you can define your own. You can export it, and you can do log ingestion as well. Okay, so let's go back. Coming back here, you can choose different services. Okay, let me go ahead and go here, and I have application. I can choose specific service, and I can choose different instances to pull the log out. So currently this particular instance is serving 100% of my traffic. I can go here and select one of the other instance. There were no traffic last 1 hour. I can go ahead and see no limit, and there are this logs which are available for that particular instance. I can go and choose the application which is default service and this particular version now, and you can see the logs which are there right now for last hour. So there are these logs. Let's go ahead and create some traffic there. So I'm just calling the endpoint for the logs, and log will appear here. Either you can click load newer log, or you can just click this one, the stream logs in, and as and when you are creating traffic on the app engine, all the logs will start appearing in here. Okay, so that's a good thing. I'll go back. So you can go from here, or you can go from application, or you can go from Stackdriver directly. So here we are. You can create different metrics for your application, but it will create based on whatever you have chosen right now. So if I need to create, say, metric based on my virtual machine, I can say no limit and load all the logs which are there in the virtual machine, right? So I can create whatever I have selected right now. I can create a metric for that. So create metric, VM virtual machine. I can add labels if I need to. I can put forward units, counter, or distribution. I will just go ahead and create by default. And you will find actually the metric is created right now for GC instance. I can just go ahead and edit this particular metric, or I can delete the metric, or I can view the logs in the metric, or I can just go to the Explorer, metric Explorer. Let's go one by one. So let me go here and view logs. So these are the logs which are right now available. I can put forward different numbers here to jump those logs. Okay, and you can download more and more logs if there are available. I do not have any instance running right now. I can download this log, and there are multiple options available. You can do that with JSON or CSV format, view in a tab, or you can click download. I would say I want to view in a tab. So the tab will open and the JSON is there for that particular logs. So that's the download option. I can create and download, and the file will get downloaded here. Okay. I can expand all. logs, and you can see the JSON for that particular individual log, what is there, what it is, what is it is for, stream, standard error, log, and what is that particular error is. Likewise, I can choose different log-based metrics which are available right now. So monthly byte ingested for billing. You can go ahead and view metric in Metric Explorer. So interval, 1 minute interval, that is what it says. I want to see for 1 month. And you can find the data. Right. So what I can do is I have this metric. I can go ahead and apply filters if at all you want to have it. I'll just choose this particular project, and then I can explore in different modes. I can put forward thresholds and define it there. I can put a stats there, maximum, minimum. Okay, so you can actually explore the logs based on the way we want to have it, right? And then share by URL. You can share it by URL or view as a JSON format. So this is what it is, and we saw that you can have monitoring based on the dashboards, and we saw this dashboards created the last time. Going back again to logging, you can create metric, you can export the log. There is no sync configured, so you can export it to any desired service. So where you want to export it in BigQuery, cloud storage, or cloud PubSub, and this is using PubSub. You can actually stream the logs. So let's go ahead and do one of this particular export in the next demo. Thanks. So I can go ahead and export the logs. I can create export here. So let me choose App Engine because that is the service which is running right now. Google App Engine. Where is that? So I have these logs. I can go ahead and sync PubSub and App Engine. Select destination. I can create PubSub. If I choose PubSub, then it says choose topic, right? I can just use one of the existing topic, or I can create the new topic. Let me create the new topic here. My log topic. Okay. And then I can create sync. So sync is created. I have the topic now, which I can use it to pull that information. Okay, let's go ahead and go to console and pull the information. So we saw already in Cloud PubSub, you can actually go ahead and use the command gcloud PubSub subscriptions, and you can pull it. Auto acknowledge, and I need to give the topic here, right? So my topic is my logic topic, my log topic, my log topic. So what it says, resource not found. So why it says not available? So let's go ahead and see if PubSub is created just now or it is still waiting. Go to PubSub. Oh, okay, I need to create a subscription for that. So let me go ahead and create. Subscription, create. So I need to create a subscription. Minus topic and subscription for this one, my log topic. Subscription sub log. Okay. Subscription is created. So let's pull. Yeah, here you go. We have the messages which we pulled it, and these are the log messages which we have it. Then you can pull one by one message out of it. So you can actually see the logs are inserted continuously, and you can have PubSub, and you can get the logs on the into PubSub. Alternatively, you can put the logs onto cloud storage bucket. So let me go ahead and create a bucket, my bucket logs, and create. So all the log will be synced into cloud storage bucket. Okay. So let me update sync. So sync is updated now. You can go to cloud storage bucket. So creating some logs. So this is my destination. If you look at, if I go to cloud storage bucket, go down into storage. Why I need to search too much? Okay, yeah, here you go, cloud storage bucket. You can see my bucket logs. So it is not yet appeared here. It will take some time to logs to come here. Usually it takes 5 minutes to log appear here. You see it, I just hold it on for some time, and then you can see there are logs. There are different kind of logs which are here, which gets inserted into the logs. And we saw how you can actually sync the log in multiple data destinations. In storage bucket, we have seen this one. It's not appearing any log here. It will take some time for us to see the log here. If you look at here, in this bucket, let's go ahead and identify if there are any logs synced. Yes, there are logs synced here. App engine, standard error, standard out. You can go one up that log, standard out, 2019 year, month, day, and you can find all these logs. You can click here and you can see the details of the log, whatever it has been incorporated. It's in JSON format. That's what we said. We want to sync it in JSON format. So you will have actually these logs here. What you can do is you can have create lifecycle policy, which will delete these logs after say 30 days. like age, uh, 30 days if you want, or I would say 90 days. What you can do is either you can do a state change or delete it. Continue and delete it. So after 90 days, these logs will be deleted. So you will not have a considerable amount of charges from cloud storage bucket. That's all, guys, for storing log in cloud storage. If you have any questions here, let me know. Otherwise, you can move to the next lecture. Thanks. Optimizing network resources. Let's go ahead and get into the details of how you can optimize the network resources. It is, you can think of more, it is like the sense which we got it until now. Just apply that particular sense to optimize the network traffic and cost. The objectives for this particular section is optimizing traffic flow, and the second one is optimizing for cost and efficiency. Let's go ahead and get into it. Optimizing traffic flow. That lowers latency and cost. There are multiple topics here, and we need to consider different aspects of reducing your latency or the traffic. The first one is the load balancer. Load balancer is, as we know, the HTTP load balancer is, or the global load balancers are not specific to a region or a zone. Majority of those load balancers, or at least Google load balancer, is global in nature. So it sits in your edge locations, and it has got intelligence enough to route your traffic to nearest location, nearest backend location. As an example, if your services are located in, say, US West or US Central or US East, your services or the customers from US East will be routed to the nearest location, which is US East backend services, and that is what it is called as intelligent routing, which is taken care by the load balancer. The CDN, right? We already saw CDN. The main purpose of the CDN is to cache the content, the static content, which does not get changed very frequently. So once you cache it in terms of, say, images or videos, right? If you cache it, the content will be served from the edge locations or the point of presence location, right? POP locations itself. It will not come back to the backend VM instance or the cloud storage bucket again if the instance is there and it is current. So that is, you can think of how you can optimize your traffic flow or reduce your load on your backend services. There are multiple rules here. Again, global versus regional dynamic routing, and this is again very important when you create networks. You can configure what is that you want to do it. So global routing means you are actually routing the services globally, irrespective of whether it is whether all the services are located in one particular region and zones. It will try to route it globally. So when you have service or the backend services which are located in your one particular region and zone, or you can think of multiple zones inside one particular region, then just tick that particular box on to select a regional dynamic routing only, right? If at all there are services which are spread across the globe as a backend, then definitely you want to go global. Expanding subnet CIDR ranges in service. This is again very important topic. You can go ahead and change the subnet CIDR range if you need to expand, because as an example, initially you thought that you in a one particular zone you need less number of devices. Devices means the virtual machine instances which you have not estimated correctly. You can go ahead and expand those subnet ranges, CIDR ranges, to add in more and more VM instances or any backend services, whether it is Kubernetes or whether it is private Kubernetes or whether it is App Engine instances, right? So you can add more backend instances there, expanding your CIDR ranges. Accommodating workload increases, auto scaling versus manual scaling, and this is again very important. Google Cloud Platform provides auto scaling or the manual scaling based on what you are using it. As an example, your workload in a typical day goes high at around say 8 o'clock, because that's where your business gets started or your shops are opened to serve your customers, or typically that is the time when you think that your customers are using it, right? So, and it goes down over a period of time, like after 3 o'clock it goes down, the load continuously goes down. What you can do is you can configure auto scaling policy, so all of that load increase and decrease will be taken care automatically by your load balancer. So, and this is very important aspect, because nowadays cloud does not charge you on a yearly contract or monthly contract or a hourly contract. It actually starts with initial some minute and then per second billing, right? This really help for you whenever your resources are not used. You can actually configure auto scaling policy accordingly and reduce your cost, as well as look at the aspect wherein you can pre-warm some of the instances when the load is about to get start, right? So you can configure different policies there. You can have some manual scaling as well for your resources, which you think that you can manage it manually, because you think that there is considerable amount of hits going to come at around 8 o'clock. You can scale it at 8 o'clock, you can manually scale it to the higher numbers. So these are the consideration which you can think, and how you can optimize your traffic, how you can optimize backend resources. Let's go ahead and get some sense of cost and efficiency in the next lecture. Optimizing it for cost and efficiency. We already saw one parameter, and that was auto scaling, right? Auto scaling of backend services, and that's a configuration on HTTP load balancer, and there are multiple options you can do it for other compute services other than the compute engine. There are two different aspects here. The first one is the network service tier, and this is what Google differentiate it from other cloud vendors, right? Google has a huge amount of backbone or network, fiber optic network spread across the globe, and there are 100 plus locations using which you can actually connect to that, and you are inside Google private network. So initially they had this particular service which was used by all the customers, and this is very important, right? Now what they have come up with is they have created two different tiers. One is their own network, and that is their power. But the second network which they have created is not the premium network, the simple network. And you can, when you are creating your instances, you can, or the network, you can actually mark that as what you want to use it, whether you want to use the basic tier or you want to use premium tier. Premium tier means their own private network or fiber optic network. All the connections or all the data from, if you use premium tier, will get into Google network near to your user's location and will not leave. So it will try to use as much as they can use their private fiber optic network. In case of basic network though, your services actually, or the traffic leaves your the backend service near to the backend service. And you can think of, if at all there are servers which are there in London data center, and if you have some users in say Johannesburg in Africa, South Africa, what will happen is, if the customer is using or the company is using basic tier, what will happen is your basic service traffic from London will leave the network very immediately in UK itself and use public internet to come to South Africa. If you use say premium tier, it will use all the way up to Johannesburg as a fiber optic network, because they have point of presence in Johannesburg, and then it will be routed or leaves the Google private network to a public internet. So this is two different aspect here. There is a definitely cost impact using basic network, basic tier versus premium tier, and you need to consider what is that it is useful, how important that particular traffic is for you, and based on that you take a decision. Cloud CDN, we already saw it is very important to reduce your load from backend services, but Cloud CDN is not a free service. Whatever data you cache it on the edge locations, you will be charged for that particular data usage. There are charges for cache fill, cache hit, right? So you need to make sure that you account for all of that when you are enabling Cloud CDN. But definitely it is less expensive than supplying the data from the backend service, whether it is your VM instances or your cloud storage bucket. You can configure autoscaler for your backend services, and that's how you can optimize the cost. You can actually do automation in case of elasticity or scaling without actually manually doing it by your own. For interconnect, you have different aspect, and we already saw that which one to use for what purpose. But typically when you have connection less than say 5 GB or 3 GB, right, pipe, that's where you can go ahead and just use VPN connections. If at all you need temporary or you need additional scaling, you can add in many more tunnels, but that is the cheapest option that you have. If at all you have the bandwidth which is more than 10 GB, then you can, and you are available in Google's interconnect location, just go ahead and do the connection with the Google directly. If at all you are not, you need more than 10 GB, but you are not there in the Google's POP location, what you do is you go with the partner, and that is how you can optimize your cost. So there are different parameters. We already saw VPN and interconnect in hybrid interconnection. The lastly, you can have a kernel parameter, because even though, say as an example, you have a considerable amount of bandwidth which is provided by Google's SDN, but at the same time you need to go ahead and modify the Unix kernel parameter as well to use that bandwidth, and that is very important in terms of utilizing proper bandwidth, whatever it is available to you. And that's it, guys, on optimization side. If you have any questions here, let me know, or you can actually go to the next summarization lecture. Thank you.